And I am profoundly delighted to take an opportunity to introduce uh, the chief guest for the day, who could not make it physically, but then because he's abroad, but his video address is with us, Sri Nitin Gadkari ji, who is Honorable Union Minister for Road Transport and Highways. And well, once again, I welcome you to the land of gods, Uttarakhand, also known as Devabhoomi. And this Devbhoomi has been the center of religious and spiritual knowledge for ages. The history and culture of Uttarakhand are deeply connected with religion and celebrated everywhere. Many cultures and ethnicities coexist here with peace and harmony. Most of the state is divided into two regions named Garhwal and Kumaon. And it is also home to the Jaunsaris, the Tibetan refugees, Bukshas, and among others. Well, Uttarakhand's people are proud of their culture and heritage. It houses people from many subgroups and ethnic groups together under one roof, which is the beauty of the state of Uttarakhand. Well, presenting before you the schedule of 2 days program, here I go. We have the inaugural session first, followed by the design and construction, operation, safety, and maintenance parallel sessions. We have the conceptual planning and design for road tunnel session, wherein the presentation on planning and design of road tunnels in Himalayan region will be executed by Mr. Rahul Gupta and Mr. Shwetab Singh from India. Presentation on NATM tunneling instrumentation monitoring by Mr. Harold Wagner, consulting engineer, Thailand. Presentation on computational methods for design of tunnels by Dr. Aditya Singh, Assistant Professor, IIT Roorkee. Whereas this session 2, ventilation and fire protection, the first presentation will be on ventilation systems and strategies for mountainous regions, taking the Austrian Alpine tunnels as an example. And this will be presented by Mr. Peter Sturm, Graz University of Technology, PRC, TC 4.4. WG4 leader, Austria. The second presentation will be on particularities of ventilation design and installations in high mountain tunnels by Mr. Frederick Wemel, PRC TC 4.4, WG4 member, France. Followed by the presentation on fire protection by Mr. Nalin Doshi, Wimel Fire Controls Private Limited, India. Followed by the lunch break, and thereafter we'll have the presentation on execution of India's longest TBM tunnel project in the tough Himalayan terrain for RVNL by Mr. Christopher Cooper, Austria, and Mr. Rakesh Arora, LNT. The second presentation will be on permanent lining material for tunnel by Mr. Harold Wagner, consulting engineer, Thailand. And presentation on TBM tunnels, inclusive instrumentation and monitoring by Mr. Nitin Garg, Director Business Development, Haranict India Private Limited. Thereafter, we'll have the session 3rd on sustainable road tunnel operation, wherein the first presentation will be on sustainable road tunnels and how small decisions during planning phase can impact the operational costs during tunnel life cycle, which will be presented by Mr. Ricardo Miranda, PRTC 4.4 member, ITA COSUF member, Brazil. Followed by the presentation on the way to sustainable and efficient road tunnel operation by René List, PRTC 4.4 member, Austria. The third presentation will be on sustainable road tunnels by Mr. George, PRTC 4.4 member, Australia. Followed by a tea coffee break, and then there'll be the session number 4 on geotechnical and geophysical investigation, wherein the first presentation on tunnel investigation model methodology, the best practices, challenges, impact on design, time, and cost overrun will be presented by Dr. Dinesh Chandra Tripathi from India. Presentation on geomechanical investigations for long tunnels in mountainous area by Lucy Rio, HSITA member, UK, on behalf of Bernard Falconet. Presentation on geophysical investigations for identification of Planning of Road Tunnels in India by Dr. Subhash Chandra, NGRI, India. Then the other session on safety issues, the first presentation will be on intelligent lighting control, not only for safety and energy savings, by Mr. Pierre Longton, PRTC 4.4 member, Canada, Quebec. Followed by the presentation on self-evacuation process, reduced mobility users by Mr. Hélène Monquiot, PRTC 4.4 and ITA COSOF member, France. Followed by the presentation on new digital approaches for safe operation of tunnels by Mr. Eril Sovik, PRTC 4.4, and ITA COSOF member, Norway. And of course, we have the cultural program for you people in the evening, followed by the dinner. So this is all about the today's program, minute-to-minute program. And talking about tomorrow, because this international conference is for 2 days. So the second day, the first session will be on contractual issues and risk management, wherein the first presentation will be on extraordinary geological occurrences and contractual issues, presented by Mr. Arnold Disk, President ITA Australia. The second presentation will be on challenges and risk management, tunneling and underground structures by Colonel Parikshit Mehra, BRO, India. The third presentation will be on risk management plan for underground road tunnel by Mr. A.K. Srivastava, ADG retired, Ministry of Road Transport and Highways. The next session will be on the risk management in the seminar hall, first floor, Vishwakarma building. Presentation on risk-based decision making in tunnel safety by Mr. Bernhard Kohl, PRTC 4.4 member, Austria. Followed by the presentation on implementation of safety management systems, an innovative approach dedicated to safe road tunnels operation by Mr. Hélène Monquiot, PRTC 4.4 and ITA COSOF member, France. Followed by the presentation on impact of new energy carriers on tunnel design and safety by Mr. Peter. Followed by the tea break. And then we'll have this session number 6 on the case studies on road, rail, tunnel projects part 1. And this will be held again at the same venue. The presentation on execution of India's largest TBM tunnel project in urban environment for Municipal Corporation of Greater Mumbai. MCGM, that's Mumbai Coastal Road Project, and this will be presented by Mr. Sandeep Singh and Mr. Sanjay Bajni, L&T India. The second presentation will be on NHAI tunnel experience, overcoming extremely challenging geological condition in Ramban, Banihal, JNK, and Pando, Takoli, HP, Himachal Pradesh by Mr. Amarendra Kumar, CGM, NHAI. The third presentation on 57 kilometers railway tunnel between Lyon and Turin under the Alps by Lucy Rio, is HSITA member, UK. And then the session number 6, the other session number, 6B, part B, will be on the case studies on road tunnels projects, part 1, which will be held at the first floor of the Vishwakarma building. And the first presentation will be on Kashidi Tunnel, a greenfield tunnel with viaducts, and this will be presented by Mr. Parveen Dongri, ILF India. Followed by the second presentation on best practices to install fixed fire fighting systems for road tunnels, and a case study by Max Lekinen, IFAB, GmbH, ITA, COSOF, Germany. And the third presentation in this segment will be on Sao Paulo firefighting strategies by Mr. Ricardo Miranda, PRTC 4.4 member, Brazil, followed by the lunch break. Wherein after that we'll have the next session on the case studies on road, rail tunnel projects part 2, and wherein the first presentation will be given on design concept of road tunnel against earthquake in Japan. And this presentation will be presented by Mr. Nobuharu Isago and Kusako Atsushi, PRTC 4.4 member, Japan. followed by the presentation on long subsea tunnels by Mr. Eril Sovik, PARC TC 4.4, ITA course of member Norway, followed by the presentation on Zojila Tunnel by Mr. Atul Kumar, Director Terminal NHIDCL, followed by the third segment of the session will be on case studies on road tunnel projects part 2, wherein the first presentation will be on Annie Cordy Tunnel refurbishment and modernization of the Brussels Road Tunnel Control Center by Mr. Arthur Kabua, PRTC 4.4 WGI leader Belgium, followed by the presentation on storm water management and road tunnel Penang undersea tunnel by Mr. IR Chansai Chok, MD Parenting Eagles Engineers Malaysia, followed by the third presentation on road tunnels controlling in the center of Prague by Mr. Lucas, PRTC 4.4 members, Czech Republic, followed by tea, coffee, and of course the valedictory session. And day 3, which is like Friday, 21st of April, we also have technical site visit to Rishikesh, Karan-Prayag new rail line tunnel project. So, ladies and gentlemen, this was the brief about the program, the detail, the minute-to-minute program, which will be executed soon on an international seminar on advances in design, construction, and operation of tunnels, and to be held from 19th to 21st. And I have already discussed with you what all events, what all presentations will be going on. Well, people, the tunnel engineering is indeed one of the most interesting disciplines in engineering. And the work is complex and difficult throughout its course, even though it is interesting. So the tunnels are defined as the underground passages that are used for the transportation purposes. And these permit the transmission of passengers and freights, or it may be for the transportation of utilities like water, sewage, or gas, etc. And the operations and the constructions are carried out underground without disturbing the ground surface. So this operation is called as tunneling, which we all are aware of. And it is found, people, that the first tunnel was made by the Egyptians and the Babylonians 4,000 years ago. And this tunnel served the purpose of connecting two buildings in Babylon. So the connection was from the royal palace to the temple, and the length of this tunnel was found to be around 910 meters, which was brick-lined. Talking about the construction of the largest ancient tunnel, I would like to throw light upon this, that the largest tunnel in ancient times was constructed between Naples and Pozzuoli in 36 BC, and this tunnel was 4,800 foot long, 25 foot wide, and 30 foot in height. It was a road tunnel basically, and during the second half of the 20th century, the development and progress of explosives and sophisticated equipment were flourished that made the tunneling process more feasible. The tunneling worked better for different approaches under different circumstances, and it is hence dependent on the experience and the knowledge of the engineer, which is of the utmost importance. It is hence dependent on the experience and the knowledge, as I just mentioned, and mainly the tunneling works are carried out by the civil engineers, and this discipline will let us know that the knowledge on the structural and concrete technology is not sufficient. We just need to upgrade ourselves with the passage of time. An equal and thorough skill and knowledge on geology, mechanical engineering, geomechanics, and the new construction technologies are also very essential. So people, the two main factors that help in the efficient route of the tunnel are the alignment restraints and the environmental considerations. And the underground, as we know, is heterogeneous in nature. A proper inspection on the nature of soil, rock, the water table level, and all the alignment restraints had to be made before fixing the route. And the site chosen for tunneling is such a way that the inconvenience and the difficulty that is caused to the environment in that area, including the living, is very, very minimum. So people, the tunneling method chosen depends on the ground conditions, the water table level, the tunnel drive length, and the diameter, the tunnel depth, and final utility requirements, the shape of the tunnel, and the risk of the construction. So now talking about the advantages, which I'm sure that you people will be, giving your presentations about how we can, with the advent of time, grow better. The tunneling procedure is more economical in nature compared to open cut trench method when the depth is beyond a limit. And the surface life or ground activities like transportation are not disturbed when tunneling is undergone. So this is why we all would prefer this activity. And the method ensures high-speed construction with low power consumption. It reduces the noise pollution. And these methods have freedom from snow and iceberg hazards in areas of high altitudes. And the surface and air interference is restricted for the tunnels. While the provision of tunnels with easy gradients help in reducing the cost of hauling and for the transportation of public utilities, tunneling method has a remarkable advantage compared to the bridge. And of course, the dangerous open cut to a nearby structure when it is needed is solved by the tunneling method. And the tunneling, as we all know, grants greater protection in aerial warfare and the bombing conditions also. So thus, we all are aware of the basic advantages of the tunneling. But I just thought that through this platform, I should just interact because there are a few media friends of mine who are here. And I would just like to give you an overview of the conference about the subject matter. So basically, why do we actually use tunnels? And so here we're going to talk about the uses of tunnels basically. And these are used for the mining ores, for transportation, including road vehicles, the trains, subways and canals, and for conducting water and sewage. The underground chambers, often associated with a complex of connecting tunnels and shafts, increasingly are being used for such things as underground hydroelectric power plants or processing plants and the pumping stations, vehicle parking, storage of oil and water, water treatment plants, warehouses, and light manufacturing, also command centers and other special military needs. And trust me, people, that very soon we're going to start with this, with the inaugural session. But we'll have a chief guest on our way, and very soon we're going to start with this inaugural session. Well, I would just like to say that the two tunnels and chambers are excavated from the inside, as we all know, with the overlying material left in place and then lined as necessary to support the edges in ground. A hillside tunnel entrance is called a portal, which we all are aware of, and tunnels may also be started from the bottom of a vertical shaft or from the end of a horizontal tunnel driven principally for construction, access, and called an edit. So-called cut and cover tunnels, more correctly called the conduits, are built by excavating from the surface, constructing the structure, and then covering the backfill. So tunnels underwater are now commonly built by the use of an immersed tube. Long prefabricated tube sections are floated to the side and sunk in a prepared trench and covered with the backfill. So for all underground work, difficulties increase with the size of the opening and are greatly dependent upon weaknesses of the natural ground and the extent of the water inflow. So while talking about India is a country which is rich in culture and heritage, full of diversity, and here there are many, many tunnels. And India has close to 20 mountain rail tunnels, and they range from 11,200 meter Pir Panjal tunnel and 6 other tunnels that are between 4,000 to 6,000 meters. And these include one of Asia's oldest tunnels, the Parsik tunnel in Maharashtra. And the longest tunnels in India, rail and road tunnels, talking about them, is Pir Panjal Railway Tunnel, which is in Jammu and Kashmir. And the length of it's 11,215 meters, almost like 11.22 kilometers. And Dr. Syama Prasad Mukherjee Road Tunnel, which is again in Jammu and Kashmir. The length is 9280 meters, and that comes to about 9.34 kilometers. And Thiruvananthapuram Port Railway Tunnel, which is in Kerala, and the length is 9,020 meters. That comes to about 9.02 kilometers. So there are like the longest rail and road tunnels in India as well. Let me tell you people that railways and roads are the most common modes of transportation for the common man here in India. The country is known for its roads and railway tunnels, an affordable option to make places more accessible to people. And if I talk about the top 5 longest rail and road tunnels here in India, I would like to name the Atal Tunnel, Himachal Pradesh, as number 1, because this tunnel, formerly known as the Rohtang Tunnel, is a 9.02 kilometer long high altitude tunnel named after the former Prime Minister of India, Atal Bihari Vajpayee. And the construction of this tunnel began in the year 2010 and was completed and inaugurated on October 3rd, 2020. If I talk about the Pir Panjal Railway Tunnel, which is there in Jammu and Kashmir, this is the longest railway tunnel in the country, measuring 11.215 meters, that's 11.215 kilometers, and also known as the T80. Pir Panjal runs through the heart of the Himalayas and is set at an altitude of 36,795 feet, and this was inaugurated in the year 2013, and it takes a train approximately 9 minutes to cross the entire tunnel. Throwing light upon Dr. Syama Road Tunnel, Jammu and Kashmir, I would like to inform you that we have the Honorable Cabinet Minister, Public Works Department, Shri Satpalji Maharaj. Can we all give a huge round of applause for our guest, Honorable Cabinet Minister, Public Works Department, Government of Uttarakhand, Shri Satpalji Maharaj. We have General Dr. Vijay Kumar Singh Ji, PVSM, AVSM, YSM retired, Honorable Union Minister of State for Road Transport and Highways and Civil Aviation. I extend a warm welcome to the dignitaries present here. I would just like to inform you that Shri Nitin Gadkari Ji, the Honorable Union Minister for Road Transport and Highways, was not able to make it for the program today, but we have his recorded video address with us. And on dais we have General Dr. Vijay Kumar Singh Ji, PVSM, AVSM, YSM retired, Honorable Union Minister of State for Road Transport and Highways and Civil Aviation. We have Shri Satpalji Maharaj Ji, Honorable Cabinet Minister, Public Works Department, Government of Uttarakhand. Mrs. Alka Upadhyay Ji, IAS Secretary, Road and Transport and Highways, Government of India. She is there with us through the online mode. Then we have Shri Ravi Prasad Ji, Director General, Road Development and Special Secretary, Ministry of Road Transport and Highways. We have Shri R.K. Sudhanshu Ji, IAS Principal Secretary, Public Works Department, Government of Uttarakhand. We have Mr. Mark Henry, Vice President PARC, Mr. Patrick, Secretary General PARC. We have Professor Manoranjan Parida, Vice President IRC, Director CRI New Delhi. Shri R.K. Mehta Ji, Vice President IRC and Secretary. Shri Arvind Kumar Jain Ji, Shri Parnav Kapoor Ji, Vice President IRC and Managing Director. MSML Private Limited, Professor Arnold Dix, President ITA. Dr. Ingo Kondia Ji. And I extend my warm welcome on behalf of the Indian Road Congress to the International Seminar on Advances in Design, Construction and Operation of Tunnels. And this international conference is going to start from today and end till 21st. And of course, as we all know that we have the tradition of lighting of the lamp as the ceremony to begin the program. So I would request the honorable dignitaries to kindly come forward for the lamp lighting ceremony so that we can officially begin with the international conference. We can declare the international conference open. I would request General Dr. Vijay Kumar Singh Ji, I would request Shri Satpalji Maharaj Ji and all the dignitaries on the dais to kindly come forward for the lamp lighting ceremony. And this is why Uttarakhand is different. Uttarakhand is known as the land of gods, Devabhoomi Uttarakhand, and I extend my warm welcome to all the dignitaries present here and all of you as well. And as it's a tradition to go ahead with the lamp lighting, I would request the honorable dignitaries to kindly come forward for the lamp lighting ceremony, please. Can we have the Saraswati Vandana, please?
हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार दे माँ। हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार दे माँ। तू स्वर की देवी, ये संगीत तुझसे, हर शब्द तेरा है, हर गीत तुझसे। तू स्वर की देवी है, संगीत तुझसे, हर शब्द तेरा है, हर गीत तुझसे। हम हैं अकेले, हम हैं अधूरे, मेरी शरण में हमें प्यार दे माँ। हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार दे माँ। हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार दे माँ। गुनियों ने समझी, गुनियों ने जानी, वेदों की भाषा, पुराणों की बानी। गुनियों ने समझी, गुनियों ने जानी, वेदों की भाषा, पुराणों की बानी। हम भी तो समझे, हम भी तो जाने, विद्या का हमको भी अधिकार दे माँ। हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार दे माँ। हे शारदे माँ, 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 हे शारदे माँ। Thank you.
Thank you so much. Ladies and gentlemen, and all the eminent dignitaries on the dais, and all the presenters here who have come from various countries to make this event a big hit. Let me tell you that light is a symbol of brightness and prosperity. And as sunlight expels the darkness of mind, similarly, the blessings bring in our life prosperity and happiness. And that is why we invoke Goddess Saraswati by kindling the lamp of knowledge and wisdom. Can we give a huge round of applause for the dignitaries on dais, please? Now, in order to welcome the dignitaries on dais, at the onset, I would like to state that Shri Nitin Gadkari ji, Honorable Union Minister for Road Transport and Highways, was not able to somehow make it for this program, but we have his recorded video address with us, which will be played later on. But I, on behalf of the entire team, extend hearty welcome to the Honorable Minister. Can we all give a huge round of applause for Shri Nitin Gadkari ji? I would like to request Shri Ravi Prasad ji, Director General, Road Development and Special Secretary, Ministry of Road Transport and Highways, Government of India, to present the bouquet to General Dr. Vijay Kumar Singh ji, PVSM, AVSM, YSM, retired Honorable Union Minister of State for Road Transport and Highways and Civil Aviation. We welcome you, sir. May I please request Sri S.K. Nirmal ji, Secretary General Indian Roads Congress, to kindly. Can we all give a huge round of applause for Dr. Vijay Kumar Singh ji? And here we have the memento as well as a traditional welcome. May I please request Sri S.K. Nirmalji, Secretary General, Indian Roads Congress, to kindly welcome Sri Satpalji Maharajji, Honorable Cabinet Minister, Public Works Department, Government of Uttarakhand. A hearty welcome to you, sir. Well, it is under the Cabinet Minister's guidance that our state is really doing well in this particular sphere. And I would like all of you to give a huge round of applause for our Cabinet Minister, Sri Satpalji Maharajji. Well, I would like to announce that Mrs. Alka Upadhyayji, IAS and Secretary, Road Transport and Highways, Government of India, is there with us through the online mode. And I extend my hearty welcome to her. Can we please give a huge round of applause for Mrs. Alka Upadhyayji? Moving ahead, I would like to call upon Shri D.K. Yadavji, Engineer-in-Chief, Public Works Department, Government of Uttarakhand, to kindly welcome Shri Ravi Prasadji, the Director General Road Development and Special Secretary, Ministry of Road Transport and Highways. We extend our hearty welcome to you, sir. Indeed, it's a great privilege to have such epitome of knowledge on dais. We extend our cordial welcome to you, sir. May I request Sri A.K. Jainji, Vice President, Indian Roads Congress, to kindly welcome Sri R.K. Sudhanshuji, IAS, Principal Secretary, Public Works Department, Government of Uttarakhand. We extend our cordial welcome to you, sir. So here we have the bouquet, the shawl, and the memento for our honorable dignitaries on dais. And it's a real honor to have such people on board with us, through whom we all will be enlightened for 3 days. Can we... Thank you so much. Moving ahead, I would like to invite Sri Deepak Sharma ji, Chief Engineer, Ministry of Road Transport and Highways, to kindly welcome Sri S.K. Nirmal ji, Secretary General, Indian Roads Congress. Can we have a huge round of applause for Sri S.K. Nirmal ji? We extend our cordial welcome to you, sir, and it's a real honor to have you with us today. I would request Sri Deepak Sharma ji, Chief Engineer, Ministry of Road Transport and Highways, to kindly welcome Mr. Mark Henry, Vice President, PIARC, World Road Organization. I would request Sri Deepak Sharma ji to kindly welcome Mr. Mark Henry, Vice President, PIARC. We extend a cordial welcome to you, sir. And it's indeed an honor that under one roof we have people from various countries through whom we all will be enlightened. A hearty welcome to you, sir. I would like to call upon Sri Rahul Gupta ji, Chief Engineer, Ministry of Road Transport and Highways, to kindly welcome Mr. Patrick. I would request Sri Rahul Gupta ji to kindly welcome Mr. Patrick, Secretary General, PIARC. Can we have a huge round of applause for Mr. Patrick? It's indeed an honor for all of us to have you with us. May I please request Sri Rahul Gupta ji, Chief Engineer, Ministry of Road Transport and Highways, to kindly welcome Professor Manoranjan Parida, Vice President, Indian Roads Congress and Director, CRRI, New Delhi. Can we give a huge round of applause for Professor Manoranjan Parida, Vice President, Indian Roads Congress and Director, CRRI, New Delhi. We extend a warm welcome to you, sir. May I please request Shri Puran Singh Ji, Superintending Engineer, Ministry of Road Transport and Highways, to kindly welcome Shri R.K. Mehra Ji, Vice President, Indian Roads Congress and Secretary, MP, PWD, Bhopal. I would request Shri Puran Singh Ji, he is the Superintending Engineer, to kindly welcome Shri R.K. Mehra Ji, Vice President, Indian Roads Congress and Secretary, MP, Public Works Department, Bhopal. We welcome you, sir. May I request Shri Puran Singh Ji. I request Shri Puran Singh Ji to kindly welcome Shri Arvind Kumar Jain, Vice President, Indian Roads Congress and Engineer-in-Chief, Design and Planning, Public Works Department, Government of Uttar Pradesh, Lucknow. We welcome you, sir. And indeed, the 3 days international seminar on advances in design will be a big hit because we all will be enlightened by such dignitaries. I would request Shri Puran Singh Ji to kindly welcome Shri Parnav Kapoor Ji, Vice President, Indian Roads Congress and Managing Director, MSML Private Limited, New Delhi. We welcome you, sir. Can we have a huge round of applause? May I request Shri Rahul Patel Ji, who is the Deputy Director, Indian Roads Congress, to kindly welcome Professor Arnold Dix, the President, ITA. It's an honor for all of us to have you with us today. Can we have a huge round of applause for Professor Arnold Dix, the President, ITA. Moving ahead, we have, I would like to request Shri Ramshid, the Executive Engineer, Ministry of Road Transport and Highways, to kindly welcome Dr. Ingo Kondia. Can we have a huge round of applause for Dr. Ingo Kondia? It's a real honor for all of us to have you with us, sir. Welcome to Uttarakhand, welcome to the land of gods. Thank you so much. Well, the International Seminar on Advances in Design, Construction and Operation of Tunnels, I, Dr. Kanchan Negi, extend a warm welcome to all of you once again. Can we have a huge round of applause for each one of you present here? Taking the program ahead, I would just like to read a few lines about Shri Sanjay Kumar Nirmalji, who is the Secretary General, Indian Roads Congress. Shri Sanjay Kumar Nirmal joined Ministry of Road Transport and Highway in 1986 as Assistant Executive Engineer through CES Roads and worked on various capacities and elevated to the position of Director General, Road Development and Special Secretary to the Government of India, Ministry of Road Transport and Highways on 12th July 2022. He has worked as General Manager during 2003 to 2009 and as Chief General Manager during 2009 to 2010 in National Highways Authority of India. Shri Nirmal is serving Indian Roads Congress as Secretary General with effect from April 2017 till date, and he was also the chairman of Indian National Group of International Association for Bridge and Structural Engineers. Shri Nirmalji graduated in BE Civil Honours in 1983 from Malviya National Institute of Technology, Jaipur, and MSc Road Engineering in 1998 from Delft University of Technology, IHE, the Netherlands. He also completed MBA from R.R. Poddar Institute of Management, University of Rajasthan, Jaipur. Shri Nirmal has participated in 35 days training program on highway maintenance at Japan in 2001, workshop on road safety in Asia held at Manila in the year 2017. He was member of Indian delegation at 75th session of WPI Working Party meeting of UNICEF. Now, to take the program ahead, I would kindly request Shri Sanjay Kumar Nirmalji, Secretary General IRC, to kindly come forward for the welcome address. Can we all give a huge round of applause? Thank you.
Good morning. Honorable Minister for Road Transport and Highways, Sri Nitin Gadkari ji, who is today abroad and has sent a recorded message for the success of the program, and always he was an inspiration for this program. Honorable Minister of State for Road Transport and Highways, General Dr. V.K. Singh ji, PVSM. Minister of Public Works Department in Government of Uttarakhand, Sri Satpal Maharaj ji. Secretary Road Transport and Highways, Madam Alka Upadhyay ji, who is present online, who could not come because of certain exigency of work, physically here. Principal Secretary to the Government of Uttarakhand, Sri Sudhanshu ji. Vice President, World Road Association, PIARC, Mr. Mark Henry Rubrenja, because President PIARC, Mr. Nazir Ali, could not come because he had some urgent engagement. Otherwise, yesterday he was here, but he had to go. So Vice President PIARC is here with us. President International Tunneling and Underground Space Association ITA, Professor Arnold Disk. Secretary General World Road Association PIARC, Mr. Patrick Maljek. Then Chairman Tunnel Association PIARC, Mr. Ingo Cornelia. Some dignitaries sitting in the opposite side, that is Chancellor DIT University, Mr. N. Ravi Shankar, who is here. Then Pro Vice Chancellor, then other dignitaries present here, ladies and gentlemen. I feel honored to welcome you all to this International Tunnel Seminar on the advances in design, construction and operation of tunnels. We have gathered here today from all around the world to share our expertise, knowledge and experiences in the field of planning, design, construction and operation in tunnels. We recognize that technology has become an increasingly important driver of progress and prosperity in our interconnected world. Technology has the power to transform our lives, our societies and our economies, and to create new opportunities for growth and development. Topic of this international seminar is very important for Government of India. And in India, we are focusing on construction of numerous road tunnels, railway tunnels, metro tunnels and hydro tunnel projects under aegis of respective departments, ministries, and we have the representative of various ministries present today in this seminar. For National Highway alone, almost 192 kilometer length of DPRs are already in pipeline. So we have a huge scope for the marketing of tunnel professionals, and they have lot of work in India for tunnels. And we all know that tunnels have played a critical role in development of modern society and infrastructure connectivity. They have enabled us to connect cities, regions, and tough terrain to transport people and goods and to create new opportunities for economic growth and development. The tunnel construction process is very complex compared with the construction of conventional road projects in plain terrain. We know that tunnel construction is having various issues, various uncertainties because of the various conditions of ground, geography, geology, and only there is one visible surface. So the rest of the construction is hidden and affected by natural conditions. Since last decade, we have seen drastic change in advancement in the machinery used for tunneling construction in India. However, one of the concern is about high cost of tunneling machine, outcome of the machines being imported, and the maintenance support of these machines, which is very time consuming because the parts come from overseas and are expensive. Hence, there is a need to develop indigenous tunneling equipments by private sector in our country to increase the deployment of modern machinery, reduce the cost, and cut short the service timelines. Our building tunnel is not without its challenges, and that is precisely we are here today in this seminar, and this will give us an opportunity to come together to exchange our knowledges in different parts of the world, to share best practices and to explore the most innovative and cutting-edge technologies in tunnel construction. We are honored to have such a diverse and distinguished international and national expert speakers and participants here today, representing a wide range of backgrounds and perspectives. In fact, we were lucky that World Road Association was having last 2 days their first executive committee meeting in India in Mussoorie. So some of the experts of World Road Association are here, PRC, and then we had the PRC Tunnel Committee, which is also a PR committee, and their experts also are participating not only as speakers but also in the audience. So this, we are really fortunate to have such a gathering of experts on tunnels. And the next is today and tomorrow, in these 2 days, we will have 12 important technical sessions, which will be held in parallel, 6 sessions parallel in this hall as well as in another hall. And the topics are conceptual planning and design for road tunnels, ventilations, fire protections, latest developments, sustainable construction, geotechnical, geophysical investigations, safety issues. And there are many case studies from all around the world, which will definitely help us in propagating technical knowledge and disseminating these knowledge, and to make tunnel professionals aware about current state of art practices, specifications, guidelines, and environment-friendly and cost-effective technology in tunnel construction. We believe that by working together, we can harness the power of technology to address some of the most pressing challenges facing our world today, from climate change to social inequality, from economic instability to health crisis. Technology can play a vital role in finding innovative solutions to all these complex problems. So let us use this seminar as an opportunity to learn from one another, to challenge ourselves and our assumptions, and to work together to build a brighter future for all of us. Once again, I welcome you all to this international seminar, and thank you for your participation. Let's make this seminar a resounding success. Thank you. Jai Hind. Thank you.
Thank you so much, Sri Sanjay Kumar Nirmalji, the Secretary General from Indian Roads Congress. I would like to call upon now the Professor Arnold Dix, the President of International Tunneling and Underground Space Association, for his address. Can we have a huge round of applause for Professor Arnold Dix, the President, ITA.
Suprabhat Mitron. I bring greetings from the International Tunnelling and Underground Space Association. I bring greetings from the 80 member nations, more than 100,000 subject matter experts, and I bring greetings of thanks from the billions of people on the planet this morning that woke to the gift of clean water, to the gift of clean sanitation, that went to work on efficient transport systems, powered by sustainable energy, all of which could not have happened without us. And 15 years ago, I was asked to attend Terry Hydro project, and there I learnt why this is truly the land of the gods. For the first time in my professional career, I was taken into a cavity, an area of construction, and I could feel the rock talking to me, and that rock was very unhappy. And that unhappy rock has stayed with me, and the way I have conducted my professional career, and the messages that I bring to anyone who cares to talk with me and share ideas. And that is without harmony in the incredible forces of nature that surround us, we will not succeed. We will use all our energy trying to prove how clever we are and fail. And in the underground, when we fail, it is usually spectacular. It is catastrophic. It is catastrophic in terms of the lives lost. It is catastrophic in terms of the opportunity lost, in terms of the loss of faith in the underground and what it delivers for humanity. In the International Tunnelling and Underground Space Association, since my presidency, we have a new slogan, and that is, many people, one planet. The many people is our recognition that the journey to water, which is safe, to sanitation, which is clean, to connections within our countries, to security, to economic success, that those connections must be respectful of the local circumstances. So my friends, perhaps, and please forgive my pronunciation, but perhaps the ancient rishi of this region, if they were to advise us as technicians, they would be saying, please, my friends, be sensitive and create harmony within these mountains, or we will punish you. Today, 15 years after my visit to Terry Hydro, I am amazed. 15 years later, I find a country with optimism that I could not imagine. I wonder whether your COVID vaccine had something a little extra inside it to make you happy. I'm not sure. But I promise you this, as a president who travels the world, visiting so many places, your spirit of optimism is not common. We are living in a world of change where most people are feeling very depressed. You're not. At this conference, therefore, I bring some thoughts. I'm here to share ideas. I will make a small presentation, but mostly I bring my message of congratulations, of support, my suggestion to embrace harmony with the incredible forces in mountains that talked to me 15 years ago. And even this morning when I woke, I'm sure the gods were interested in this conference because for the first time, the wind blew hard, the thunder roared, and the rain it came. So they're listening. We have opportunities to do things better for our people, smarter for our people, more efficiently for our people, to deliver the health, the wealth, the happiness and security that all peoples of the world deserve. My friends, I bring greetings and salutations and best wishes from your brothers and sisters around the world in tunnelling. Greetings, and I've forgotten how to say my Hindi thank you. So I say thank you, not in Hindi, but I've forgotten how to say it. In goodwill, all the best with your conference. Thank you, ladies and gentlemen.
Thank you so much, Professor Arnold Dixie, President, International Tunneling and Underground Space Association. Now I would like to call upon Dr. Ingo Kondia, the Chair, PARC Technical Committee 4.4. Let us all give a huge round of applause for Dr. Ingo Kondia.
Thank you very much for this very kind introduction, and good morning and welcome also from my side to all the dignitaries of the day and to you tunnel experts and all the people present here for this conference. I will give a very brief keynote address presenting some work we are doing at the moment in our tunnel committee, and I'm very honored to chair this committee, and I'm very honored to be here and to speak to you. So I will talk in my brief keynote about challenges for road tunnel safety and operation from our tunnel committee's perspective. So how did it begin, this very deep cooperation which we now have with India? So we had 2 years ago a webinar which was streamed from Delhi about road tunnels, recent trends, innovations, and way forward. And in this webinar, we decided that it will be very good to deepen this cooperation with India, with Indian Road Congress, and with the Ministry of Transport from India. And we are very happy that we now have a delegate from India, Mr. Rahul Gupta, in our committee. And then we began to cooperate very much, and we decided in this event that it would be nice to have a seminar together in India. And now we are here and we have the seminar. So it's great. It's really a very good success of cooperation with you in India. Coming briefly to our committee, we are a huge group of 170 members in total. We have 38 member countries in our tunnel committee, and we organize our work, of course, in different working groups and small task forces. You see here a picture of our TC meeting we had in the last 2 days here at this university. It was a very successful meeting, very fruitful, and a very good exchange. This is a small overview about the working groups we have in our committee. I've printed in bold the names of the working group leaders and co-leaders who are present here in this Congress, who will present, and you are able to talk with them and to get some information about these topics they are ahead of in our tunnel committee. Our committee is one of the oldest ones in PIAC, so we have in total 65 years of experience in road tunnel operation and safety. We have delivered a lot of outputs, not only conferences and seminars, but also a lot of technical reports, 49 in total since 1995. And all this knowledge is for free. You can access this knowledge on the PIAC webpage. You just have to register on this webpage and you can download all our reports and our knowledge which is being gathered on this work page. So coming now to the future, to the new challenges and topics we are feeling are important for the future from perspective of our tunnels committee. First issue, which is of great concern, is the road tunnel operation and safety issues related to the use of new energy carrier vehicles, so battery-powered vehicles, hydrogen-powered vehicles, or vehicles running on LPG or other gases. So this is a topic which we begin to tackle during this cycle, and we will go on in the next years because there are so much developments in these technologies, and it is important to deal with the safety aspects of these new technologies. Another new topic which has been identified by our committee will be the challenges related to the development of soft modes. I also saw many people in India walking on the road, some also cycling. So this is something which we would like to look from a safety perspective in tunnels. So how could we include cyclists and pedestrians in road tunnels, mostly in urban road tunnels, to have them safely integrated into these infrastructures. Another important topic is the digitalization of road tunnel design and management. So I speak not only about digitalization of the design and construction of the tunnel, but we try to identify also the benefits of the building information modeling methodology to be used for the operation of a tunnel, for the maintenance of a tunnel. So this is also something which could be interesting to look at in the future. And then coming from the input from the BIM models, you can also think about operating tunnels by using so-called digital twins. These are digital representatives of the physical assets. And you can operate these physical assets and you can maintain these physical assets through these digital representatives. And this could be done, for example, by some dashboards which you develop and where you can identify and can very easily see what is the current status of your tunnel, what could be the developments, and so on. And you can look at the new communication systems we have now in the cars. The cars are talking to the infrastructure, and the infrastructure could talk to the cars. So there's a lot of new developments in this area, which could be also investigated in terms of what are the impacts for road tunnel safety, and what are the impacts on the users, what are the impacts on operation. So I think these are new topics which are important for our committee. Finally, I would like to mention sustainability. This is, of course, a concern everywhere in the world. And we will look into the sustainability approaches which could be used to operate a tunnel more independent from electricity from the grid, for example. You can use solar panels to have your lighting systems in the tunnel supplied. And you can use, for example, drainage water coming from the tunnel to heat road surface, so you don't need winter service. So there are many possibilities to use green energy for the tunnels. So this was just a very brief overview what we are talking about in our tunnel committee in the next years. I hope it's interesting for you, and maybe others are also interested in joining our committee. It's always possible to join our tunnel committee, and we are very happy to have Indian delegates on our committee, and I'm looking forward to the further very good cooperation with all of you, and I wish us a fruitful and very interesting conference. Thank you very much.
Thank you so much, Dr. Ingo Kondia. I would like to request Sri Mark Henry Ruberencia, the Vice President, PARC World Road Organization, to kindly come forward for the address, please.
Dignitaries here present in your respective capacities, dignitaries, technical experts, and friends of the tunneling community. I bring you greetings from the President of the World Road Association, Engineer Nazir Ali, as well as the Executive Committee and all the leadership of the World Road Association. It's a pleasure to have you here with us. So I'll just put this in a broader context of what we're doing and why we are all here and why what we're here, what we're doing here matters. Roads are very central to the realization of the Sustainable Development Goals, which is a commitment that all nations of the world have given themselves, and there's certain particular goals. I would say 7 of those goals will not be achieved if we here do not do what it is that we've set out to do. We will not be able to achieve sustainable economic growth. We will not be able to build resilient infrastructure, make cities more resilient, provide access to health, provide access to education, build efficient institutions, and very importantly, combat climate change. If we do not have our tunnels in order, we will not be able to achieve these goals as a global community. And so why should we be coming here again to talk about roads? My colleague, Professor Arnold, mentioned he's been around 15 years ago. So this discussion on roads has been there, but it's probably been around since the time of the Romans and before. So why talk about roads? Well, road transport is very essential, and it continually changes. You know, a lot of our inland transportation is by roads, and it's not going to change, not in our lifetime or several other lifetimes. However, the techniques of constructing and maintaining roads continually evolves. And so we need to share knowledge on what's new, what's happening, what's best practice. And so that's why these meetings are very, very important. And it's an honor that PIAC should convene these meetings across the world in both low-income countries and high-income countries, because PIAC is a mature organization. We've been around for about 109 years, and our core objective is really about sharing knowledge, convening experts, sharing knowledge, so we can all go back enriched and we can apply the lessons that we have learned. PIAC is composed of 125 governments, as well as lots more regions, businesses, and individuals. So it's a very large organization. We can call on at least 1,200 experts, of whom a good number are here. And you all come from about 80 plus countries, and these experts work across more than 20 technical committees, working groups, and task forces. At the top of PIAC, to give some sense of governance, we've got an executive committee, we've got a president, past president, we've got members and national committee representatives. And I'm very glad to say that India is a member of the executive committee. We've got Sanjay Kumar, who sits on the executive committee and has been a very active participant over the years. Our strategic plan, like I mentioned, has technical committees and working groups, task forces across the entire road sector. So in this particular case, we're here attending an international conference that's co-organized by the Technical Committee 4.4 on tunnels. But Mr. Minister and dignitaries, I'd like to assure you that we've got committees that span the entire sector, the entire spread of the road sector. And I call upon India to participate and benefit from the knowledge that is being generated and shared in each and every one of these respective committees. We do develop a lot of publications every year, some of which have been mentioned by my colleague, Dr. Ingo, and lots of others that are very relevant to countries like India. And India is a big place, so they would also be specific to certain regions. So I would say get into our publication, a list of publications, and there's a lot of very valuable input that can just be picked and applied, because this is best practice that has been collected from across the world. A lot of this material all this material I would say is available in English, but a good amount of it is also available in Spanish and in French, which are the two other official languages of PIAC. PIAC convenes very many meetings like this. We've got seminars, some of which, for instance, in the region, have been organized already in Indonesia, in Malaysia, this one here in India, and then next year we're going to be organizing a few others, notably in Tunisia, Morocco, Tanzania. We've also recently organized a symposium on pavement characteristics, an international conference last year on road tunnel operations and safety. So PIAC offers lots of opportunities to get experts together, as well as people interested in the sector, to come together and share knowledge. And I'd like to talk about one in particular, Mr. Minister and dignitaries here. I'd like to invite all of us, members of the Indian Tunnels Association and Indian Tunnels community, to participate in the upcoming World Road Congress. The World Road Congresses are held every 4 years. They are very high-level meetings that bring together all the technical committees to present the work that they've been working on over a 4-year cycle. It's very, very rich in content, because we have a ministerial session where you have top-level leaders in the transport organizations who happen to be the ministers. And then we've got various sessions, and as well as foresight sessions, where we're now looking towards where is the road discussion going. Like, again, Dr. Ingo has mentioned some of the things that we're more forward-looking. We don't want to dwell on what is and what has been. So finally, I'll say, how has India benefited from PIAC? I again reiterate that our vision is to be a leader in knowledge exchange in roads and transport policy, and we do this in the context of integrated, sustainable transport. So it's not just a leader for leadership's sake, but it has context around it. And so through this, there are very many opportunities to share knowledge. I just mentioned a few on the screen ahead of you. And there are opportunities that I'd like to specifically invite India to interest itself in. In May and June this year, we're going to send out calls to have members to attend technical committees. Dr. Ingo has just mentioned that the Tunnels Committee will be inviting other experts. You've seen the entire list of technical committees, work groups, and task forces. I welcome India to send representatives to participate in each and every one of these technical committees for the knowledge that you will bring as well as the knowledge that you will gain. And also, I would like to invite India to say this is not the last. This is a very wonderful seminar that you've put together, but even into the next cycle that begins in 2024, please plan to organize lots more seminars in various technical committees to which you will send your members. And I would also finally like to acknowledge India's great contribution to the World Road Association. India being one of the founding members, I've mentioned you're represented on the executive committee, you're represented on the tunnels, the electric road systems, as well as the pavement systems. And as has been mentioned, for the first time, you have hosted the PIAC board, to which we're very, very grateful as a board for your extreme hospitality. So thank you very much, and I wish you all successful deliberations. Thank you.
Thank you so much, Shri Mark Henry Ruberenzia, the Vice President, World Road Organization. And now it's the time for the release of the souvenir, for which I would request General Dr. Vijay Kumar Singh, PVSM, AVSM, YSM retired, Honorable Union Minister of State for Road Transport and Highways and Civil Aviation, along with Shri Satpal Ji Maharaj Ji, Honorable Cabinet Minister, Public Works Department, Government of Uttarakhand, to kindly unfold the souvenir. To kindly unfold the souvenir, which is in the remembrance of this international seminar comprising of the world-class papers and articles by the eminent personalities. So can we have a huge round of applause? And this is indeed a historic moment that all the dignitaries on dais are unfolding the souvenir. That is the comprehension of the articles and the papers by the experts. Indeed, a historic moment for all of us. Thank you so much, the eminent dignitaries on dais, for unfolding the souvenir. Taking the program ahead, now is the time to invite Shri PVSS Ravi Prasad Ji, Director General Road Development and Special Secretary, Ministry of Road Transport and Highways, for his address. Can we give a huge round of applause for Shri PVSS Ravi Prasad Ji?
Good morning to one and all. Honorable Minister of State for Road Transport and Highways, General Dr. V.K. Singh Ji, PVSM, AVSM, YSM, retired. Honorable Minister, Public Works Department, Government of Uttarakhand, Shri Satpal Maharaj Ji. Secretary, RTH, Government of India, Srimati Alka Upadhyay Ji, who is with us in virtual mode. Shri R.K. Sudhanshu Ji, Principal Secretary, PWD Uttarakhand. President, World Road Association, PR, Mr. Nazir Ali. President, International Tunneling and Underground Space Association, Professor Arnold Dix. Secretary General, World Road Association, Mr. Patrick Malaja. Chairman, Tunnel Committee, Mr. Ingo Kondinya. Distinguished tunnel engineers, guests, media friends, ladies and gentlemen. I am delighted to be with you in the inaugural session of the International Seminar on Advances in Design, Construction and Operation of Tunnels. I express my deep appreciation to Indian Roads Congress, World Road Association, International Tunneling and Underground Space Association, and Government of Uttarakhand for coming together in organizing this international seminar on this important topic of tunnels. Ministry of Road Transport and Highways, Government of India is committed to development of durable, efficient and safe national highway infrastructure to improve connectivity and mobility to act as catalyst to the socio-economic development of the country. As we all know, underground structures have a lot of potential in highway development. Ministry of Road Transport and Highways, Government of India is focusing on development of tunnels on national highways, primarily in hilly and mountainous terrains, to provide all-weather connectivity to inaccessible, remote and strategic areas. Construction of tunnels is a challenging task due to the uncertainties associated with the underlying strata, high mountain overburden, and difficult working conditions in higher altitudes. Presence of shear zones, very weak rock strata, water ingress, and sludge cavity formation, etc. pose challenges in building tunnels. Tunnels of about 45 km length are in operation at present on national highways. 120 km length tunnels are under implementation, and about 192 km length of tunnels are presently in DPR stage on national highways in India. Some of the noteworthy tunnels in operation on national highways in the country are 9.02 km long Atal Tunnel at Rohtang on NH3, 9 km long Chanani Nashri Tunnel on NH44, and 8.45 km long Kajigund Banihal Tunnel on NH44. Different technical sessions have been included in the seminar, covering crucial aspects like geotechnical and geophysical investigations, conceptual planning and design of tunnels, ventilation and fire protection, and contractual issues in the construction of tunnels for detailed deliberations. All the survey investigations are very pertinent to gain knowledge of unforeseen, highly variable subsurface ground conditions and play a critical role in realistic assessment of the project costs as well as in ensuring safety during construction and operation of the tunnels. We are also planning to standardize the data collection in the investigations for tunnels. This data will be stored in a central server which would be accessible to different organizations and industry for research and development activities. In addition, as tunnel construction has to deal with numerous complications due to presence of water streams in tunnel corridors, faults, snow at higher altitudes, etc., there is a need to disseminate knowledge among the concerned government organizations such as Defense Research Development Organization, National Institute of Hydrology, Geological Survey of India, etc. In this direction, Ministry of Road Transport and Highways has signed a memorandum of understanding with DRDO and GSI for collaboration. As the present EPC contract document does not fully address the risks involved in tunnel projects, there is a need to develop a contract document for the tunnel projects on the lines of FIDIC Emerald Book to facilitate equitable and fair sharing of unknown geological risks between contractor and the authority. Work has also been started in this domain in the ministry. There is a need to encourage contractors in using new technologies with support from reputed academic institutions. I hope that this seminar will provide a platform to all the stakeholders to discuss and identify the constraints, best available global tunneling practices around the world to recommend the strategies for taking the development of tunnels in the country forward. With this, I wish every success to this seminar. Thank you. Jai Hind.
Thank you so much, Sri P.V. VSS Ravi Prasad ji, Director General Road Development and Special Secretary, Ministry of Road Transport and Highways. Now, moving ahead, I would request Mrs. Alka Upadhyay ji. She is IASN and Secretary Road Transport and Highways Government of India. She is there with us through the online mode. I extend my cordial welcome to you, madam. Over to you, ma'am.
Thank you very much. At the outset, I express deep apologies and regret that I could not be physically present over there. Honorable Minister of State for Road Transport and Highways, General Dr. V.K. Singh ji, PVSM, AVSM and BISM, Minister Public Works Department in Government of Uttarakhand, Shri Satpal ji Maharaj, President of the World Association PR, Mr. Nazir Ali, President International Tunneling and Underground Space Association, Professor Arnold, Secretary General World Road Association, PR, Mr. Patrick, the Chairman of the Tunnel Committee, Mr. Ivo Pandinya, and of course our Secretary General, who is from the Ministry, Mr. Sanjay Nirmalji, DG and Special Secretary, Ministry of Road Transport and Highways, and my dear colleagues, distinguished dignitaries who have traveled from different parts of the world and different parts of the country to attend this very important conference. At the outset, I would also like to extend my deep gratitude to the government of Uttarakhand for helping us in organizing this very prestigious seminar in the state of Uttarakhand, and thank you for the hospitality. It gives me immense pleasure today to be with all of you in the inaugural session, although I would have been happier had I been able to participate there physically, on International Seminar on Advances in Design, Construction and Operation of Tunnels. India boasts of the second highest, largest network of roads in the world, and which is about 6.3 million kilometers. And our national highways are about 145,000 kilometers of roads are national highways. But these roads carry more than 50% of the freight as well as other traffic in the length and breadth of the country. Tunneling is a very new subject, and we all know that India is a country with huge differences in geography and very different topographies. In the north, we have the young Himalayas, which pose a challenge for road construction. On the other side, in the peninsular side, we have the coast engulfing the country. So we have a very varied experience, and I'm also happy to share over here. It is because of this that our engineers are probably amongst the best, and they are learning to be at par with the best of the engineers across the world. We are aware that road infrastructure not only increases the socio-economic development of the country, but today we are looking at road development or infrastructure development with a very different perspective. We want to bring in the cheapest or the best models of intermodality, which will reduce the logistics cost and which will help in propelling the economy or reducing the cost that is spent on the logistics area, which will give a huge impetus to the economy. We also have a very dynamic leadership in the country right now, and this ministry has been given the highest budget or outlay for development of roads in the infrastructure sector. We are one of the highest spenders as far as capital expenditure is concerned. India has some of the most difficult mountain terrain, as I just mentioned, and this is the time that when we are trying to connect the far-flung areas in the upper reaches of the Himalayas, which are with high altitude passes that are covered with snow for almost 6 months of the year. These roads are narrow and they go through sensitive ecological zones. And as I mentioned, Uttarakhand, for instance, is one of those challenging areas. While we are committed to building roads and creating new infrastructure, but we also have to be very, very sensitive about the ecology of this region. The emphasis is now being placed on construction of tunnels to ensure connectivity throughout the year. As far as tunnels are concerned, this country is now spending or investing a lot in tunnels and taking up very prestigious projects which are also very challenging in number of ways. At the moment, we have about 300-kilometer length of tunnels being constructed in the country, and I think in the next 10 to 15 years, we would have about 2,000-kilometer length of tunnels in the country which are under the process of being conceptualized and being taken up for construction subsequently. Planning for a road tunnel requires a multidisciplinary approach, and it involves deep involvement of a number of stakeholders. Further, modern road construction places special demands on the geological investigations in connection with tunnel construction. The investigations for tunnel projects shall provide an account of alternatives and total costs along with survey of conditions relating to safety of community and the environment. Very recently, we have constituted an inter-ministerial committee which is also looking at alternatives to tunnel or reducing the cost in tunnels. One thing is very sure, that while we are constructing the tunnel, human life is also very important. The safety of human life is very important, as is the ecology of the region where we take up these works. We need world-class road infrastructure enabling fast mobility and safe mobility. I implore the tunnel engineers and the contractors to have adequate knowledge of latest advantages in technology across the world and commit towards adherence to quality control. And as I had just mentioned, while we are taking very deep strides, very sharp strides as far as tunnel construction is concerned, which is matched by the contractor or the concessionaire community here in India, as a result of which we are doing the Zojila tunnel, the Zedmore tunnel, which are going to be, I think, any engineering marvel in a short time from now. About the Zedmore tunnel, I presume, would be completed this year by October, November. And similarly, the Zojila tunnel will also be completed in the next 1 or 2 years. These are going to be game changers, or this will really change the nature of commute in the upper reaches of the Himalayas or in the Jammu and Kashmir area of the country. I hope this 2-day seminar will be beneficial to all the highway engineers and tunnel professionals, as well as national and international stakeholders, to discuss and identify the constraints, best tunneling practices and technology which is prevalent worldwide, and recommendations for overcoming constraints and improving the road tunneling work. By facilitating the exchange of information regarding global design, construction, etc. And one important aspect is the operation and maintenance and safety of commuting in the tunnels, which is related to fire hazard. We have a lot to learn from the international practices. I take this opportunity also to assure that India will be adequately represented in the World Road Congress, which is to be held subsequently. I think in the month of October it was mentioned. I would also urge our Director General, during the course of discussion in these 2-3 days, that the agenda which has been set forth to us on optimizing the cost of tunnel construction, there will be a learning for many of our engineers as well as the officials who are present over there as to how we can construct safe, optimally cost effective roads and tunnels. Thank you very much, and I wish you all the success in this seminar today.
Thank you so much, Mrs. Alka Upadhyay, IAS Secretary, Road Transport and Highways, Government of India, for your enlightening words. And before we move on to our next dignitary, I would like to say a few words about him. That he is an epitome of knowledge, a visionary cabinet minister of a state, under whose positive vision and unsurpassed execution our state Uttarakhand is doing amazingly well. He has taught our state people to strive for success, and he has taught us that ocean is so deep and the sky is so high, yet we have to reach the depths to touch the heights of the sky. May we all join hands together for Shri Satpal Ji Maharaj Ji, Honorable Cabinet Minister, Public Works Department, Government of Uttarakhand.
Honorable Union Minister of State for Roads and Transport and Civil Aviation General Dr. V.K. Singh Ji, Secretary Ministry of Road and Transport Mrs. Alka Upadhyay Ji, Principal Secretary Public Works Department R.K. Sudhanshu Ji, Chairman IRC Mr. Sandeep B. Vasava Ji, Director General and Special Secretary Ministry of Roads and Transport Mr. PVVSS Ravi Prasad Ji, Mr. S.K. Nirmal Ji, Secretary General of IRC Mr. Nazir Ali Ji, President of PARIC World Road Association Professor Arnold Ji, President of International Tunneling and Underground Space Association PARIC General Secretary Mr. Patrick, IRC Vice President Professor Manoranjan Parida Ji, R.K. Mehra Ji, Arvind Kumar Jain Ji, Pranav Kumar Ji, Chancellor Mr. N. Ravi Shankar, Vice Chancellor Dr. G. Raghu Rama Ji, Professor Vice Chancellor Dr. Priyadarshan Patra Ji, and all tunnel experts who have gathered here from different parts of the world, and all participants from India and abroad, all present officers, representatives of electronic and print media, I heartily welcome each one of you to Dehradun, the capital of Devbhoomi, Uttarakhand. सुरंग की डिजाइन, निर्माण एवं संचालन के विकास विषय पर उत्तराखंड राज्य में आयोजित हो रहे इस अंतर्राष्ट्रीय सेमिनार को लेकर हम सभी उत्साहित और आशावान हैं। हमारे राज्य की विषम भौगोलिक परिस्थिति एवं पर्यटन की अपार संभावनाओं को देखते हुए सुरंग निर्माण विकास के क्षेत्र में नए आयाम स्थापित कर सकता है। मैं माननीय सड़क परिवहन एवं राज्य मंत्री माननीय जी और मॉर्थ के अधिकारी, वर्ल्ड रोड एसोसिएशन, IRC, ITA इत्यादि संस्थानों का उत्तराखंड के ऐसे महत्वपूर्ण ज्ञानवर्धक सेमिनार का आयोजन करने के लिए हार्दिक आभार व्यक्त करता हूं। ऐसे आयोजन अभियंताओं, नीति निर्माताओं, निर्माण एजेंसी, सुरंग विशेषज्ञों के लिए उपयोगी तो होते ही हैं, साथ ही आम जनमानस को जागरूक करने के लिए एक तंत्र की तरह से कार्य करते हैं। यह मानव स्वभाव है कि जब कोई नई व्यवस्था, नई टेक्नोलॉजी परंपरागत प्रणाली से हटकर प्रारंभ की जाती है तो इसकी सफलता असफलता को लेकर मन में तमाम आशंकाएं होती हैं। लेकिन जब हम कुछ सफलतापूर्वक प्रोजेक्ट कर लेते हैं, उनसे लाभ से और आज की आवश्यकताओं से विभिन्न सक्सेस स्टोरीज लोगों के सामने आती हैं, तो इससे आम जनमानस में स्वीकार्यता और उसकी सहभागिता बढ़ जाती है। हमें पूर्ण विश्वास है कि इस प्रकार के टेक्निकल नॉलेज शेयरिंग सेमिनार से इस क्षेत्र के जुड़े प्रोफेशन से लाभान्वित होंगे लोग, साथ ही स्थानीय लोगों में जागरूकता बढ़ेगी और उनके सहयोग से हम ऐसे सुरंग के प्रोजेक्ट को आसानी से धरातल पर इंप्लीमेंट कर सकेंगे। हमारे प्रदेश में अनेकों सुरभ्य स्थल, बहुत से धार्मिक स्थल हैं जिनको जोड़ने के लिए एक सुरक्षित और मजबूत इंफ्रास्ट्रक्चर होना जरूरी है। मार्ग के निर्माण में पर्वतीय क्षेत्रों में वर्टिकल क्लिफ, हिमाच्छादित क्षेत्र, आबादी क्षेत्र, भूस्खलन जोन, भूमि की अनुपलब्धता, ट्रैफिक कंजेशन, पर्यावरण संरक्षण इत्यादि कई अवरोध एवं चुनौतियां होती हैं। ऐसे में सुरंग का निर्माण हमारे लिए स्वाभाविक एवं सर्वाधिक उपयुक्त विकल्प हो जाता है। सुरंग का निर्माण कोई नई टेक्नोलॉजी नहीं है, लेकिन अभी इसको हमारे देश एवं प्रदेश के अधिक से अधिक इसको एक्सप्लोर नहीं किया गया है। मैं विश्व के अनेक देशों में गया हूं जहां छोटे छोटे टनल बनाकर आवागमन को अत्यंत सुगम कर दिया गया है। इसका प्रयोग अपने प्रदेश में हम करके अच्छा इंफ्रास्ट्रक्चर बना सकते हैं। और मुझे ये पता है कि जब मनारी वैली फेज 2 का निर्माण हो रहा था तो 14 किलोमीटर की टनल थी, जिसमें 7 किलोमीटर एक तरफ से, 7 किलोमीटर एक तरफ से उसको खोद करके और उसको ज्वाइन करना था, उसको जोड़ना था। हम लोग 7 किलोमीटर के अंदर हम लोग बैठे हुए थे और वहां पर उसको जोड़ा गया। बहुत ही एक हर्ष का क्षण था कि जबकि हमारी टेक्नोलॉजी ने सही तरीके से उसको जोड़ा और हम सफलतापूर्वक मनारी वैली फेज 2 की टनल को हमने पूरा किया। तो मेरा कहने का अभिप्राय यह है कि टनल से जैसे कि आपको पता है कि हम एक स्ट्रेट लाइन की डेफिनेशन जो होती है वो ये होती है कि द शॉर्टेस्ट डिस्टेंस बिटवीन 2 पॉइंट्स, ऐसे टनल भी शॉर्टेस्ट डिस्टेंस है बिटवीन 2 डेस्टिनेशंस। तो ये टनल हमारे उत्तराखंड के लिए बहुत उपयोगी होंगे और मैं समझता हूं कि जो हमारे विशेषज्ञ और प्रोफेशनल्स हैं उनसे अपेक्षा की जाती है कि अपनी खुली सोच रखते हुए और छोटी छोटी टनल बनाकर हमारे उत्तराखंड के इंफ्रास्ट्रक्चर को मजबूत करें और एनवायरमेंट फ्रेंडली स्ट्रक्चर को बनाएं। छोटी टनलों में वेंटिलेशन का इशू भी कम होता है, मोनाटनी भी कम होती है। टनल के साथ साथ जो स्केप टनल निर्माण की जाती हैं इसका मल्टीपर्पस उपयोग होता है। क्योंकि मुझे जब मैं अलास्का गया था तो मैंने देखा कि वहां जो टनल थी उसके अंदर ट्रेन भी चलती थी और उसके अंदर कार्स भी चलती थी, तो उसका दोनों का उपयोग किया जाता था। आज हमारे उत्तराखंड में ऋषिकेश से कर्णप्रयाग जो है रेलवे का पूरा विस्तार हो रहा है, जिसमें एक रेलवे की टनल बन रही है, एक इवैक्यूएशन टनल बन रही है। तो निश्चित रूप में हमारा जो क्षेत्र है ये जोन 4 और 5 में आता है। भूकंप का वाला क्षेत्र यह है, यहाँ पर टेक्टोनिक प्लेट्स जो हैं आपस में रगड़ रही हैं और बढ़ रही हैं और आने वाले समय में ये सोचा जाता है कि यहाँ पर कोई बड़ा एक विशाल जो है अर्थक्वेक आने की संभावना है। तो ये सब कुछ देखते हुए अगर ऐसी टेक्नोलॉजी को हम लाएंगे कि जो सेफ होगी, सुरक्षित होगी, क्योंकि ये माना जाता है कि भूकंप के समय में सबसे सुरक्षित स्थान टनल ही है, सुरंग ही है। तो निश्चित रूप में इसको बढ़ावा देते हुए हम लोग आगे बढ़ेंगे तो उत्तराखंड का विकास होगा, देश का विकास होगा। मैं सभी विशेषज्ञों को एवं प्रतिभागियों को इस सेमिनार की सफलता के लिए शुभकामना ज्ञापित करता हूं और आशा करता हूं कि इस सेमिनार से सभी लाभान्वित होंगे। बहुत बहुत धन्यवाद। जय भारत, जय उत्तराखंड।
Thank you so much for your enlightening words, Shri Satpal Ji Maharaj Ji, Honorable Cabinet Minister, Public Works Department, Government of Uttarakhand. Now I would like to request General Dr. Vijay Kumar Singh Ji, PVSM, AVSM, YSM retired, Honorable Union Minister of State for Road Transport and Highways and Civil Aviation for his kind address. Can we all give a huge round of applause for the Honorable Union Minister?
Present here today with us, the Minister for Public Works Department in the Government of Uttarakhand, Shri Satpal Maharaj Ji. Joining us on the virtual network, our Secretary in the Road Transport and Highways, Srimati Alka Upadhyay Ji, President IRC and Secretary PWD, Government of Gujarat, then DG RD and SS Morth, Shri PVSS Ravi Prasad Ji, Principal Secretary PWD Government of Uttarakhand, Shri R.K. Sudhanshu Ji, Secretary General IRC, Shri S.K. Nirmal Ji, Vice President of the World Road Association, Mark Henry Rubrinzia. We also have President International Tunneling and Underground Space Association, Professor Arnold Dix, Secretary General World Road Association, Mr. Patrick Malizak, Chairman Tunnel Committee, Mr. Ingo Kondinya. Premises of this university that we are using, I would like to acknowledge the presence of Chancellor Ravi Shankar Ji, Vice Chancellor Dr. Raghurama Ji, Pro Vice Chancellor Dr. Priyadarshan Patra Ji, and all our experts, all our guests who have come from abroad, from the various member countries of the World Road Organization, and all those who are attending this seminar, a seminar that will contribute a lot to the knowledge bank as well as to discussions on the subject. Very good morning to each one of you and members of the media who are present here, who would be reporting on this in their papers. Welcome. I would like to say that it's a pleasure to have each one of you here, and my pleasure to come here has been doubled to see this hall full. And I think you need to give yourself a big hand. I would like to first of all express my sincere thanks to the World Road Association for partnering with us and organizing this international seminar. I also express my thanks to International Tunneling and Underground Space Association as well as the state government of Uttarakhand for supporting this particular event and ensuring that there's a gain that occurs by the ideas that will be exchanged. Today, India is on the move, and there's a large amount of work that is being done on the road infrastructure sector. We have approximately 6.3 million kilometers of roads, out of which only 145,000 kilometers is national highways, which carry almost 50% of the road transport of the country. And therefore, we are always on the lookout for making better and better roads, since most of the traffic ultimately converges onto our national highway network. And today, what we are trying to do is to create world-class infrastructure in terms of connectivity amongst the various parts of the country, in terms of economic corridors, in terms of green highways, in terms of roads that will go to areas which hitherto had very shallow connectivity, and all this to ensure that the economic growth can keep pace with the modern times. We are on the lookout for ensuring that whatever you have, we can copy that, we can sit with you, share our ideas with you, and then come up with solutions which will suit us. I'm a firm believer that no one size fits all. Each country is different, conditions are different. For example, in our case, the Himalayas are young mountains, the geology is totally different. Within these various sectors of Himalayas, the geography is different. In fact, there is a tunnel which is under construction in Kashmir at Zadmore. Each bore that takes place, the geology is different. Now you can imagine the problem tunneling would have. And that is why we are ever eager to find out solutions for this kind of things. You go to more older mountains, older chains, you have very hard rock. What do you do out there? And tunneling is not just confined to the mountain and the hilly areas. They were the first areas which were touched by tunnels because you wanted shorter distances, you wanted a straight line. So you had bridges and tunnels to ensure that you did away with going along the contour lines of the hills. And it has helped. You go to some of the countries where the roads are absolutely straight, despite being in the mountains. That's what we are also aiming at. Our challenges are very many. We have got very high altitude areas. When I talk of high altitude areas, they are all above 14,000. Now, construction in those areas have their own challenges. And therefore, we need to find technology, we need to find machinery, we need to find solutions to do this. Tunnels have also progressed as tunnels in urban areas, where you want to decongest the traffic in urban areas. You also want the tunnels to bridge certain sea channels. So you go under the sea channels, you go under the rivers. So there are tunnels of various types which will require different methodologies different technologies and different materials to ensure that things can come up in the time that you require them to come up and in the price band which you are prepared to spend for these tunnels. As the market grows, prices will come down. And therefore, what I would say is that we not only look for technology in tunneling, we are also looking at machinery. We are looking at people coming here, building with us, because there's a great scope for market to grow for this kind of activity in India. And more we grow, more the prices will come down, better technologies will come up, because you will have newer challenges in areas which you have not seen earlier. So at the end of the seminar, I'm quite sure, with the expertise that you will share, with the ideas that you will share, we will have some very good things which will come out as a summary of the things that you have given to us, which we can use not only here, but in conjunction with you elsewhere also in the world. The seminar is only just beginning, and I'm sure the type of support that we are getting from the World Road Conference and our association with them, and the type of support that we'll get from the Tunneling and Underspace organization, it will make things better for us. And I sincerely look forward to the discussions that you would have had, so that we can make use of whatever ideas have been passed on so far. Once again, welcome here. It's a beautiful city. You can look at the various things. In fact, a lot of people in summers come and visit Mussoorie, which has been a hill station for a very long time. And it is a place out of the world. Your coming here has also brought down the temperatures, which is a good omen. So wishing you all the success. Thank you very much. Jai Hind.
Thank you so much, General Dr. Vijay Kumar Singh ji, for your insightful words indeed. Moving ahead, as we all know by now that Shri Nitin Gadkari ji, Honorable Union Minister for Road Transport and Highways, could not make it today. However, we have the recorded video address of his. I would request the team to kindly play that.
Namaskar, all respectable dignitaries, ladies and gentlemen. It is a pleasure to address you through this recorded message. At the outset, I express my sincere thanks to World Road Association, PIORC, for partnering with the Ministry of Road Transport and Highways, MORTH, and Indian Road Congress, IRC, in organizing this international seminar on advance in design, construction and operation of tunnels. I would also like to thank the President of IRC and Secretary PWD, Government of Gujarat, Sri S.B. Vasawaji, DG Ravi Prasad ji, and all the national and global dignitaries attending this event. I also express my thanks to International Tunneling and Underground Space Association, ITA, and the Government of Uttarakhand for their support in organizing this event. Tunnels are one of the most important structures which improve accessibility and make travel safer in difficult and hilly terrains. It is important to have recent technologies and best-in-class engineering designs for reducing cost of tunnel construction without compromise with the quality. India has one of the largest road network in the world. It is about 6.3 million, 63 lakh kilometers, second largest road network in the world after USA. The national highway has a length of nearly about 1,45,000 kilometers, and which carries 90% of the passenger and 70% of cargo traffic across the length and breadth of the country. The road network is vital for sustained and inclusive growth of the economy. On national highways in India, total of 110 tunnels with the length of 354 kilometers with an outlay of rupees 2 lakh crore is now our plan. Just yesterday, I visited one of the longest tunnels in Asia called Zojila Tunnel in Jammu and Kashmir. It is a very difficult project to execute. It involves construction of 13.14 kilometer long Zojila Tunnel at 18.63 kilometer approach road at an altitude of about 3,000 meter under Zojila Pass. Presently, it's motorable only for 6 months in a year due to heavy snowfall. However, after its construction, it would provide all-weather connectivity between Srinagar Valley and Leh Ladakh, particularly Ladakh Plateau, on NH1. Baltal to Maltin, 15 minutes travel time is place of 3 hours. It is one of the most dangerous stretches in the world to drive a vehicle, as this project is also geostrategically sensitive and will facilitate natives and armed forces for last transport of goods and services. Cost assessed initially for the project including Zojila Tunnel and approaches up to Jhedmore Tunnel was nearly about 11,000 crore. In year 2020, I reviewed this whole project to reduce the cost of execute the project in priority, referred the matter to a committee of tunnel experts in the country, and the committee suggested to integrate the project of tunnel and approaches road utilizing the excavated rock material generated from tunnel boring, its construction and approach roads. Based on the remodeling of the project, the cost resulted in nearly rupees 7,000 crore. Hence, the saving was about rupees 4,000 crores. Despite certain challenges due to high altitude, it is being executed in full speed, and I am hopeful that the project will be completed by 2025. This will bring about an all-round economic and socio-cultural integration of Jammu and Kashmir. Once the tunnel is thrown open, the tourism will also increase, and it's going to create job opportunities in Jammu and Kashmir and Ladakh and Leh. It will lay out a roadmap for connecting several cities across the country. The Zojila Tunnel is one of the important things of our dream to connect Kashmir to Kanyakumari, and this will connectivity between north and south. It thus becomes imperative to make use of the available and emerging technologies and innovative concepts to better understand and manage the complex procedures and process of the tunnel design and construction with high cost efficiency. It requires a holistic approach, incorporating latest method of Internet of Things, IoT, and artificial intelligence, AI, integrating every aspect for achieving cost-efficient decisions. This is very important. Here the role of digitalization comes into picture for effective and specific administration of data captured in investigation, design, construction, monitoring, and operation process. With the technological advancement, digitalization will change the way of gathering geological data, the method of rock classification, as well as the application of design analysis required for tunneling. Tunnel construction process and tunnel maintenance will also be benefited by digital transformation. The precious drilling has to be achieved with the use of navigation satellites and computer-controlled drilling jumbos. During the last decade, successful application of machine learning has been incorporated in tunneling techniques, especially in Europe. These modern concepts need to be adopted for construction of tunnels in India. Further innovation approaches need to be followed in construction, operation, and maintenance of tunnels. The tunneling business in India is experiencing a rapid growth and is prepared to adopt cutting-edge technologies, making it one of the markets with the fastest rate of tunnel construction growth. Vision of my ministry is to provide world-class infrastructure which will boost overall development of the country. Availability of good infrastructure facility is an essential prerequisite for the growth and development of all spheres of economy and improving the living standard of the people. in this seminar. The international expert from Austria, Belgium, Australia, Brazil, Canada, Czech Republic, then France, Germany, Japan, Malaysia, Netherlands, Norway, and UK, and Indian expert will share their experiences. I will request them. The most important agenda for this conference, that how we can reduce the cost and how we, without compromise with the quality, at the same time, we need to manufacture made in India, make in India, all equipments in the country, by which we can reduce the cost, and that is very important. Without compromise with the quality, we want to reduce the cost. At the same time, the tunnel side area, by using the same material, we can make the beautification of that area, making good plantation. At the same time, we can make resorts, adventure sports, and also some entertainment planning for that, which can going to create employment potential in that area. We need to develop smart villages nearer to that area, where the market will be available for handloom, handicrafts, and the food of that area. Actually, we want to boost the economy by making the tunnels. We want to create employment potential by developing the tunnel. We want to make it easy road transport, by which we want to reduce the logistic cost. I hope this will enrich our existing knowledge of tunneling and will help IRC in adopting best international practices in our codes and guidelines. I hope this seminar provides a platform to share experience all around the world in design, construction, and operation of road tunnels. I will request to all of you, if you can make the one standards, one code for all type of tunnels in the world and different strata, then it can be a great achievement for the world. I will request you, I am expecting that you will work on this line. Once again, I am giving my thanks to all of you, welcoming all of you to India, and my best wishes to all of you. Thank you very much. Namaskar.
Thank you so much for your insightful and inspirational words, Honorable Union Minister. Now, coming closer to the end of the inaugural session, I would like to call upon Mr. Patrick, the Secretary General PIARC World Road Organization, to kindly deliver the vote of thanks. Can we give a huge round of applause for Mr. Patrick, please?
Namaste. 25 years ago, I came to India with the French Minister of Transport and organized visits and business trips to Kolkata, among other places. And in those days, I would never have thought I would come back to this country and to this beautiful part of this country to organize a seminar with a number of colleagues on tunnels, construction, design, operations, and safety. So it's really a great pleasure and honor to be invited to be with you here today. So I think we have to thank, and I really want to thank a number of people, our hosts, the Ministry of Road Transport and Highways in India, the Indian Road Congress, without whom we wouldn't have been able to organize this event, and of course our local hosts in Uttarakhand, this really beautiful land of the gods. I also would like to thank our technical committee in PIARC and its chair, Ingo Kaundinya, as well as its secretaries, Hélène Mangeot from France, Thiago Massingue from South Africa, and Rafael Lopez Garga from Spain, as well as all their members who have made the trip to join us here in India today and tomorrow from countries as far as Japan and Switzerland, to name just a few. I would like to thank our partners and colleagues, ITA, its president, Arnold Dix, ITA COSUF, its president, Eric Prema, who's in the room as well. And I would like to thank all sponsors and exhibitors who play a maybe silent but very important role in the organization of such events. I would like to wish all of you, ministers, dignitaries, officials, delegates, an excellent seminar over 2 days. Please feel free to discuss and ask questions to international and national experts, because I'm sure that we can all learn from each other. Having said that, I think we agree collectively to thank the organizers and all partners involved, and I would like us to give them a warm round of applause. Thank you.
Thank you so much, Mr. Patrick. And now I would request all of you to kindly raise from your seats and be in the attention position for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you so much. Kindly be seated. I request all the participants to be seated, and I request all the eminent guests on the dais to kindly move ahead to the ground floor for the high tea. And once again, thank you so much for being with us in the inaugural session. Can we all give a huge round of applause for the eminent dignitaries on dais for their delightful presence. Thank you so much once again, our honorable distinguished dignitaries on the dais for sparing their valuable time in the inaugural session. I would request all of you, to kindly be seated as, may I have your attention please? All the participants kindly pay attention that here we have, the sessions are divided into two technical sessions, wherein the one venue is here, whereas the other is in the Vishwakarma building. So once again, let us all give a huge round of applause for the delegates. Can we all give a huge round of applause? So now, the participants, this is for you, that the technical sessions will be on after the high tea, and the sessions comprising of design and constructions of tunnels will be held at this same venue, while the sessions related to operations, safety and maintenance of tunnels will be held at Seminar Hall, first floor of Vishwakarma building. And there's one more announcement that for the sightseeing, all those people who wish to visit the beautiful sites, so can meet the person concerned at the registration counter and give your consent by filling some form at the registration counter. So once again, thank you so much for being with us at the inaugural. Thank you. I, Dr. Kanchanegi, bid you goodbye. Thank you and all the best for the seminar. Thank you.
So this way, I just came to say you this thing only.
Very nice ceremony. Very nice. Okay, thank you. The program. How are we doing? 10:30, I think. Half an hour break and then start on time. No, we are just 15 minutes late. Just 15.
Thank you. I like the leadership session. It's a very long session, so actually, because the discipline, I thought, yes, this must be professor. The class in order. I'd like somebody to help me take care.
Sure. I'll just ask someone.
Yes, yes, अरे यार, हमसे मिलने ही तो मैं
संदीप अरे वहीं पे आ जा रहा है
ये लैपटॉप वहीं का है ना?
I have to keep my laptop here because अभी जो जो hosting होगा ना अभी सेरेमनी का टेक्निकल सेशन वो उसका होस्ट हम कर रहे हैं.
But this will be here. All this मतलब जो असाइन में PPTs हैं तो उनकी वो यहीं पे होगी.
सर तो इसको थोड़ा सा पीछे से थोड़ा सा करके Good morning, everyone present here. With due respect to our tradition and culture, I extend my greetings to all the dignitaries present here today with the Hindi salutation of Pranam and Namaste. I am Anya Jha, a sophomore at DIT University, and I am pursuing computer science. Honestly, when I was asked to host this seminar, I had no idea about it. But I must say that I am super excited to be here and I feel incredibly privileged to be a part of this amazing event. Spending a lot of time in the research of PyArc and their agenda, the 2018 conference at Lyon was indeed very insightful on how to improve the cycle time of tunneling, and the NATM method and the rock classification of the Q system was quite fascinating as well. Tunneling, in fact, is very difficult in India, but when it comes to the tunneling in the Himalayan region, the bar of difficulty raises to the next level. I'm sure that this seminar will be quite intriguing and will be a learning experience for all of us. We now start with the first technical event of the seminar. I would like to take this moment of honor to introduce you all towards the direction in which the seminar will be held. Our session will be about the conceptual learning and design for road tunnels. In this session 2A, there will be 3 presentations by the experts on the tunneling and design of road tunnels in the Himalayan region under the bright leadership of Mr. Rahul Gupta and Mr. Shwetab Singh from India. Moving on from that, we will be understanding the NATM tunneling instrumentation through the bright insights of Mr. Hayard Wagner, Consulting Engineer, Thailand, and henceforth we shall be concluding this session with a better understanding of the topic, Computational Methods of Design of Tunnels by Dr. Aditya Singh, Assistant Professor, IIT Roorkee. I find it honoring to declare the chair of our session, Ms. Alka Upadhyay, Secretary, Ministry of Road Transportation and Highway MORT, Government of India. We are honored to have Ms. Alka Upadhyay as our esteemed chair for this event, but unfortunately, she won't be joining us physically for this event, but her mere presence virtually will add a sense of grandeur and prestige to this occasion. The co-chair of the seminar, Mr. Patrick Malajak, Secretary General, PyArc, a man of immense experience and vision. I would like to invite Mr. Patrick Malajak to proceed towards the high table on the stage and guide us through the event. We believe that your insights and expertise would greatly enrich the knowledge and understanding of our audience. Ladies and gentlemen, it is with distinct pleasure to invite the luminary whose erudite accomplishments have widespread acclaims and garnered well-deserved accolades. Please give a huge round of applause for our chair, Ms. Alka Upadhyay, and the co-chair, Mr. Patrick Malajak. Now I'd like to invite respected DGRD, Shri PVSS Ravi Prasad, to please come up on the stage and felicitate our co-chair with a token of respect. Thank you so much, sir. We shall proceed with the seminar, and for that I request all the presenters to please come up on the stage and proceed towards the high table. And so please let us know if you have any specific requirements and preferences. With this, I hand over the procession of the seminar to our respected committee. Thank you so much.
Maybe I can invite Ms. Alka Upadhyay, the chair of the session, to initiate the session. From a distance, of course, but you are here with us in spirit in this room. Thank you.
I really appreciate that I have been allowed to join this session virtually. But in all fairness, I think it would be better that the co-chair takes up the proceedings from here on. I will, of course, be in a listening mode, and at the right time, if the co-chair feels that there is a point of interjection, he may do the same. I thank all of you in this very, very important session. And as I just said, I'll just start very, very briefly over here. As you're all aware, India is right now in that stage that we are gaining a lot of experience. And as we had said earlier, we would like to, and also the Honorable Minister said so in his speech today morning, that we would like to adopt the European standards, we would like to take up the construction technology, get the best of construction technology to fasten the pace of construction of tunnels. And of course, all of this can only be done if we have a very proper design, investigation, and also a knowledge of the structure that has to be taken up when the tunnel constructions are being, in fact, steered in the country. I would also like to mention over here, and as this is a sequel to what I had said in the morning, that there is a need for protection of the ecology, and also there is a need for optimization of cost. I'm sure when we are doing this the designing of our tunnels, if we are able to take up these issues, we would be having very cost effective and sound tunnel regime or ecosystem in the country. I also take this opportunity to kind of educate our contractors in the ecosystem who are really the leaders, or who are really the people who are taking forth this entire task of tunnel construction in the country. With this, I hand over to the co-chair to take further the proceedings, and I'm here in listening mode, and as and when I feel there is a point for interjection, I would also come in, but over to you, the co-chair.
Thank you very much, Ms. Secretary, and I'm very honored by the trust you place in me to chair the session from here today, and I hope I will do a satisfactory job. So first of all, thank you to everyone in the room. Maybe you don't see it, but we have an almost full room here, which is a very good sign of the interest of the delegates in the topic of this session. So this session will address conceptual planning and design for road tunnels. In light of the presentations and introductory speeches delivered by the dignitaries and ministries this morning, I would like to share a couple of thoughts. At PIARC, as you know, we address a large number of topics, tunnels being a very important one of them. And we place this in a context where we have identified a number of key issues that apply to almost all road-related questions. I would like to highlight the topics of resilience, adaptation to climate change, and of course, always road safety. These are cross-cutting issues, I think, and I would be very interested in the course of this seminar to hear and learn more about how our colleagues from international expertise fields and also Indian experts address those questions. Having said that, the ministers this morning made it very clear, and the Honourable Chair made it very clear as well just now, that the questions of technology and cost reduction are very important. I think this is a very useful reminder of the framework in which we have to position those speeches. I would like to add two last remarks before handing it over to the first presenters. My first remark is that we are here to exchange between peers. I don't think that we are here in a situation where Indian colleagues are here to learn from international experts. It goes both ways. We are here in a very hilly part of your country. The Himalayas are just on our back. You have built tunnels, very long tunnels. I'm sure you have lots of experiences to share with colleagues from Germany, Japan, Australia, and elsewhere. So don't be shy. Please ask each other's questions and maybe even conflict opinions about how to address address issues. Something else that was mentioned, and I think it's also going to be a question that will be undercurring during our seminar, is the Made in India aspect. Just a few months ago, I think a company which is very famous for its phones, Apple, developed new partnerships to manufacture those pieces of technology in India. So I think the call from the minister to have more made in India technology and products and processes is, in that context, quite illuminating. I will end here. I will invite the speakers to try and stick to the time as much as possible. I will invite all delegates here to note sessions that they will have for the Q&A part of the session, which will take part after all three presentations. Please make notes so that you don't forget. And I'm sure there will be lots of remarks that you will want to share with the presenters. Without further ado, let me invite Mr. Rahul Gupta and Mr. Svetab Singh from India to deliver the presentation. It's a joint presentation, from what I understand, on planning and design of road tunnels in the Himalayan region. Thank you. You have about 20 minutes for the presentation.
Thank you, Chairman, Madam, Co-Chair, Patrick, learned delegates, PIARC Executive Committee and Tunnel Committee members, officials of Government of Uttarakhand, consultants and contractors, fraternity present in this seminar, ladies and gentlemen. I will begin with a glimpse of Indian road network, which has been highlighted by various speakers in the inaugural session. India has the second largest road network in the world, and the national highways constitute only 2.29% of this network, but they carry on 40% of the traffic on Indian roads. There are some major national highway development initiatives which are already presently under implementation in the country. There are Bharatmala, Char Dham Pariyojana that is being implemented in the state of Uttarakhand, and there is special accelerated road development program for the northeast region of the country. As regards tunnel on national highways, this is the status of tunnels on the national highways. चल नहीं रहा है.
Please bear with us. There seems to be a minor technical problem. I'm sure it will be sorted very soon. Thank you.
माउस कहाँ चला गया माउस
Yes, sorry for the interruption due to some technical glitch. Now, coming on to the tunnels of national highways in the country, this is a status of the tunnels which are under operation. Around 45 kilometers of total length is presently under operation. 120 kilometers of tunneling is being carried out. and another 192 kilometer of tunnel length is under DPR. And we expect that by year 2028, around 355 kilometer tunnels will be operational in the country. This tunnel net will constitute, the tunnel length will constitute only 0.2% of the total NH network and 1.4% of the national highway length in the hilly region. These are some major tunnels which are operational in the Himalayan region, which has been highlighted by various speakers and none other than Honorable Minister of State in his inaugural address. The Atal Tunnel, also known as Rohtang Tunnel, a 9.2 kilometer length tunnel. Chenani Nashri Tunnel, it is 9 kilometer tunnel, and Banihal Kajikund Tunnel, it is 8.4 kilometer long tunnel in the state of Jammu and Kashmir. Thus, these construction of these tunnels has significantly affected savings in the distance as well as in the travel time. These tunnels also ensure uninterrupted movement of vehicle at an average speed of 60 km per hour as against 20 to 30 km per hour in the absence of a tunnel. These are the status of some major highway tunnels under construction, and the noteworthy is Jojila Tunnel on National Highway number 1 in the state of Jammu Kashmir and in the UT of Jammu Kashmir. The total length is around 14 kilometers, and the tunnel is being constructed at an elevation of 3,528 meters. And future speakers, especially from the employer, National Highway Development and National Highway Infrastructure Development Corporation, will give a presentation on this tunnel. Ladies and gentlemen, planning and design of tunnel is a vast subject. And it is not feasible to limit it within the allowed time of 20 minutes for this presentation. Therefore, me and my colleague, Mr. Shwetab, will limit the deliberations to salient aspect of planning and design of highway tunnels in Himalayan region. Himalayas are one of the youngest mountain ranges on the planet and are still growing. Thus, their growth makes them tectonically active and a geologist paradise, resulting into numerous challenges to tunneling community. The tunneling community faces with thrust, fault zones, shear zones, folded rock sequences, high seismicity, ingress of water and gases, geothermal gradients during the construction right from the planning stage. These factors result in the increased cost and the completion period. Extraordinary geological occurrences are a serious issue in the Himalayan region. Limiting working period due to adverse climatic condition and avalanche-prone sites is another factor. Buckling of support systems or lattice girders due to squeezing ground conditions and chimney formation is a serious issue. Absence of risk-sharing mechanism between the client and contractor is also another issue which we needs to address. The end result is that every aspect of tunneling, from its conception to commissioning, is influenced by the geology. Now, coming to considerations in planning of tunnels, the important factor influencing the planning and decision making is the providing connectivity to remote areas in the Himalayan terrain. We have to provide connectivity to different population clusters, whether they are villages, district headquarter towns, state capitals or national capitals or interstate cities. Development of strategic connectivity in border areas, another factor in the planning of tunnels. Preservation of forest land, reserve forest, eco-sensitive zones and wildlife has to be affected while planning the tunnels. The rapid urbanization of Himalayan towns, glacial water bodies, natural aquifers pose a challenge in developing the sustainable transport connectivity of the future and has to be catered in while we plan for construction of tunnels. So, to me, each and every tunnel project in Himalayan region is unique, primarily on account of underground underlying uncertainties of the geological strata, the planning of road tunnels requires detailed site investigations and studies, and it comprises of two essential parameters. First is functional requirement, and has to be planned accordingly based on the operational requirement. And second aspect of the planning is objective planning. As regards functional planning, the connectivity network analysis of the existing national highway, state highway, major district roads, and other roads with the project corridor where the tunnel is being conceived. The development option for different possible alignment for provide maximum connectivity to the dwelling areas in and around the target city and towns. Assessment of the traffic characteristics, all weather connectivity throughout the year, that is one of the major consideration in high altitude areas. Finding solution to over-urbanized Himalayan towns without disrupting the existing ground and surface development. Mitigation of risk of depleting forest blocks, reserved areas, and conservation of wildlife. Reduction of the intervention with the eco-sensitive zones and provide safe wildlife corridors in the Himalayan landscape, which is the habitation of one of the most exotic set of flora and fauna over the globe. Now coming on to the operational requirement, the transport mode planning, whether it is a highway, urban road, railway, metro, mixed mode, which has been now a new concept in the Government of India, that the same tunnel can be used for the road as well as for the railway network. Traffic characterization and volume, lane configuration and lane utilization through bidirectional and unidirectional movement, capacity assessment and future space utilization, environmental risk and their mitigation planning, econometric planning, that is the socio-economic dividends and the return on investment analysis for the economic feasibility of the project, that are also being catered at the planning stage. So, the only codal provision which has been published by Indian Road Congress provides a decision-making flowchart for adopting the bidirectional single tube with escape passage tunnel or unidirectional twin tube tunnel for cross passes for emergency situations. The factor considered in deciding, and this chart you can see depicts the categorization of tunnel into various types. The factors considered in deciding single tube versus twin tube options are the length of the tunnel and volume of traffic. In general, the highway tunnels in a length ranging from 2,000 meters and up to 10,000 meters under category A and category AA for traffic volume above 10,000 average annual daily traffic are being considered for twin tube configuration with unidirectional flow. And highway tunnels with traffic volumes ranging between 1,000 and 10,000 ADT under category B and A have been implemented under bidirectional traffic flow with single tube and an escape passage. I will come on to how they have been implemented in the field. So this is a typical case of a main tunnel with escape tube bidirectional traffic flow, which has been adopted for Chenani Nashi tunnel. This is a twin tube unidirectional flow with two-lane pavement, paved shoulder, inspection gallery, and a pedestrian footpath. This has been adopted in the Ramban Banial tunnel cross section. And third one is, it's a bidirectional traffic tunnel having a parallel escape divided by a curtain, and it comprises of inspection and pedestrian footpath also. It is being adopted in Ojri tunnel in the state of Uttarakhand. The second aspect of operational requirement is the tunnel services. That is tunnel ventilation, tunnel lighting systems, and communication systems. Now coming on to the objective planning. After considering the functional requirement, we arrive at the objective requirements. So for Under the objective planning, exhaustive public consultations are carried out and user requirement study, including local and district administration consultations, are carried out along with the interdepartmental deliberations. Geological mapping and the risk hazard assessment is carried out, and thereafter the structural conceptualization is being done for determination of construction methodology based on the geological risk and hazards. Thereafter, the construction methodology is finalized, structural design planning is done, services and safety installation planning follows after the structural design, operation and maintenance objectification, and O&M phasing with the civil and equipment monitoring, testing, and replacement planning. The end result is to achieve the connectivity assessed based on following metrics, that is, reduction in travel time, where a ratio of 1:4 to 1:8, that is a ratio of tunnel length to that length of the equivalent open highway in hills area, has been found to be techno-economically viable in Himalayan landscape. This is based on our experience. All-weather connectivity across the snow-laden routes and mountains, landslide-prone zones in monsoon period, removal of choke points, development of bypasses, and facilitation of ring roads as well as urban connectivity enhancements. Significant reduction in land acquisition and the forest land clearance, for which a ratio of 1:20 to 1:18, that is a ratio of land acquisition area for tunnel construction to the land acquisition area for equivalent open highway in hills, have been found to be techno-economically viable in Himalayan region. The next aspect of objective planning is the sustainability of the project in terms of air quality, maintenance, fire safety requirements, revenue generation for potential tolling and non-tolling commercial activities for economic and maintenance of sustainability of the facility. The viability of the project for implementation of public-private partnership mode and sustainability of the project with monetization option is also being explored under the objective planning. Indian Road Congress has published a detailed guidelines for road tunnels, that is Indian Road Congress Special Publication 91/2019. This is the only road, guidelines available in the country for the construction of highway tunnels. Besides that,
excuse me, you have about 5 minutes left for both aspects.
We also adopt various guidelines available across the globe, customize them for Indian conditions, and design the tunnels accordingly. Now my colleague, Mr. Shweta Singh, will further deliberate upon the designing of the tunnels. Shweta.
I extend my gratitude to the Honorable Chair and Co-Chair. A warm good afternoon to the distinguished guests and all participants. And I thank you, Rahul Gupta ji, for the presentation till this stage. So I'll be taking the presentation further into the design aspects of Himalayan tunnels. So briefly, these are the processes that have been ingrained in the system of designing in India. Which includes the investigation, after which more or less we get to understand, which acts as the basis of the decision support for the method of tunneling. Either it has to be NATM, TBM, or DNB method. Now, since we are talking primarily about the Himalayan tunnels, most of the highway tunnels that we are doing, in fact, all the highway tunnels that we are doing right now in the Himalayas are NATM-based technique tunnels. Then after this stage, we reach the ground characterization, support matrix development, portal development, drainage planning, estimation, and the development of technical schedules for the BOT or the concessionaire for the project, which is to be done on the HAM model or the BOT model. Briefly, since we are going to discuss extensively on the concepts of design, I'll showcase very briefly the concepts of NATM, which includes the profiling, face drilling, charging, blasting, defuming, mucking, scaling, and sealing shotcrete, lattice girders, monitoring, of course, a very important part of the NATM sequence, with the initial shotcrete lining and rock bolting grouting. Now, to elaborate upon the Indian scenario in the Himalayan region, we present here 3 case studies, a very quick case studies on the design aspects and the important and the lessons learned out of the designs for these projects, which are in various phases of implementation right now. So Ramban Banihal Tunnel, this is in the middle Shivalikas in the state of J&K. There's a stretch around 30 to 35 kilometers between Ramban and Banihal, which is fraught with landslides and is a geological hazard, for which the diversion has been created through a network of tunnels. Kilometers and approximately. This is a typical cross section, and what you can see here is almost it's 12.5 meters excavation width and almost 12.8 meters of the crown height from the finished invert level. From the outer invert level. And what the material characterization, the ground characterization based on the RMR and the derived material properties which are used for the analysis of these tunnels. This is a typical FEM analysis which was done before the construction started during the DPR stages, along with a theoretical GRC curve, ground response curve. And this is the classification matrix. So what we have here on the left side is the classification system. Classification system primarily consisting of RMR and Q-based system, and then overlapping it and correspondingly developing the support matrix for the given classification system. Most of the rock formations here are schist or highly weathered sandstones. Second case study that I bring forth is Bhanupalli Bilaspur Bheri Tunnel. So this is series of almost 9 tunnels cumulatively, which would be around 17 kilometers, with the minimum length ranging from 300 meters to a maximum length of around 4 kilometers, with and this is under construction, and some breakthroughs have been achieved on this tunnel. What we can see here, which is of and the ground along with system. One is the RMR system. The important point that we draw out of this analysis, this is the numerical analysis which was done before the excavation started. And based upon this, the support matrix was prepared. This is for a typical class 5 rock, which is ground type 5. And once the data has been received from the site, that is the deformation data, and the face log has been done, and the deformations have been noted, which can be seen in the last column on the right side. A back analysis has been performed to optimize the supports, and the optimized support looks like this, where the SDA bolts spacing has been increased and the spacing of the pipe roofing have been increased. And the deformation obtained after this matches perfectly with the deformation that were obtained at the site by monitoring data, by 3D monitoring. Then quickly I'll come to Sungal Tunnel. This is a tunnel which is being constructed in the lower Shivalikas, mostly interbreeded with sandstones, siltstones, in highly fractured geology. So before the construction started or before the excavation started, the predicted rock line was almost 17 meters. While the excavation started and the were discovered, rock line was found at almost 9 meters below the natural ground level. So generally what we are trying to bring out here is that the investigation that is done before the construction starts, and while we are constructing, as it happens in the NATM, that's why we have a tool like NATM, there is a significant and stark differences that we come across. Ground characterization, as I explained earlier. And this is the numerical analysis. And what we can see here is the variation of the maximum, the major principal stress from maximum to minimum range for different ground conditions. I would like to conclude by saying that the importance of geological mapping and geotechnical mapping superimposed with the geophysical investigation cannot be denied to reach a stage where the parameters for the design, the strength parameters that we are looking for, are optimized and give us an optimized solution. Selecting the right strength criteria, which in almost all the cases here is either the Moore-Coulomb criteria or the generalized Hoke-Brown criteria, depending upon the situation and condition of the site. So this is the three pillars of our design in the Himalayan tunnels, where based on the rock class, we do the rock behavior analysis and the support classification, and provisions for the risk mitigation pertaining to cavity formation, rock burst, squeezing condition, water ingress, and low cover zones have to be incorporated in all designs, which has now become a part of all the technical schedules that are being prepared for the EPC or for the concessionaire agreements. For recommendation, I'll hand over to Rahul Gupta. Thank you.
Thank you, Siddharth. Yeah, in order to have a robust planning and design mechanism, the following are the recommendations which emerged out of our presentation: that airborne electromagnetic surveys to map the surface geology in Himalayan tunnels having high overburden may be considered. For fast-tracking the tunneling process, TBMs are to be adopted for construction of long tunnels. As rightly said by our Honorable Minister in his inaugural address, the adoption of digital technology will be a game changer. To develop standards and guidelines and best practices for road tunnels in India is a need of the hour that requires updation of Indian Road Congress codes, develop manuals for surface and subsurface investigation, tunnel excavation, tunnel lining, firefighting, ventilation systems for Indian Himalayan conditions. Development of case studies incorporating the best practices across the world. Further, there is a requirement of standardization of inspection and operation and maintenance practices, and develop a tunnel asset management system and tunnel digitalization center in the country. Thank you very much.
Thank you very much, Dr. Gupta, Dr. Singh, for this presentation. Again, to every member of the audience, please set aside the questions you will have, and we will make sure we have time for the questions and discussions later in the session. I would like to invite our second presenter, Mr. Herald Wagner, who is a consulting engineer in Thailand, and he will introduce us to NATM tunneling, instrumentation, and monitoring. Thank you very much.
Good afternoon, and let me just briefly thank the organization team for inviting me to this important seminar. I appreciate it a lot. And the subject of my presentation is NATM. Basically, NATM is New Austrian Tunneling Method, and that raises the question, what is Austrian, what is new? And one of the answers of what is Austrian has been given in a very short definition. You know, Austrian is a mix of Prussians and Bavarians. Austrians have the charm of the Prussians and the flexibility of the Bavarians. Both does not exist, but Austria exists. So we can go to the first slide, maybe. Okay. No, this is still wrong. Yeah. Okay. Oh, here, yeah, up and down. Okay, just to give you a brief bio sketch of myself, I'm a consulting engineer, and people may have a problem to understand whether I'm Thai or I'm Austrian. I'm Austrian living in Thailand. So that is another explanation for the meaningfulness of names. I have been a master builder in Austria. I have been an independent expert for infrastructure for more than 50 years, almost 60 years now. I have been 2 times in my life, I've been a professor academic at the Technical University in Graz in Austria and at the King Mongkut Institute of Technology in Bangkok. I also have been a vice president of the International Tunneling Association between 2002 and 2007 and a member of the Executive Council. I'm a trustee of the so-called ITACET Foundation, which is International Tunneling Association and Committee of Education and Training. As a designer, I published more than 180 papers, and I edited non-fictional books. The one in 1996 was about TBM tunneling and trending machines. Another book on the Kra Canal. We have mentioned today that we have to cross oceans, and also I have been working. I used the time of COVID-19 to write a book on usable grounds, which is expected to be launched in December of 2023. The content of my presentation is listed up here. I think it's also in the souvenir, so no need to mention it again here. Naming tunnels, as I mentioned, with regard to the geomechanical colloquium in 1993 in Austria, it has been questioned, the name has been questioned by international experts, whether it is new or Austrian, or is it a method at all? And so the question is, what is NATM? The terminology is 30 years back. It has been common understanding that there are 2 technologies in tunneling. One, these technologies are competing. One is conventional tunneling, as it is named in the International Tunneling Association as a term. The other one is TBM tunneling. Both of these terms are incomplete, and they don't really match what we understand nowadays as tunneling. I will come to the conclusion that nowadays international tunneling method is a better term than conventional tunneling and TBM tunneling. What is a better name? Yeah, through the inventors of names, there have been other countries also in Scandinavia and also in Central Europe. They wanted to have another name, and I think the better name would be International Tunneling Method, which is close to my understanding of what happens here in India, as I would call it, the Indian Tunneling Method, or IATM, which is significant also with regard to comparison of other names. I would like to briefly mention what are inventions and innovations. Innovations hardly become existing, but almost all the time are inventions the result of a devoted hard work for many years from the inventors. And in each invention and in the spirit of the inventing engineer, there is similarity to the spirit of artists, painters or sculptors. And mostly only the long troubled times, then suddenly the image of the subject or the process of the subject becomes an invention and well known. In the origin of the invention created by the spirit of the originator, it dissolves from its originator and gains, independent from the originator, value and power internationally, which above space and time is able to change the world with efficiency. This slide should show you the classical model of an understanding of NATM. It acts as a complex interactive system with individual elements, support elements viewed in the interaction and interdependence. The strength of the reinforced underground with joint system is governed by characteristics of fissures and joints, roughness, fill, rock material, orientation of the rocks, and so on, plus supplementary contribution provided by the reinforcing elements of the support. The design of ground reinforcement system needs experience. That's what I would like to underline very strongly, plus appreciation of expected conditions. The classical ground structure interaction realizes the excavation and support in stages, with limitations imposed on size of excavation and length of round, followed by initial support systems. Shotcrete lining has an interlocking function and provides early support. Excavation as such is to adequately address the sequence of excavation and support. Structural design shall be based on numerical methods mentioned before, for instance, finite elements. Numerical methods account for ground structure interaction, allowing the ground to representation and enabling the process of sequencing. This picture shows, and first time also mentions, new Austrian tunneling method in the context of SEM. SEM became invented by one of the former presidents of ITA, and it means sequential excavation method, which is correct, which is also another name. And this slide shows you in 8 stages, starting with excavation and mucking and installation of lattice girders, rock bolting, bench excavation, invert excavation, and finally final lining installation with cast-in-place concrete, the sequential excavation. What is the request for NATM, SEM, or whatever you call it? The modern transport tunnels for railways, highways, urban mass transit are challenged by the request to strengthen the engineering capabilities using innovative technologies in project delivery and in quality management. We have a very dynamic population development, and there are 8 cities mentioned here where you can see the difference in population in millions between 1950, 1970, 2000, and 2015 for London, Cairo, New York, Mexico, Lagos, Shanghai, Mumbai, Sao Paulo, and Tokyo. And the winner here definitively is Mumbai with the population extension. Transport is always related to the consumption, in particular, of petrol products. And this slide should show you an extrapolated scale of the United States petrol production with regard to transportation and consumption between 1970 and 2035. Just a moment. Something happened. It does not move. Maybe I can. There's a problem, yeah. We are almost half through. Battery is low, okay. Sorry for the interruption. Continue. Okay. not connected. Okay, let's go to 15, I think. This one? This one, yeah. This is very quick. It needs professional planning to effectively mitigate risk and hazard in underground construction. We will have another risk management lecture during this seminar. And it also requires professional planning of networks to enable and safeguard future expansion and extension of projects. There is a population trap because when I started university, I was remembered that 2 billion people have been living on our planet. Now it's almost 8 billion people, so it's 4 times the amount. In particular, in the Asia-Pacific region, we have about 4.5 billion people, which is home also to 63% of the global population. With regard to the gross domestic product on a global basis, the region is accounted for 37% of the global GDP. By 2040 is expecting to rise to 42. That only indicates already the economic development and dynamics of the economy. The urban population has expanded to 2.2 billion, or 54% of the global population of the earlier times, projected for 2050. There's an additional 1.2 billion people in urban areas, only in urban areas, to be expected. What are the goals of the transport tunnels with regard to environment, mobility, public ownership, and infrastructure? The demographic change and economic growth is coupled to the appreciation, or with the appreciation, of the United Nations Sustainable Development Goals. Mobility and access through efficient system performance is also major issue, in particular to safety, sustainability, resilience, supplies driven by financial and energy resources, governance. It's X again. So something is wrong. Okay. I think basically for this part of the lecture, I have covered most of the project, even if the last few slides cannot be shown. It can be shown in the afternoon at session 3A. I'm going to again provide information on innovation. That is very important. I would like to mention about 20 different innovations of the past 10 or 20 years, which have been successfully applied in the industry. And with that, let me conclude and thank you for your attention. I think I have been within the frame which I was given. Thank you very much.
Thank you very much, Mr. Wagner, and sorry for the technology failure. So technology is a complicated beast. As you have noted, Dr. Wagner will also be speaking in session 3A on innovation. So it will be very nice if many of the delegates today could make a plan to join him in this session. I would invite our third and last panelist, Dr. Singh from IIT Roorkee, to join us and to present on computational methods for design of tunnels, and the system, and the IT system seems to be back on. Thank you very much. Fingers crossed.
It's not working.
Is it? Shall we operate it from there? Is it okay?
Where?
From the back screen. You can just press front from here.
Okay.
Okay.
So I can see the slides over there, right? Okay. You can use this pen drive. My presentation is in this. So should I come there? You just take. Just a little bit change. I have some changes, so you can. Good afternoon to everyone, and thank you to the chair and the co-chair for allowing me to give my presentation on computational methods for design of tunnels. So my topic would be more inclined toward what are the methods available for the tunnel design, and in which scenario which method should be adopted. So I will be concentrating on to that aspect of in this presentation. So to begin with, whenever we are going for any design of a tunnel, so first thing we should be knowing what is the purpose of that construction. Either it can be a road road tunnel, or it can be what we generally call as a highway tunnel, or it will be a railway tunnel, or it can be an HRT or something of that kind. So you should know the purpose of it, and you required what? Next thing is required is you should know the where you are constructing and what are the properties of that area around. Okay, so these are the two prominent things which you require. And once you know these things, you go for the design. Okay, and when you are going for the design, what we are having three methods at our disposal for the design. First one is an analytical method, next one comes as an empirical method, and the last one comes as our numerical method. So I have put in the sequence analytical first because that is what I love most in doing research in, and then I put an empirical, and last put I had the numerical. Numerical also I do a lot of work, but empirical is something which is very much important because as we know, some things we cannot handle very much, with a very high degree of accuracy in our analytical models because of the boundaries or whatever the axioms we have defined for our problems. And under that constraint, limited amount of flexibilities can be allowed in analytical model. Whereas when we are going for the numerical analysis, you need to know the material behavior or material properties very well to have a very good numerical model. So sometimes it is very difficult to obtain these things, and empirical methods come as a result. So I put that in the middle. So my presentation will be focusing on the numerical methods. So the numerical methods, basically we are trying to solve a boundary element problem. And when we are solving a boundary element problem, we are working with two types of models. One is continuum based model, another one we call as discontinuum model. So let's see what are the categories of continuum model. We have finite difference model. I think most of you who are in the tunneling industry might be using FLEC. FLEC is a commercial software which is working on FDM. Then there's a finite element method. Again, RockScience software phase 2, or nowadays it's called as RS2. It works on finite element. You have a boundary element method. Earlier, there was used to be a very free tool provided by the RockScience group, which was called Examine 2D. Examine 2D was working on the principle of boundary element method, and there is a lot of research is going on, or previously it has been also conducted in the area of coupled finite element and the boundary element method. So this method, which is coupled finite element and boundary element method, in this we are trying to use the positivities of two methods. One is boundary element method. In the boundary element method, we have to go for the discretization of the boundaries where we know the solution of a problem. Whereas in a finite element method, we have a complete domain has to be discretized. So thing is, more the discretization, more the number of nodes, and more the computational time will be taken by the system. So if we merge these two together, then we can use the potential of a boundary element as well as the finite element. Now you can ask me that if a boundary element method requires lesser computational time, then why we are not using the boundary element only. The thing is, boundary element method works very well when you are having a linear system. And as my friend Shwetab has already discussed in his presentation, the Mohr-Coulomb model and Hooke-Brown model, these are not a linear model. Okay, and when there is a non-linearity, so your boundary element cannot work very well. So, but you know there is a certain reason in the tunnel where the linearity will be coming into picture. So those regions can be modeled very well with the boundary element method. So there is a coupling can be done between these two. The majority of the continuum models are being used for modeling the isotropic rock nature. It is nowadays been modified for anisotropic, but in anisotropic, when you are using discontinuities in the finite element, your discontinuities are considered as a weak discontinuities or weak. Why it is a weak discontinuity? There is not a sudden jump of displacement you cannot obtain in a finite element. Okay, so that is inbuilt problem which is there in it. So we go for another kind of modeling which is we call as a continuum modeling. In a continuum modeling, we have again different methods or models are available with us. We have discrete element method. I think everybody will be aware of UDEC over here, which works on this principle. Then we have another thing which is a particular flow, Claude or boundary, bounded particle method. These methods are not in general use for rock mechanics purposes. More or less they are used in the soil mechanics, but they are still at very initial stages because you are trying to model each and single grain of soil in this when you are modeling a particle flow code. And when you are modeling in each and single grain, then the problem of multiple variable comes into picture. Your computational, for doing the computational analysis for that, the RAM size has to be too large and all those things come into picture. So still, this model is still in the stages of, element level. But people have tried to integrate this model into a, complete finite element model by integrating, in a sense that they try to simulate a small specimen using PFC, and whatever the output they are getting from that PFC, they are using in the finite element as a constitutive relationship. So that way they are trying to use the particle flow code. But still, this is not which we generally use in our rock mechanics. Next comes displacement discontinuity method. Displacement discontinuity method is based on linear fracture mechanics. And in this method, you have a potential to even model the fractures, its propagation, how it will be moving, and all those things you can do in displacement discontinuity method. Here it is a combination of boundary element method and the fracture mechanics. And when I'm talking about the boundary element method, again one thing has to be there in the mind. It should be a linear system, so it work on linear fracture mechanics. The last one which I will be discussing in this slide is finite discrete element method. Here you are using the discrete element principle where you are allowing displacement to take place suddenly at a point, and here you can even model the fracture pattern, fracture propagation, and everything of that kind. And this is by the help of using a finite element or finite element philosophy near the correct boundary level, and the boundaries of the fractures are being modeled using the discontinuum approach. So now the thing comes when I'm talking too much about continuum and discontinuum and saying that my continuum approach is very good for isotropic material and for anisotropic material. That's why I'm putting that much focus. Going for any construction of tunnels so you will be encountering. Okay, so the thing is, when I am converting that rock which is there into a model, into a rock mass, isotropic mass with homogeneity, which conclusion slide. So first thing with this presentation, I want to conclude with that we should be aware of what kind of model we should be opting for our problem. Okay, either should be a continuum base or discontinuum base. It will depend upon my cavity size or what is my tunnel size and what is the discontinuity patterns which I am seeing where I am constructing my tunnel. Second thing is I should be aware of what are the limitation of my modeling, means what is the material model which I have chosen, what is the limitation of it, what is the limitation of my, if I am assuming a discontinuous model to be a continuous model, what are the limitations will be coming arising of due to that. All these things should be, predetermined or should be there in your mind, because finite element method or any numerical technique is good if you are good. And if you are bad, then it can give you a very, very, very disgusting results, okay, and can cause a lot of problems. And next thing is, which I think Shwetabh also discussed in his presentation, that it is not all the time possible to obtain the parameters very accurately for our numerical modeling. So it is always preferred that we should go for the back analysis, obtain the right parameters, and it will help us in the optimization of the support system. So with that, I would like to thank everyone for listening.
Thank you very much, Dr. Singh. I will invite you to come back to the table here, and we are nearing the end of the session, unfortunately, but I think we have time for a couple of questions from the audience. So if you have questions, I suggest you raise your hand. There are probably microphones that you can use, and please introduce yourself, and as well as introduce or name the person you are directing the question to. See a question here from the front row. It would be nice if we could have a microphone. Otherwise, please come to the stage and use one of those. See? Yeah, a microphone is coming. It's on its way. Yep, the microphone is on its way. Thank you.
This is regarding Dr. Aditya Singh for the different methods of design and modeling. There is one method you have mentioned, that boundary element method.
Yes, sir.
Is it possible to apply this method uniformly for the tunnels, which is under the river or sea? Because here you are discussing the rock mass. Only rock mass, but here it is a heterogeneous. Water body mass is also over the rock mass. Therefore, in that case, what shall be our additional conditions to apply this boundary element method?
So, boundary element.
If it is so, then can we say that this method is equally applicable and equally advantageous and efficient for both the cases?
Okay, thank you for the question. Boundary element method is being generally used for linear system, means if you are assuming your material to behave linear elastic. So if you are talking about your problem, it could be possible that your material behavior is not linear elastic, and when material behavior is not linear elastic, it is not recommended to use boundary element method. Because boundary element methods give basically to you is the elastic solution to the problem. Well, when I am saying you can use the boundary element problem for the problem is you have to couple it with the finite element. And if you can, everybody knows that near the boundary of your excavation, you have a plastic zone where the non-linearity is basically coming into picture. And as you go away from your excavation zone, you are going into more, linear behavior of your rock mass. So where the more linear behavior of rock mass is there we can use our boundary element method to obtain the results. And when you are coming closer to your excavation, there again you have to go for your finite element. So again, this is an more or like academic way of dealing with the problem to to reduce the time for computation of often a boundary element problem. So this is a two methods when we are combining just to reduce the computational time. And I think I might have answered your question that if your material behavior is linear, then only you can go for the boundary element.
Thank you. Thank you, Dr. Singh. Is there another question from the audience? I know there will be opportunities during those 2 days to interact with the speakers and the experts, but if you have questions now, feel free to raise your hand and introduce yourself first. Thank you. I see a question here from the floor. Thank you, sir.
Good afternoon. I am Abhay Kumar, ex-Chief Engineer from Ministry of Defense. I just wanted to know from the MORTH and IRC whether they consider any internal blast, accidental blast, for design of the tunnel, especially in strategic connectivity in the border Himalayas. And then what are the measures are considered in planning and design for preservation of forest at edit, mouth of the tunnel, versus cost consideration? And what are the limiting gradient in the border areas of the Himalaya they are considering? Does above activities, criteria result in any special category of tunnel apart from category mentioned by the MORTH officers? Then my Dr. Aditya's question is there.
Excuse me, I suggest we start one by one.
Okay, thank you.
I understand that this question is directed at the first panelists. So Dr. Gupta or Dr. Singh, maybe you want to handle this. Thank you.
Good afternoon, sir. Thank you for the question. If I can recall the order of your question, the first question that you asked was the effect or whether the blast load is being considered for high altitude tunnels.
Internal accidental blast.
Yes, sir. So that is what I was referring to. Generally, sir, when the blast load is considered as per the given codes that we are referring to for the normal highway tunnels, limits the release of the energy up to 50 megawatt for whatever tunnels we have been doing as far as the impact on the structure is concerned. I'm not talking about the fire suppressant system, which can claim up to suppressing 200 megawatts of fire. So theoretically, no, because any blast that occurs of the magnitude that we are talking about would be more than 150 megawatts. And if we are talking about the fuel containers or any military vehicle which is containing the ammunitions, etc., yes, if any strategic requirement is there, those kind of tunnels can be designed with a higher lining thicknesses and other provisions for safety evacuation. But till now, it's not being done as far as I am aware. If I come to the second question that you have asked about the gradient requirements. As such, the Indian code, that is IRC SP 91, limits the longitudinal gradient to 3%, but that is a limitation for the commercial vehicles. Yes, as we move into the higher altitude for the projects which are being done for strategic purposes, which are being used for military application, the gradients up to 4 or 5% are being adopted, and it's being done in various border states right now as far as the DPR stages are concerned, because military vehicles can negotiate these gradients. Now, I did not get the third question of yours, sir.
At the edit and mouth, what are the planning consideration being done to conserve the forest and the big trees?
Sir.
At the edit and the mouth, whether any cost consideration also affecting this planning?
Sir, I'll answer it in a different way. What I understand when you talk about the face of the edit, you're talking specifically about the portal locations. Generally, in Himalayan geology, we haven't had the liberty of placing the portal wherever we want to because of the geological limitations and the geological challenges we have. So, first thing that we look as the DPR consultants or the designer in such scenario is retaining is to minimize the excavation or the cutting effort of the hill slope for creation of the portal. In case that is not possible, then the first impetus is in slope stabilization through various geotechnical support means that we have at our disposal. And probably once the stability aspect has been covered properly, that is when we look into the conservation of the forest or the tree area. I mean the plantation area which is in the region. And generally, if any deforestation or any tree cutting activity happens, probably it doesn't extend beyond 100 meters of the width and the portal location. And still, if we compare it with the open highway, this would still give us a better solution for preserving the environment and preserving the forests. So that is why tunnel solution is a more viable solution for environmental factors.
Any minimum cover in this regard is considered for the minimum cover?
In general, whenever we are designing a portal, probably we are looking at least in the Himalayan condition, we are looking at 1.5 to 2 times the diameter of the excavation to be provided as the minimum cover at the portal locations. And generally that is what is being followed everywhere. Nowadays, because of the challenges towards acquisition of the land or, of course, any reserved area, probably the portals are being placed at location where it may not be possible. So the false portal concept is catching up very quickly. And Ramban Banihal is one such project. And then, as I mentioned about the Bilaspur Beri tunnel projects, so most of the portals are being built as false portal, which minimizes the excavation effort, as well as provides the inlet into geologically challenging the faces.
Thank you, Dr. Singh, for these detailed explanations. Thank you very much, and I suggest you continue this discussion. We are over time, to be honest, so I think I will bring this session to a conclusion, and I will ask the chair, Ms. Upadhyaya, to also connect, and I'll ask the technicians at the back of the room to make sure that we can interact with her while this is being done. I will recap very briefly the session. We had a very interesting presentation on planning and design of road tunnels in the Himalayan region, with a number of tunnels under construction and lots of complex challenges that have to be taken into account, linked to the risks and the climate and the need to protect the environment. And a number of standards are being used. We heard an unfortunately truncated presentation about the NATM tunneling method and other methods, and I'm sure we will have further opportunities to hear more from Dr. Wagner. And last, a very detailed presentation on computational methods, which introduced us to the variety of models that are available and the need to confront them with real-life data to make sure we select and use the good ones. This will be, in a very few words, the wrap-up of the session. The presentations will be made available. So you have received this pamphlet. The presentations will also be made available on our website so that you can consult them, even the slides that have not been shown. And I will invite Ms. Upadhyaya, if she's available, to share closing remarks with her. Okay, so this will be my closing remarks. I will thank our panelists. I would apologize for the IT glitches, and hope they will be sorted for the next sessions. And again, my sincere thanks to everyone at RRC and at the IT University in Dehradun who've organized the sessions. And I invite everyone to prepare for the break and to join the sessions that are taking place this afternoon and tomorrow. Thank you very much on behalf of PIARC. Thank you.
I request the dignitaries to please kindly be seated. I'd like to invite Shri S.K. Nirmal, Secretary General IRC, to kindly come up on the stage and felicitate the distinguished guests at the high table. The co-chair, Mr. Patrick Malajak, Secretary General, PIARC, Mr. Rahul Gupta, Mr. Shwetab Singh, Mr. Harold Wagner, Consulting Engineer, Thailand, and Dr. Aditya Singh, Assistant Professor, IIT Roorkee.
Very good handling of questions also. Very detailed analysis. Thank you.
Thank you, sir. I would also like to inform all the guests present here that a parallel technical session on sustainable road tunnel operation will be held on the first floor of Vishwakarma building. With this, I declare this session for a hiatus and request everyone to enjoy the lunch with us at the Vedanta Reception Hall. We shall continue with the scope of the seminar after lunch in the auditorium. Thank you so much.
So lunch is available at ground floor, same place where you had tea. Please. We reassemble at 2:30. दिया शेड्यूल आपको?
ये अपलोड कर लेते सर ऑलरेडी 2.
अच्छा. Or 2:45, huh? So we try to reassemble at 2:45. Thank you.
वहाँ पे सर फोटो अभी बहुत बेकार है. अभी सर उधर से ऑपरेट कर रहे हैं क्योंकि इधर ये कंप्यूटर चेंज कर रहे हैं और उधर से ऑपरेट कर रहे हैं सारे. ठीक है, वो बेहतर है. तो आपका भी इनका भी नहीं, इनका ऐसा उतना कोई इशू नहीं. अभी सर आगे से वो कर लेते हैं. ये रिप्लेस करके ना जो नया वाला कंप्यूटर
पावर चेक करवा रहा हूँ ढंग से.
अभी आप लोग रहेगा ना इधर, इसके ऊपर का कहा ये है क्या, ये ठीक है।
Good afternoon, everyone. Now we are going to start the third session, that is the 3A, on the latest development of tunnel construction. In this, we will have three representations from three experts presenting on the execution of India's longest TBM tunnel project in the tough Himalayan terrain of RVNL by Christopher Cooper, Austria, and Mr. Rakesh Arora, L&T. Second will be on permanent line-in material for the tunnel by Mr. Harald Wagner, consulting engineer, Thailand. And the third will be on the TBM tunnel included instrumentation and monitoring by Mr. Nitin Garg, Director, Business Development, Private Limited. The chair of this session is Shri PVVSS Ravi Prasad, DG RDNSS, Ministry of Road, Transport and Highway, and Honorary Treasurer, IRC. And the co-chair for the session is Shri Amrendra Kumar, Chief General Manager, National Highway Authority of India. I request the chairperson and the co-chair to kindly come on the dais. And I request Mr. D.K. Sharma, Chief Engineer, MORT, to please kindly come on the stage and felicitate the chair and the co-chair. I request all the presenters of this session to kindly come and join the chair and the co-chair on the high table and conduct the technical session. Thank you so much, sir. With this, I hand over the stage to the committee.
Good afternoon. So, in the post-lunch session, capturing the attention of the audience is a challenge to the speakers. So, I would request the speakers to be a little more extempore and concentrate on the aspects related to practical execution and where we can reduce the cost so that it will be interesting as well as will meet the ends of our Honorable Minister's mandate that we should work towards cost optimization in the tunneling. So in this session, we have got 3 speakers as explained by the comparer. The first one is execution of India's longest TBM tunnel project in tough Himalayan terrain by Mr. Christopher Cooper, Austria, and Mr. Rakesh Arora, L&T. Then permanent lining material for tunnel by Mr. Harold Wagner, consulting engineer, Thailand, on my left. Presentation on TBM tunnels, including instrumentation and monitoring by Mr. Nitin Garg, Director, BND, Herring India Private Limited. So now I would request Mr. Christopher to make his presentation.
So, very good afternoon to you all. This presentation, myself and Chris, we both will be doing. Chris is here with me. So, just to start with, these are the photographs. You can see the casting yard, our stacking yard, and the main bearing in between for the TBM when we were assembling the TBM, and the tunnel which is finished by TBM. So myself, Rakesh, and then Chris has joined, who is the expert with us for the tunneling, for the execution of the TBM tunnel especially, and his 40 years rich experience is very valuable for us for the execution of the project. And then we have Mr. Rajiv with me, who is the project manager, TBM. Was instrumental for assembly of the TBM and for launching of the TBM, and then now he is looking after the operations of the TBM there. Then with me is Shamim Ahmed, who is the project planning and control, who is very instrumental since beginning of this project. So in the planning and resource mobilization. So that way we are executing this project. The slide is not changing there. Anyone? Slide is not changing in the screen. यहाँ चेंज हो रहा है, वहाँ नहीं हो लैपटॉप से हो रहा है लैपटॉप से तो हो रहा है डुप्लीकेट नहीं हो रहा है ना उधर नहीं दिखा रहे ना वो बोल रहे उनका वो आदमी को बुला दो एक बार ऑफ करके फिर रीशेयर करो एक बार ऑफ करके फिर रीशेयर नहीं सर डुप्लीकेट कौन सा चल रहा है ये चल रहा है हाँ इस परफेक्ट ओके फाइन हाँ जी So this is what I explained, myself, Chris, Rajiv and Shamim. Then this is the content which we will be covering today, the introduction brief of the project, then project challenges and how we have mitigated, and then Chris will take up the technical challenges and the mitigation for that. So this is the project which is awarded by RVNL, and Thomas Altinock is the consultant for this. They are designer and the consultant. And the scope is basically 15 kilometer of tunnel, the longest railway tunnel in Himalaya for railways. 60-month duration project, and it's with NATM as well as TBM. So 2 tunnel boring machines, hard rock tunnel boring machines, which we have mobilized for this. If you see, the scope distribution is 70% is with tunnel boring machine and 30% of the scope is to be executed with NATM. So total this project, if you see, there are 10 packages, and what we are representing here is package 4, which is between Devprayag and Srinagar. The length is 15 kilometer, as I said. This is the layout of the project. If you see on the left, this is not as per the scale. On the left, around 600 meter of the tunnel, which we have done with NATM for launching the machines. And after that, there is a TBM drive of 10.5 kilometers. And on the other hand, around 3.5 kilometers of the tunnel, which is to be done with the NATM. So overall, if you see, around 50, and we have launched, one has done more than 500 meters already, and the second one is 200 plus meters. There are different shapes and sizes of the tunnel here. If you see, the biggest one is the 20 meter wide around, which is the station portion actually, around 100 meter, which is double track and double platform. And then we have the double track and this also. This is an overview video which will tell you that how
Portal 1 has all the ancillary facilities to support all the construction activities.
This
The construction of the tunnel is done through new Austrian tunneling method, NATM, also known as sequential excavation method. It starts with navigating the face and constructing it in 6 stages. This is done by drilling the face and charging the respective holes with explosives. Then the blasting is done, followed by muck removal. The exposed rock face is then consolidated using rock bolting and shotcreting for the safety of the tunnel. Similarly, all 6 stages are constructed one by one. The TBMs in operation has a diameter of 9.11 meters and a length of 140 meters. The TBMs are shipped to India in pieces up to Mumbai and Gujarat ports and then gets reassembled at the site in Devprayag, Uttarakhand. The biggest challenge is transporting the over-dimensional cargoes, namely the cutter head, which weighs more than 100 tons, and the main drive, which weighs more than 200 tons, via the valley's steep topography and existing untested bridges. Assembling such heavy machine.
So this was the main bearing, which was 6.3 meter wide. This is OD consignment, 165 ton weight. So last 3 kilometer of the road, which was having the width less than 5 meters. So for that, what we did is that we brought it near to the site, around 25 kilometer from the site. There we rotated it, bring it in the vertical position, then transported using the SPMTs, self-propelled modular trailers. Reached up to the site, again made it horizontal, and then bring it to the site, and then the assembly was done further.
Machinery requires special facilities, including heavy-duty gantries and precise engineering.
So this is how the machine was assembled in front of the portal.
Further, the TBM after
using the modular crane for the first time.
Skid jack system, which is developed in-house by L&T. TBM here is equipped with advanced grouting system and best-in-industry safety features. Segment installation is done by transporting segments towards the feeder using multi-service vehicles. These segments are used to build the final lining of the tunnel using the parameters of boring. The carousel plant is divided into 9 stations, starting from the opening of covers and sides of segment
So for the
molds.
first time in India, we have mobilized the fully automated carousel plant for
Positioning of the
casting of the segments.
Positioning of the inserts,
Otherwise, in all other projects, if you see in India, is all
Concreting and
stationary
vibrating.
plants are there.
finishing off the extra
So
dose.
here the different stations are there for which all the activities are happening.
After which these molds
So
are
molds are
transferred for
moving.
steam curing, where they are cured for 6 to 8 hours. Then the segments are demolded and stacked properly.
Very good animation.
And then these segments are
Portal
stacked
two
to the
includes a stone crusher
stacking
plant,
yard and then
3
shifted
stacking
to the
yards,
tunnel
2
portal
batching
for
plants, a store,
further
and a fabrication
mobilizing
yard.
into the tunnel and erection. This is the third front where we have done the 30-kilometer deep shaft,
Near Portal 2,
and then there are
resulting
2
in
tunnel
2 new
faces
additional faces
which
for
will
tunneling
be
using NETM.
doing the breakthrough with the
This is connected to the
TBM
TBM
drive.
exit tunnel portion,
And
where
after
the
the
TBMs
end of the
break through
project, we
and
have
are
to
then
dismantle the TBMs and then bring it out. So this gives a clear idea of how the project execution is planned. And further one, this is the progress video which gives you an idea that how we have started the journey month by month. So this is how we received the site, and then we developed the complete infrastructure for the project so that TBMs can be launched in time and the NATM works is executed parallelly. So month by month you can see the development, how the site is to be developed and how big infrastructure is required to run 2 tunnel boring machines. The challenge is in the hills that you don't have the land the way you desire it to be available. But whatever land is available with you, how to plan in a good manner and execute the project to beat that challenge is a remarkable work which we need to do. But this gives us one learning also that going forward when we are planning the projects, so for land for the proper infrastructure development and for all the contractors' facilities should be available well in advance, and the infrastructure for mobilization of the big machines. So that infrastructure also we need to give an attention so that things can happen in a faster manner without big challenges. So these are the upline. Left side you can see the upline, right side is the downline. This is a finished tunnel, you can see. So as of now we have done 500 meter plus, so we have to go 10 more kilometers in this. So portal 2 is on the other end of the tunnel, where we are doing the works with NATM, and the casting yard is also developed at that end only, because there we have plenty of land available. So segments are being casted there and we are transporting it to the portal 1. So this is how this site is developed. On the left, that in front you can see the casting yard, and here is our other facilities, labor camp, crusher plant, portal. This is the casting yard. Actual photographs you can see. So it is distributed in 2 plants. Each is having 6 molds, 6 set of molds. So 12 set of molds, and it is able to, you can say, produce more than 500 rings in 1 month. So then we are having the stacking yards. This is the NATM front. So actual excavation in stages you can see, and then further this is the double track portion. So ventilation shaft is the third front. The starting of ventilation shaft excavation, and then we completed the shaft and then started the main tunnels from this. So so this is how we shifted the machineries inside the shaft and then started the excavation works. So I'll move this further because we need to see the time also. So this is what we were saying, that We desire to have this 250,000 square meter of the area, but we have 150,000. So that way we have accommodated all our facilities and trying to do the job in an efficient manner. But it's always good that if we have sufficient land for the infrastructure development. So this was the biggest challenge of transportation of the OD consignment and heavy consignments. If you see on the right side top, this was the main bearing, 165 ton, including all, you can say, SPMT, it was 240 tons. So this bridge, we did the live load test and then got the NOC for crossing it. But this exercise, if the infrastructure is available, then we need not do that. Again, vertical and horizontal, those kind of things were not required otherwise. So the other challenges, if you see the availability of quarry site, if we identify the quarry site beginning in the project itself with the sufficient quantity with the good quality, then that saves lot of you can say energy for getting the approvals and going for the quantities to be available at site. And then the key equipments which we mobilized are all new state-of-the-art equipments. Then skilled manpower definitely is the thing that you need to mobilize, and then to retain is a bigger challenge in these kind of remote areas. So to facilitate the launching of the machine well in time for completing the NATM works, we have done few innovative methods, like we increased the number of cross passages and opened new further fronts which were not planned but in addition to what it is, and so that we can launch the machine ahead of schedule, even though we started around 3 months after we received the front which was as scheduled to be because of some local issues. So these are the different activities in the segment casting yard. You can see just what was the video, it's similar. This is the concreting, so everything happened at different, and then digitalization, so various initiatives which we have done for the the tunnel segment documentation system, 3D measurement as well as molds, and then the HK connections, then seismic prediction, explaining in detail, and then we like asset management, the workman force management, there are things. And further, it is just to showcase the achievements. We got the appreciation from RVNL for the good overall project management, and from the Ministry of Railway for transporting the this machine in safe manner in this hill terrain, and then launching the machine in time. Thank you. So here I'll give it to Chris to take it forward.
Thank you, Rakesh. Okay, 4 minutes. My name is Chris. I come from UK, not Austria, and I also live in Australia. The first tunnel I did was the Channel Tunnel, and I was there for the breakthrough, so that's about 43 years ago. So I think I've earned the grey hair. I'm going to go off script and I think just deal with the cost savings as a hard dollar contractor and efficient delivery of tunnels. I'll step back very quickly to what Major General R.K. Singh said earlier on.
You
tunnels,
please speak, you speak closer to the mic.
Yeah, with tunneling, one size doesn't fit all feet. Every tunnel's different. And I'd just like to make a general observation. I've been in India for about 8 years, but a lot of the tunneling experience in India comes from metros, in different types of ground conditions, to hard rock tunneling in the Himalayas, and also from NATM works. So there's some fundamental differences in how we look at hard rock projects. So if we're looking at TBMs going forward in the Himalayas, one thing I'd say is look at what the information's being given to you, and then question it and check it and see if it's relevant to the project you're actually looking at. I'll give you some examples on that. The metro tunnels, a lot of the TBMs are launched from shafts or stations, where you have direct lifts over the TBM build area. That makes it easy to build TBMs in position and also to build heavy-duty reaction frames. In the Himalayas, normally the stations, or invariably the stations, actually not in the open. In our project, they're actually recessed into the mountain, and the tunnel launch position is 500, 600 meters away from where you're launching. So you've got to look at how you're going to build TBMs in adverse conditions. Size constraint, size of the project area is a constraint, and also how do you deal with the rock classifications? A lot of people are used to dealing with NATM rock classifications. Because we don't do face mapping on a TBM, the rock classification is not really relevant. And then we go into the other issue as well, is that the GBR, or the geological interpretation, in low overburdens in urban areas, we have the luxury of doing we have the opportunity to do a lot of dense geotechnical investigation. In the Himalayas, where you've got 800 meters overburden, it's not so easy. So the measurement, or the evaluation of risk and geological transfer between the client and the contractor becomes very, very complex. I'll just move through there. So, picture. No, sorry. Second. So I just wanted to go on to this one. So the building of the TBM, you can see this area is very constrained. I've got a minute left. The area is very constrained. This shows that we were building the TBMs at the same time as we were finishing off the NATM works. Traditionally, people use crawler cranes, or tend to use crawler cranes, 650 ton, to build TBMs. The disadvantage of that in the project we've got, in particular the Himalayas, is the time it takes to transport the large parts up to site, the assembly time, and the tracking or the marching of the crane around the site. This is tight. If I can just get another 30 seconds. This costs time. We opted for a modular gantry crane. The modular gantry crane took a very short period of time to get up the mountain. It took 3 days to assemble, and we didn't have any interaction with marching backwards and forwards. So it's all about time saving. We also marched the TBM. We marched the TBM nearly 600 meters, and 700 meters on the other. We used a unique system. I'll just very briefly explain it. Instead of having marching legs, we had a track that just sat on the ground. We slid legs on Teflon plates, and the coefficient of friction differential between the ground and the Teflon plates meant that we could move the machine forward at a higher rate. Sorry. At a higher rate. We were moving the TBM forward at 139 meters a day in times, whereas the more traditional options would take 40 meters per day. This all translates into time and money, which goes back to the original concept. And I'll just say, you can work out the dollars yourself, but we built the TBM with a modular gantry. We were told it was going to take 10 weeks by the OEM. We built it in 6 weeks, and that was basically because of the efficiency of using the modular gantry instead of a crawler crane. And walking the TBM to the face, it's all on the critical path. Obviously, if we're moving the machine at 110 and 140 meters a day instead of 49, it means that we can get move the schedule along. And we ended up launching the TBM 2 weeks ahead of schedule, which was unknown. I think I've reached my times there. I was going to tell you something else about seismic prediction and how we're actually looking at the interpretation of the ground, but Nitin's coming up after, and Henry Connect are doing the ISP, so I'll leave that up to him. Thank you very much.
Any questions from audience, you keep it to yourself. Once the presentations are over, we will open the floor for discussion. Then you can identify yourself and name the presenter who is expected to answer the question and then raise your question. That way it would be systematic and will conserve the time. So next presentation. So I would request Mr. Herald to make his presentation.
The old ones, I did not show 15, back to 15. No, next. 14, 15. Yes. Okay. So we have been talking about these in the morning session, and I have kind of a 5-minute bonus for this presentation. We started with the United Nations Sustainable Goals, and I encircled here goals number 7 and number 9 and number 11 and also number 13, which I think we all are covering with our tunneling activities. And just let me add what we have just seen here. India really has to be congratulated for fantastic success. What I have seen here destroys every ancient opinion about problems with TBMs in India. It is just fantastic what the success of this presentation has been and how it has been shown to us. So it definitely covers all of the United Nations Sustainable Development Goals. I also would like to put your attention to pioneering innovations in tunneling of the last 20 years. And I mentioned here, and there is a special specification for each of these innovations: the clay silt anchor development, the double deck anchor development, the steel arches, which 30 years ago had been totally new, in particular a specific configuration of inclined steel arches, the load distribution rails, which is standard nowadays in NATM or SEM tunneling. The final lining with shotcrete has become the success also, where we have reached all of the goals which we have been missing 20, 30 years ago. The multiple drift technology, multiple drift, we have seen several of the cross sections. I will show some other cross sections with multiple drift also, in particular starting with the binocular metro stations of the metro in Munich, then in metro in Washington, in the United States, then in Korea, and so on. Waterproofing with sprayed membranes have been an innovation 35 years ago. Nowadays we know it is feasible. We can do it cheaper. The hybrid shallow tunneling with the combination of NATM and cut and cover tunnels, the steel fiber reinforced wet process shotcrete, and the vertical trench for prefabricated one-pass D-walls. And that has been NATM innovations. And now let's go take a look on TBM innovation, TBM technology innovation, starting with the universal ring, which has been first in 1977 introduced for the Munich metro, then the controlled kinematic, the connectors for the controlled kinematic, which at that time have been made of yogurt plastic materials. Then the simultaneous tunneling with digging and support of TBM at the same time. The flat joint design for all of that is TBM tunneling. The sealing with precast concrete segments, sealing technology, Then we have construction of caverns with particular machines. Herrenknecht has done a lot of research on that and succeeded also in practice. Then we have the single-pass unified precast concrete segments, which have been new also, another innovation. Then we have the unified circumferential joint and the unified joint sliding guiding rods. And what is most important maybe of all of these mentioned innovations is the new contract technology, which I call a new contract technology when we use from the FIDIC, the Emerald book with the geotechnical baseline report. It's a technology, in my opinion, and with the RMP risk management plan as a part or a twin brother of the geotechnical baseline report. There is an urban paradox when it comes to tunneling. This is an example where we have sinkholes. Please take a look to the two red arrows. It is in Bangkok. And what is the urban paradox? The prime appeal of greater urban opportunities and benefits initially relocating is effectively weakened, paradoxically, from social, economic, and environmental pressures associated with the rising of the urban population. It boosts the economic growth from the transport sector expansion, which is prioritized over its traffic problems and inequality. So priority is given with regard to inequality and problems caused by traffic. The Asia-Pacific region, in particular where we are now and where I'm living in Bangkok, produced 57% of the global emissions from fuel combustion in 2019. The transport sector consumed more than 19% of the regions of Asia-Pacific region total energy, which directly correlates to an increase in CO2 emissions. There has happened a shift of the paradigm from transport to mobility. Transport systems and various attempts have been made to address such concerns and provide cost-effective transport options. The demand for cutting-edge technology to improve municipal operations, alleviate urban traffic flows, and increase livability has been increasing and caused by the technology change. The shift has been a paradigm shift from traditional concept of transport to mobility with technology responding to traveler needs. Mobility in this context refers to the ability to move freely and easily, whereas transport means the movement of goods and people. So with that, I have concluded in the morning, unfortunately, concluding now, fortunately, and now entering into another topic, NATM technology focused on permanent lining. We have to understand smart mobility, which is introduced in this terminology as a new concept captured within smart transport systems. Smart mobility shifts traditional paradigms by disrupting the legacy of private transport, public transport, and paratransit with customized user-oriented services. Smart mobility is defined as an agglomeration of drivers, transport technologies, services, and modes. And on the right side of this slide, you see what the key benefits of using smart mobility in a smart city are. The key benefits are real-time information systems, predictive maintenance, intelligent parking management, intelligent traffic management, automated toll collections, integrated ticketing systems, smart surveillance and road safety, and of course also real-time information systems. So all this is part of what we call smart mobility. Now let's take a look to the interaction between ground and structure, where embedded frame analysis have limitations in adequately describing the ground structure interaction. This picture very illustratively shows 4 phases of what a tunnel in an urban environment can cause. Due to limited use, it shall be applied where ground structure interaction is of secondary importance, and the tunnel excavation causes disturbance of initial state of stress, creating 3-dimensional stress regime like a bubble around a face. So the state of stress and the lining support, we can simulate excavation and installation of initial support, which allows for analysis of ground response expressed in deformations, in strains, and in stresses. There are portions of elastic and plastic strains which can be obtained and used to evaluate the state of stress in the ground and its capacity. Stresses, strains, and section forces are used in ground support elements such as dowels and rock bolts and shotcrete, of course, and all of that configurations of excavation, multiple drift excavations. Computer programs, we heard about that, often provide such information in a user-friendly display using numeric and graphic forms. Calculations do not distinguish between type of lining, for instance, conventional lining or TBM-based precast concrete linings. Shotcrete and cast-in-place final linings are treated within the program which we use with the material properties and the characteristics of the concrete. We can simulate all of that today, which gives us a big help. And on the right side of this slide, you can see a picture from Munich Metro, where I have been working for a long time. Existing tunnels at the right side and connecting the extension to a parallel tunnel on the left side. When we go into monitoring and verification of monitoring, an integral part of NATM is the verification by means of in situ monitoring of design assumptions made regarding the interaction between ground and initial support as a response to the excavation process. Instrumentation and monitoring program must be implemented in addition to general instrumentation programs connected, we have still time, connected with the overall tunneling work, for instance, surface and subsurface instrumentation. On the right side, you can see a so-called typical cross-section, a representative instrumentation cross-section for a special situation in the tunnel, supported with a few smaller pictures arranged of the opening here. NATM tunnel instrumentation is aiming at a detailed and systematic measurement of deflection of the initial lining. So deflection is something which we can objectively, absolutely measure. Stresses are much more complicated and much more questionable. Monitoring deformation is the focus of instrumentation. Stresses in shotcrete lining and stresses between the shotcrete lining and the ground shall be monitored, but doesn't give highly reliable results. The stress regime within the lining and between lining and ground shall be captured. However, it is in question and needs interpretation. The reliability of stress cells the installation complexity, and because everything depends on the bedding of the pressure cell, and the difficulty in obtaining accurate readings have led to critics in reliance to the deformation monitoring. The use of stress cells is typically reserved for applications where knowledge of the stress conditions is more important than general. For instance, where high and unusual in situ ground stresses exist. For instance, if we are in an urban environment that we have to drive a tunnel under existing buildings or under existing foundations, then stress cells make a lot of sense. Very important also is the evaluation of the data we gain. Monitoring data are collected, processed, and interpreted to provide early evaluation. For what? For the adequate selection of type of initial support, for the confirmation of the type of initial support, for the timing of support installation in conjunction with the excavation sequence. So you can see that this is also going hand in hand. The stabilization of surrounding ground by means of self-supporting ground arch. So the self-supporting ground arch always has been an issue of critics, because people say, how can you know, how can you guess, how can you reliably verify a self-supporting ground arch above or around your opening? The performance of the work in excavation technique and also in the performance of the support installation itself. Then it is also important with regard to safety measures for the workforce and for the public, neighborhoods, for instance. The long-term stress settlement behavior for final safety assessment is also depending on the data evaluation. And then the parameters which we assume, the design assumed parameters such as strength properties of the ground and the in situ stresses used in the structural design of the computation, all this should be part of the interpretation and evaluation of the gained data. So monitoring information depends on monitoring of planning, designing, data collection, and reporting. So such decisions should be made immediately in the field based on most recent gained information. Concerning proper excavation sequence and initial support also depends on the information which we gain during monitoring. In the range of given ground response classes. So that needs not only observation and monitoring, but also confirmation, as well as the respected excavation and support classes which we have make a part of the design. There are field decisions which we need to make where NATM is frequently utilized in the construction of road tunnels in urban settings, mainly due to its flexibility and ability to minimize surface settlements. NATM has the reputation of being more flexible than TBM, but that is history also, and we can talk about this in construction happens increasingly often in combination with ground improvement methods. So nowadays we convey there is no ground which we cannot use in mined tunneling. When I say mined tunneling, I mean conventional and TBM tunneling. If it's not suitable, then we can do an improvement of the ground by injection, by freeze. Then consider future loads that may be imposed onto the tunnel for which the final lining must be designed. so that to understand what is the overburden, what is the structure which most likely is coming to put an additional load on our tunnel underneath. And such include buildings, foundations, underground metro stations, for instance, fulfilling infrastructure needs. So the tunnel stability has a evaluation of the rock mass quality and of the mechanical rock quality and of the mechanical process also, where from the point of view of strength has to be rock mass deformability has to be defined, the strength anisotropy has to be defined, as well as discontinuity and weathering and alterations. And from the mechanical point of view, from the mechanical process, rock stresses and groundwater, these are the two main important parameters. In the field observation, it is necessary to have a solid experience when we go into NADAM construction, and we have also to prove personal skills of the construction company, personal skills of the consulting, of the advisors, and so on. The use of construction equipment and handling of materials for installation of initial support, like shotcrete, lattice girders, pre-support measures, rock reinforcement measures, and so on, that has to be considered, and observation.
Please keep track of time, please.
And observation and evaluation of the ground, as well as contract and bidding process. So I like to focus on that. Contracting is an art. You know, contracting is an art, like tunneling is an art also. Urban mobility, I would like to just finish my presentation with an example from a tunnel in Phuket. This is in the south of Thailand, the so-called highway tunnel Katu Patong. This shows the project overview of that project, and you can see that there is an eastern and a western access to that, but it is not a connection, linear connection from A to B. It is a connection like we have it in Austria for the Semmering base tunnel, for instance, also. Then we have to collect the geotechnical facts and the interpretation of the geotechnical facts, like rock type, uniaxial compressive strength, rock behavior, and so on, water inflow, rock class, and so on. So the route selection, you can see here, it's you have to make the best route, but you can only find out the best route if you have a variation of routes. In the case of Katu Patong, there are two multi-lane tunnels, quite big tunnels, 17.1 meter wide and 12.6 meter high. And you can see that the size of this tunnel and the specific geology here in Katu Patong makes it necessary to have structural invert. You can see the structural invert versus an invert beam. Monitoring in a drill and blast section, you can see here what I have given as an example. On the right side, you can see a multiple drift section with top heading and bench heading and some excavation in between. The reinforcement membrane installation for the waterproofing membrane is shown on these two pictures. Then we have to take a look to the reinforcement of the arch, of the tunnel arch. Specific look from the point of view of structural design. The cast-in-place concrete shown on this picture for the tunnel lining, for the cast-in-place tunnel lining. And finally, the tunnel itself after final installation. Let me come to the conclusion that NATM may be blessed in its relation to the Indian tunneling method. I call it the Indian tunneling method. Why? Because I think India and the Indian mentality is a special condition for negotiating, a special condition for finding compromises, a special condition for talking to each other. And that is the big advantage, and we can see the success with the examples, with the previous presentation from the typical project here in India. And let me say many, many thanks for your attention. It has been highly appreciated. Thank you very much. Oh, if you have questions, maybe you want to ask the question immediately now. Okay.
So thank you, Mr. Herald. So now I would invite Mr. Nitin Garg to make his presentation.
Good afternoon, everybody, and thank you for having us here. I will be not talking too much, going into very specific about TBM tunneling, but just to give you an oversight about...
Position mic to your mouth.
Yeah, so maybe to give you a little more insight of what has been done in last, let's say, 10, 20 years in the field of TBM tunneling. And how the Indian market has been developed in last, let's say, 20 years, mostly coming out of, let's say, metro, but now some new projects coming in Himalayas, which was discussed just some time back. Another project is also going to happen in other part of the Kashmir. So a little bit about our company. This is our company based out of Germany in Schwanow, around 200 kilometers down south from Frankfurt. Not a very old company. We are around 50 years old, 45 actually. We also have a manufacturing facility and a sales office in India. I sit in Delhi, but so for Indian market, especially in the metro, because now from coming out of tier 1 cities, tier 2 and tier 3, tunnel boring machines in India initiatives manufacture more than we are a let's say TBM solution to carry segment people. You need segment molding, segment molds, foam works, ancillary solution we normally provide. So we just talked about molds. This is where you do the cast, molding cast. Conveyors, if you're using a long tunnels. This is basically locos and the backups. This we supplied already in Rishikesh and then also in Pakaldul. These are new, let's say, concept. Instead of a rolling stock or you carrying a loco train to, like a loco train is used to carry a tunnel boring, segments or people or maybe some other tunnel equipment. So this is there you don't with this you don't need to install any rails, and you don't need to remove them later because it takes a lot of time. This is a vehicle which can move or drive on the invert, and you can carry one ring or you can carry two rings. Like the top photograph is a 2-ring logistics, and the bottom one is 1-ring logistics. So it depends on how you design your TBM and how you design your logistics. So you can carry segments. In this, there are modules. You can put a personal carrier. You can put a crane and do some lifting arrangements as well. These are the concept which is not there, at least on the longer tunnels, or let's say even in metro tunnels, everybody used to use a loco. But this is now becoming very popular. It's easy to run, easy to maintain, and very flexible in terms of its usage. And this monitoring, and when you're running a TBM, so it has to steer properly, it has to go in a right direction. So there's a navigation system on board on the machine, and it is integrated with the tunnel boring machine, and also you can see the navigation at the surface if you want. Everything is connected either through wireless or a LAN cable. This also helps in monitoring. I'm not going to talk too much about settlement monitoring and instrumentation monitoring, but in urban environment where you have metro and you have buildings on top, so structures on the top, so we have certain systems which you can install on the surface, which is mostly typically on the buildings or on some heritage structures, and they will keep on monitoring the settlement. If there is some settlement on the buildings, or if the vibrations levels are higher than the desired vibration levels, so the operator in the TBM cabin will get a let's say an alert that there is something at the surface. So please take a note of it, and maybe you need to do some corrective measures. So all this is, let's say, live. So over the last 30-40 years, as I think we have been discussing, are becoming bigger. People road integrated with the railway, maybe a metro, could be a flood control road. Let's say permutation and combinations are nowadays possible because the tunnels can be made bigger. You can have 2 decks in the same tunnel. Don't need to make 2 tunnels if the traffic load can be taken care with one. Working TBM, which was used in Hong Kong, but technology it is, I think, 20 meter. Milestone about our company. I mean, we started almost 15 years back, and we have reassembled machines in India for more than like 15 years, and out of this factory, more than 40 machines have gone out. We also do a lot of other work, and more than 200 kilometers of tunneling we have done with our machines, mostly in metro, plus some in hydro, irrigation. This is only about talking about metro, but we have done a lot of other tunneling which is in the smaller meter diameter, which is basically gas, sewage, water. I think we all know that TBM tunneling has been a challenging one in India, at least in the hydro sector. If you see, there are a lot of projects which are still struggling to finish off, particularly in Uttaranchal. And for whatever reasons, could be contractual, could be technical, could be geological, but a lot of people are still, I would not say scared, but they are still skeptical about using tunnel boring machines in the mountains. So, I mean, yeah, that's a fact, but at the same time, there are a lot of success stories around the world. In Nepal, in China, they have done a lot of TBM tunneling with, I would say, a few hundred kilometers every year. They are doing every year, and they have taken the tunnels from, let's say, down from southern part of China up to even Tibet. So I think when we talk about TBM tunneling in urban, I mean, when we are talking about going under a river or when we are going about under a sea, we have a project in Mumbai, which is, there is a tunnel which is going under a sea, or not a direct sea, but under a creek. So the challenges are different when you are in the mountains, because normally here in the mountains you use only open machines, as we call them, hard rock machines. But this you cannot do when you are under the urban environment. So there you use a closed mode machine, which means the machine has to be pressurized. And if you're going deeper into the sea or deeper into the river, so you have to have a machine which is capable of withstanding higher pressures and also able to handle the geology. So if otherwise you have, because TBM can only go in one direction, you cannot bring it back, or you cannot, under the sea, when you cannot make a shaft and take it out. So longer the tunnels, and the grounds are becoming challenging, because now, as we were discussing with Mr. Wagner, also discussed that the urban space is becoming more congested. We have already expanded the road, the flyovers are being made, underpasses are being done. Now the only way is to make tunnels. So that's where the challenges are coming from. Okay, we have TBMs we have made in last 40. Various type of tunnel boring machines have been developed. Initially, they were basically hard rock machines, like 30-40 years back. Then, with the advent of urban tunneling, EPBs were developed. Then mixed shields came in, which is a slurry based machine. And today you also have a machine which is called a variable density machine, which is a combination of a slurry and a EPB. So I think one new trend has been over a period of time in last 30-40 years, or less in the recent 10-20 years, is that the projects are becoming bigger. I mean, if somebody has to develop, okay, in India we had in the first phase of Delhi Metro and even in Mumbai Metro, Kolkata Metro, not a big amount of tunneling. We did maybe around 20 kilometers into 2 times the tunneling, but there are places where they are doing like 100 kilometers in one phase. So it means you need less number of tunnel boring machines, but at the same time you need more packages, but the planning has to be done in a way. But this saves you a certain amount of cost, because if you are able to do, let's say, 5 kilometer with 1 TBM, instead of doing just 2 kilometer, you save cost. So I mean, if like in Doha Metro, even in Crossrail, all these projects have basically started to expand their work. So there's 21 machines drilled 111 kilometer, so which is close to 5 kilometer per machine, and they did it in 26 months. So this is how projects were developed in last few years. Same is in Paris. They are also now making a new phase for the Olympics, upcoming Olympics. So they are also doing expansion in the outer part of the Paris. So as you can see, again, the number of TBMs, more than 20 machines are working. So, and they also deployed new technologies for making shafts for ventilation. So so a new kind of vertical shaft machine, shaft sinking machine was used. This is a machine which is, I would say, quite self-sufficient in terms that it does the vertical mining and it does the shaft lining as well. This is another project which was done in Singapore. This is typically a very deep sewage tunnel, so they wanted to make a complete sewage system as used as a storage, water storage, because Singapore does not have any river. So they want to collect all the rainwater and store it. At the same time, sewage water can be also used and treated and then complete recycle, because I think currently this drinking water in Singapore comes from Malaysia, and I think they have some pact in next 10-20 years. They may not have the supply. So here again, more than 20-25 machines were used of various sizes at various depths. I think this is well known that in terms of becoming the project becoming more efficient in terms of cost, in terms of time, and in terms of manpower, you need to do planning, and then take the machines which can give you higher performances. Today, there are new technologies being developed in terms of enhancement of the machines. This year we got a new award for simultaneously mining. Nowadays, in any machine, in a EPB or in a mix shield, you cannot do the continuous mining. So you need to stop the machine when you are doing the ring building. But now there is a technology available which you can do mining when you are doing ring building in a EPB or in a mix shield machine. So all these new innovations are helping to increase the speed of the TBMs. And also, a lot of places I think nowadays plan to recycle or reuse the machines. This is saving a lot of carbon footprint. You can, like in a metro, the diameter is more or less same for all the machines, so people tend to reuse those machines, so it helps you in terms of cost and reducing your carbon footprint as well. And also, I think it has been discussed in the morning that for success of the project, you need the client, the owner, the designer, the contractor, and at some point in time, the political support has to be there, because if you don't have all this together, then the projects are normally delayed or they don't take off the ground in time. So again, I think the reason why, I mean, in urban environment, particularly where you are having a city of more than, let's say, 2 million, or maybe, okay, maybe not in India, but let's say 20 million population, and everything is crowded and you have a lot of structures everywhere. There's no more room to make any more roads or, let's say, structures. So the tendency is to go under the ground. But whether the planning, the safety, and the geology allows you that. So all this is nowadays driving that from a point of view that you want to go to above the surface. The bigger cities are now thinking of going under the surface. Whether you do drill and blast or a typical NATM or a TBM tunneling, that's a secondary question. These are some of the projects which we have been discussed. I think again, as I said, under the sea, under the river, under the mountains. So the technologies were developed looking at the requirement of the project. By this particular TBM was the first TBM which was designed with the accessible cutter head, was purely designed keeping in mind the deliverable of the project. The technology never existed at that point of time. Yeah. So as I already discussed, so the various types of tunnels are being made around the world. You can see this is smart. I think there is one session on this, if I understand, maybe tomorrow. And then you can see there you have a road tunnel and the metro on the same tube. You can have 2 deck of tunnels possible. So all this is possible with today, let's say, at least from the technology point of view. There are references available, there is experience available. This is another project which was done in China, in China, Hong Kong. And I was there in this tunnel last month, so this was the biggest tunnel that time. Another challenges that we see, maybe not in the Himalayan side, but in the road, is to make the cross passages if you have long tunnels. How do you do cross passages? So in this, you can see that there were, I think, more than, if I don't remember, but there were enough cross passages. Oh, sorry. So these cross passages were also done using a tunnel boring machine, a small one. So this was special arrangement which was done. So this also is now, so 46 cross passages were there, and they were all made using a tunnel boring machine. Another new, let's say, especially for the road, bigger diameter road tunnels. Now when you make a tunnel, after that you have to lay the invert or the deck on which you lay the road. So how do you do that? So either you do in situ casting, which takes time and also stops certain process. So you cannot do the in situ lining unless until you finish off the tunnel. So you cannot do this at the same time when the TBM is running. So but nowadays there is all these systems are available. Either you have it on the TBM or you have it besides the TBM. So you do the TBM tunneling ahead, and this deck, this is an inverted deck, or you can have another option, and then you can do the road deck also at the same time. Not at the same time, but just let's say 200 meter or 300 meter behind the TBM. So your tunnel road is also ready more or less at the same time where your TBM is coming out. So this I think we are going to see very soon in India, I mean, because this has been done in various tunnels in Australia, in Hong Kong, in New Zealand, in Europe. So this is a very good way of speeding up the tunnel process and very safe. Okay, hard rock. Enough experiences around the world. Diameters have been becoming bigger. 13 meter, I think nowadays we are talking about 15 meter. So enough of the projects, enough references. I'll not go into them too much. Time is running out. All these tunnels are already, let's say, working and running. This is the longest tunnel being made in Austria-Italy border. So it's going to be more than 60 kilometers of one tunnel. So there are three packages: 20 kilometer, 20 kilometer, and 20 kilometer. They here also to do something, let's say, to be more, let's say, to handle geology better. What they did is that instead of making, doing let's say, getting the unexpected from the TBM tunnel, they made an exploratory tunnel just beneath. So this exploratory tunnel that you see in the bottom was done before they started the main tunnel. So all this, so this tunnel gave all the whatever geological information, surprises, challenges, and everything. So this is a new concept. This was done, and this also now I think will be used as an escape tunnel also. So nowadays you have multi-mode tunnel, multi-mode machines, so you can do a lot of changes. You can take the machines out. So this is what I have to say, and thank you so much for listening. And if you have questions, we can take them later. Thank you.
Thank you, Mr. Garg, for a nice presentation with animations and pictorial representation. So now the floor is open for questions. Please identify yourself and then indicate who is the presenter to answer your question, and then give your question.
Yeah. Good evening. I'm the Executive Director, NHIDCL, Jammu region and Uttarakhand. The TBM which we really see in India today is not being used for road construction. It's mostly for the, that is the hydro projects or the metro rails. Yeah. So there are three things which I have. One is when the rock class goes to C, D, and E, and where you have to put in the lattices, girders, or the ribs. Probably in this kind of a technology, would we be able to use it? The second question is, what is the delivery time? Because it has to be custom made. And third is the economy, that what is the length which you feel is it becomes economical for the contractor to use this, the minimum length, because it's customized and reusing, recycling. I don't know how far it's possible. Yeah, Mr. Nathan, please.
So thank you. You asked a very relevant question, and this question is being asked at every forum, whether it is the owner or the consultant or even the contractor. So let me answer it this way. The TBMs today, let's say, depending on the application, as I said, urban tunneling. So if you are in an urban environment, so normally we used only a closed mode machine, which is mostly a EPB or a slurry machine. Technically, you can handle class 3, class 4, even mixed ground with these kind of tunnel boring machines today. But at the same time, a proper geological investigation and a GBR is necessary just to make sure that when we are designing the machine, or even when the contractors or the people are bidding for it, has the right approach to the contract. So technically possible, without the keeping the diameter, whether it is a 10 meter or a 14 meter diameter. I think we already have a project in Mumbai where they are making a road tunnel 12 meter dia. So that project is going to be ready, and I think soon operational. So the first big road tunnel is going to be ready next year, or this year actually. Now comes to the question of economics. I mean, yes, you rightly said, if you have a tunnel which is 1 kilometer or 2 kilometer, sometimes it does not make any maybe economical sense. But then in urban environment, you don't have much choices, particularly when you have class 3, class 4 rock. You cannot do drill and blast very conveniently, particularly in a very large diameter. So now we have a project which is in Dwarka Expressway in Delhi, which is just 4 kilometer tunnel. Coastal Road in Mumbai is only 2 kilometer road tunnel. So there the TBM is still being used. So, and in a lot of projects in China, in Europe, 2 kilometer, 3 kilometer, large diameter TBM tunnels are being done. Whether you use 1 TBM or 2 TBM is a different question. But again, if you have any other choice but to use a TBM, then TBM is not required. But if it can be only done with a TBM, then cost is secondary. Yes, sir.
Hello, my name is Lucy Roux. I'm from Egis in France, and I have a question for Rakesh or Christopher. I was wondering what provisions you made for the spoil management, and were you able to reuse any of it as aggregate for the tunnel lining, for example?
Hello. The spoil management means the muck, which is excavated muck, is coming out. So the arrangement is that we are, you can say, bringing out the muck using the conveyor for the TBM. That is the plan. So we have a temporary stock dump yard near to the portal, and from there we have the permanent dump yards, which are around 7 kilometers away from the portal site. So we are using the dumpers and wheel loaders to remove the muck and dump it into the permanent dump yard. Yeah, you want?
Yeah, and then about reusing the spoil, we actually having to crush boulders for aggregate for the segments. The muck that we're going through, or the rock we're going through, is a phyllite, and the phyllite, when it gets worked, when it's a workability, it turns into a clay or into almost a swamp. So it's not suitable for reuse.
Hello. Myself, A.K. Srivastava. I am former Additional Director General, Ministry of Road Transport and Highways. My question goes to Mr. Herald. During your presentation, you have mentioned this, we should take care of the future loading. Then in design of future for tunnels, underground tunnels, how to quantify the future loading? Because whatever load combination is possible, we are taking into consideration at the design itself, design stage itself. And if it will be not quantified properly, then definitely it is going to increase the cost of the tunnel. Number two, during your presentation, you had given the NATM methodology for the tunneling, but both the presenters, first and third, they have given this TBM. Now, can you share with us that what is the factor of a stand-up time to go and to decide the method of tunneling? Then these are the questions to you. And next is to Rakesh Arora. During your presentation, you have shown these precast segments. Just through TBM, it is being placed automatically. Then what about this cross passage? How you are taking into account this placement of precast segments in case of cross passage, because their radius of curvature and warping and plate concept will come and design concept will be also there. And how you are taking care of that. Secondly, that you are producing these segments in bulk. then what is the method of curing you are adopting to achieve the uniform strength of the segments? And number 3, what is the method, at what frequency you are adopting the testing of the segments to ensure its durability after the placement? Thank you.
Okay, I think you addressed me first, and then I will give the microphone over to my colleague here. You have been asking the future of tunneling in India. I think what we have seen in the last few years confirms that India has no reservation against any tunneling method. Before, we have heard that TBMs are so vulnerable, TBMs are so difficult. We have had so many projects with failures of TBM here in India. And NATM has been the one method which has been supported. And we have had a hydropower project here in India, and the Luri project. Maybe you have heard about that Luri project. And the Luri project.
Sorry for interruption, sir. My question was future loading you have mentioned. Future loading for the tunnel.
Okay.
Future loading.
Not the loading, not the method as
loading.
such.
Yeah, sir.
Okay.
Future loading is the basic thing, because at this moment we are taking every possible loading for the design of the tunnel. And if you will go for the future loading, I think that I wanted to share with you that how to quantify it, because this will definitely impact the cost of the tunnel.
Well, you know, that depends really on the specific project. Is the project in an urban area? It's completely different than in the Himalayas. And the loading, I think, is possible to keep it under control with the reinforcement. You know, the more loading we assume, the more reinforcement we will have until we reach a maximum of, I can tell you, per cubic meter of concrete, the maximum of reinforcement should not be more than 120 kilo of steel. So, in my opinion, the loading is not an issue of urgency, and is not an issue of a question. We have it completely under control. If you think that it has significant influence to the decision whether we do the tunnel or not, I would respond, no, it is not decisive for the project as such. There is maybe a little bit more reinforcement or a little bit less reinforcement. We have plenty of experience with the impact of reinforcement on tunnel lining, both on cast-in-place lining and on precast concrete segments. So I think there is no problem from that point of view. Unless you want to be absolutely sure that an underground structure will not be affected by a nuclear bomb or something, then it's a different story. But generally, I think that we have it completely under control. The second question, the speed of excavation between NATM and TBM, is that completely correct? To understood it?
Yeah, my point was this, that a stand-up time, that during your presentation you have mentioned that synchronization should be there, that how we are going ahead, how the squeezing effect and falling effect is there. Therefore, there is a concept of a stand-up time while digging the tunnel. Therefore, what is the relation and what is the these implications for the stand-up time with respect to choosing the methodology of the tunneling?
Well, standard time for a TBM tunneling, you know, it is either supported by the cutter wheel, or it is supported by bentonite suspension, or if it is a liquid supported or compressed air supported phase. I think it is something which has to be decided project specific. And from that point of view, I think technology is completely clear. There are no options for that, and it doesn't have an impact to the decision whether the tunnel will be built or not. For the speed of excavation, it is very clear that usually TBMs are faster than NATM or CTM tunnels, and which is not 100% correct now, because again, you have to compare on a project-specific sample what the speed of CTM or the speed of TBM will be, the speed of excavation. I think it's a solved problem.
So the first question was regarding the cross passage. See, this segment lining which we are using is basically for the lining of the main tunnel. The cross passages are to be constructed with NATM technology, and the in situ lining will be there in the cross passage. And then you ask for the...
then in that case, suppose you have made the main tunnel first, then yes. Are you going to, which one will be the taken up, cross passage will be taken up later on? Then are you going to remove the
yes.
precast panels?
Yes. So those panels in the cross passage area need to be removed, and then the proper support to be given to the
roof.
You can say roof, and then we are entering into the cross passage. So the next question was regarding the segment. So segment for curing we are doing the steam curing first. So it is in 2 stages. So steam curing is being done for bringing it to the strength of the demolding. So which is say M60 is the grade for our segment. So once it reaches 25 MPa, then we are demolding it. And after that, curing compound is being applied on the segments, and that's how it is being cured up to the 28 days. The tests which you are asking for the segment we are taking is for the strength. We are basically cube test we are doing, workability test, then cube test is there for for checking the strength of the steam curing, then 3 days, 7 days, 28 days test what we are doing. And then for these tests, and then for the dimensional check we are doing by the laser technology, we are checking the dimensions of the molds as well as of the segments.
Of EPB you are also taking for the segment?
EPB?
UPB, ultra
that we are doing not in a regular manner, but we have done it to check the homogeneity of the concrete, yes.
Okay.
Thank you.
Okay, my name is Tiag Singh, a member of Technical Committee 4.4 Tunnels. I'll start with the first group of presenters, and maybe to thank you for the excellent presentation and the opportunity you gave us to learn about what you are doing. One thing we are not debating in this, and it's irrelevant, but I would like to have an insight from your side. It's a contractual arrangements you have. Mr. Cooper indicated that, for example, if you take the completion of TB1 and TB2, they were done either 1 week or 2 weeks earlier. The original program was 10 weeks, but it came down to 6. Is it design and build? You know, are you taking decisions yourself, or you are refining the program which were originally granted to you? And I think that links to what Mr. Harold highlighted in terms of decision-making and process. You know, technical decision must be done on time. Everything is working smoothly. Depending really in terms of who has to make the final decision. If you have to go to the client and seek opinion, then expert advice, it might take longer. So between the three of you, it looks like you are doing everything right. So maybe you should share with us, you know, the secret. Very last question, which it's you know, it's applicable for low-income and medium-income countries like this one. You have not spoken about the job creation, SMME developments, opportunities. You know, it's a high technology-driven equipment, yes, but are you creating jobs? If so, how many? Thank you.
So the first thing, let me tell you this project which we are executing, this package is on item rate basis, so we are not the designer. So RVNL here, Mr. Sumit Jain is also here, who is the project director from RVNL. This design is done by RVNL with the help of a consultant, which I said that Thomas Altinok. They are the designer as well as project management consultants. So you got like an impression that we are doing everything. We are not doing design on our own. The original method also decided by RVNL only that this project need to be constructed with tunnel boring machine. So we are implementing that design. But the thing is that the execution of the project, and if you see the assembly of TBM or transportation of TBM, yes, those decisions we are taking and we are organizing the thing. We have organized that. So further, all the things, whatever is happening, so if there is some technical decision is required, like what kind of advanced stabilization need to be done, or what kind of if some design changes are required, those are being handled by RVNL and designer. We are there to basically propose something or provide our inputs so that the final decision can come from the employer. So hope that answers your question. And the second question is whether we are generating the employment. Yes, employment definitely being generated whenever you are executing this kind of infrastructure project. This is a huge project which is being undertaken. Like we are executing only one of the package out of 10 packages. So here we have the staff who are the qualified staffs. Around 200 staff is there with me for execution of the project, who are engineers and supervisors. And apart from that, we have 1500 plus workman force. So they are being now getting conversant with this new kind of technology. What I said is the challenge is that to get those kind of skills and then to retain them in that remote location. But definitely these projects are creating a good opportunity for creating good employment. Thank you.
Mr. Arora, you just mentioned that initially you do curing with steam, and after attaining a strength of 45, you switch over to curing using curing compounds. But my experience is that curing compounds are useless. You don't gain any strength using the curing compounds. I don't know what is your experience.
No, if you see in all the TBM projects and the segments, see what is the steam curing function is that you need to get the accelerated strength so that you can demold the segments faster. So steam curing gives me say around 25 out of 60 in say 6 to 7 hours or maximum 8 hours, generally 6 to 7 hours. So then we demold it, do the curing compound. Yes, in 28 days we are getting strength even better than what is the target strength for us. My experience is good only in that. Maybe if you want to add something, you can add here.
I have used curing compounds at number of places during my surveys, and I noticed that curing compounds does not add to any strength using that compound.
No. Add to curing compound is for curing of the concrete, yes, but yes. 28 days strength, what ultimately we need to get, we are getting it. Our experience doesn't say like that. You want to say something? Yeah?
Not exactly in this line, but I have a different query.
Okay. No, I have completed. My experience is good only with curing compound. I have used it in 3 projects. And maybe Chris also.
Technical requirement anyway, isn't it?
Yeah.
Hello, I am S.S. Gherwar, Chief Scientist, Central Road Research Institute, New Delhi. My question is Mr. Rakesh Arora and Mr. Christopher Cooper. Arora sir, you showed in your presentation, beautiful presentation, of course, all the presentations were nice. I just want to know what is the time duration starting from procurement of TBM and right to the execution of the project. That is my first question. And to Mr. Christopher Cooper, somewhere in your slides, sir, I saw some seismic prediction. Was some instrumentation was used, and what was the methodology? You did not cover that. Thank you.
So for TBM, if you ask me, see, we ordered the TBM in the month of April 21. and we did the FAT for the first machine in the month of February 2022. So it takes around 10 to 12 month X works for manufacturing after order placement. And then to mobilize the machine to the site, again it takes say 2 months for the shipment, and then 1 month it will take to reach it up to the site, and then you have to assemble it. That also takes around 1.5 to 2 months, then to the launching position. So it takes around 1.5 years at least. This is what is my experience for machine. And then further, after this, now this 10.5 kilometer tunnel boring which we have to do, we have to do in 33 months. This is the plan. So let us see. We are very much hopeful that we will be completing it in time.
So if any more questions are there, I would request that they should interact with the presenters after the session, because already we are quite late in the session and other sessions are also there. So I would request my co-chair to sum up the presentations.
It's my privilege to co-chair and get opportunity to sum up this important topic, and namely the latest development in tunnel. It can very rightly said it is the soul of this seminar. Mr. Rakesh Arora and Mr. Christopher Cooper has given presentation on longest tunnel being constructed for RVNL. He has detailed in a very nice manner even a smaller component like transportation of TBM assembly, and for the government officials present here that they can take cue from this, that land and quarry site etc. is also important and to be planned quite earlier. Mr. Christopher has elaborated performance of TBM with different geology, and subsequently Mr. Herald presented a very interesting topic, permanent lining of material for tunnel, describes in brief tunnel construction innovation and making it economical. He also mentioned a very important point for government officials to take note of, that new contract provisions that is suitable for tunnels take care of, because most of the things are invisible in tunneling. So taking GVR and RMP and such suitable mechanism is developed in contract management also. Mr. Herald also elaborated very basic concept of support system and monitoring and its verification, importance of data evaluation and so on. And we thank him for giving a new name, Indian Tunneling Methodology, and we will be indebted to you for this new. We will take pride in you naming now ITM. Subsequent to this, Nitin Garg has given very informative information on TBM tunneling methodology, including instrumentation and monitoring. Different type of machinery required for tunneling has been elaborated by him. Different size of TBM used and what are the sizes of TBM that is still in design stage and that can be used in future. He has also mentioned that new developments in mechanized tunneling and things to remove misconception about TBM. It cannot be used in Himalayan region. He tried to explain in this matter also. He also elaborated deep tunnel sewage and water recycling concept, as most of us are here in highway engineers, so this was a new things to us to know about and take some gain knowledge about this. He mentioned interesting point, tunnel get political and public support. It is also heartening to know that it is mainly environment friendly, and that's why TBM is also gaining support. And taking cue from chair, all the presentation has been made very lively. That is proof that very lively question and answer session has happened. Thank you.
Thank you, Amrinder. Seeing the volley of questions, definitely the presenters are due to be congratulated, and they have done their job very well, and the presentations were very interesting, And the ultimate objective of all the design, conceptual planning, everything is the product, that is construction of the tunnel. So this particular session is devoted to that, and everybody naturally had the interest and will have the interest. And I thank all the presenters. And any more further questions, because of paucity of time, we could not allow more. So they can be put to the presenters in the lunch, dinner times, wherever you have interaction. Thank you. Thank you.
I request everyone to please kindly be seated. I'd like to invite Shri S.K. Nirmal, Secretary General IRC, to kindly come up on the stage and felicitate the distinguished guests at the high table. The Chair, Shri P.V.S.S. Ravi Prasad, the Co-Chair, Mr. Amrendra Kumar, and the presenters, Mr. Christopher Cooper, Mr. Rakesh Arora, Mr. Harald Wagner, and Mr. Nitin Garg. Thank you so much, sir. Ladies and gentlemen, please kindly pay attention. The shuttle bus services are available for the following hotels near the parking area: Hotel Madhuban, Sarovar Premier, Lemon Tree, Red Fox, and Fairfield by Marriott. Those who wish to utilize the bus services may do so. After the high tea, the next session will be on the geotechnical and geophysical investigation in this auditorium, and parallelly on safety issues in the Vishwakarma building. So I request everyone to kindly proceed for the high tea at the Vedanta reception that is on the ground floor. We shall resume the discussion of our seminar at 17:10 hours. Thank you so much.
them to the guys, right?
But anyway.
We now move forward with the seminar, and we will be focusing on the topic, the geotechnical and geophysical investigation regarding the agenda of our seminar. As we glide through this session in the presence of our chair, Professor Arnold Dix, the President of ITA, and our co-chair, Shri R.K. Mehra, Vice President IRC, and Secretary PWD MP, while focusing our contemplation towards the understanding of the tunnel investigation model methodology, best practices and challenges, impact on design, time and cost overrun by Dr. Dinesh Chandra Tripathi from India. The second will be on aspiring to understand the geomechanical investigation for long tunnels in the mountainous area by Lucy Rue on behalf of Bernard Flacknett. And the third will be on contemplating the ideas for geophysical investigation for the identification of planning of road tunnels in India, put forth by Dr. Subhash Chandra, National Geophysical Research Institute. I request the chair and the co-chair to kindly proceed towards the high table. I now request Shri Puran Singh, Superintending Engineer, Ministry of Road and Transport and Highways, to please come on the stage and felicitate the chair and the co-chair. I now request all the presenters to please come up on the stage and proceed towards the high table. With this, I hand over the procession of our seminar to the respected committee. Thank you so much.
Namaste, my learned friends. Ladies and gentlemen, it gives me enormous pleasure to chair this session this afternoon. I'm very aware of the time, but I'm also very aware of why you are here. We have 3 excellent presentations which deal with the most fundamental and important factual elements of our major tunnelling projects, and that is trying to predict what's really down there. And I've had the pleasure of looking at the presentations, and you're going to enjoy them very much. Now, I'm just going to give you a little clue as to why I'm so excited. Our first speaker, and I'm going to just, you've already had the introduction, but our first speaker has decades of experience in delivering projects from the beginning until the end. That means they need no more introduction. Anyone who survives these huge projects has wisdom to share with us. Our second speaker is a chartered engineer of the highest order out of Western Europe, which means, and also for decades of experience, they understand the importance of this. And our third speaker then takes us up into the air and deals with some of the latest technologies to assist us trying to understand Mother Nature. So with that said, I welcome first speaker to the stage to make their presentation. This is the Tunnel Investigation Model Methodology, Best Practices, Challenges, Impacts on Design, Time and Cost Overrun by Dr. Dinesh Chandra Tripathi. Please, ladies and gentlemen, make him welcome. And can I say the scariest slide is in your presentation. I'm looking forward to seeing it big.
Good evening to everybody. Chair, co-chair, learned delegates, ladies and gentlemen. I'm DC Tripathi. My topic is the tunnel investigation model, methodology, challenges, impact on design, time and cost overrun. Since morning, we are listening a lot about geology. In every paper, in every topic, without geology, nothing was there. We are using very big machineries for construction of tunnel, but without geological investigation, it is not possible. We are using DBM technique, but without this geological investigation, nothing is possible. We are using excavation method. Without geology, it is not possible. So it means a bankable investigation is essentially required. And how to do this bankable investigation? Ladies and gentlemen, whatever I am going to present here, this is based on my own experiences. This is not the bookies or something like that. Whatever I have done for the last 40 years, that I would like to discuss the things with you, whatever the time permits to me. So, the highway tunnels means these must be viable to minimize potential environment and geological impact, and should be feasible to cross a water body or traverse through physical barriers like mountains and ridges. Must be identified properly as major road projects being involved hundreds of crores of public money. This is very important before construction of a tunnel. Complex engineering geology. This is also very important thing, because this complex engineering geology, wherever it is there, it is required to be studied in detail. Otherwise, the structure is going to be ruined. Then, constructability, long-term environmental impact, land use restrictions, life expectancy, economical benefit, and life cycle. These are the few guidelines which everybody knows, so we will not waste the time in that. Now there come geotechnical investigations. Geotechnical investigations are very, told you, for a alignment viable. Geological structures, you know, we are talking about Himalayan geology, complex geology. In India, we have got very easy geology and very complex geology. If you go to Eastern, very easy geology. Nothing is there, no even very small shear joints, very limited. Rock is very, very competent. As soon as you go towards north, variety of Indo-Gangetic, lesser, middle, higher, weak rock zones. Lesser Himalaya, comparatively better. Higher Himalayas, intermittent and moderately good. But Tethys Himalaya, you do not know about that. So this is the complexity of Himalaya. And we are talking about the investigations. Investigation is not only in the part of one portion of Himalaya. We must have a basic idea about the details of pros and cons, what is going to happen in the future. Otherwise, there is an engineering project, unnecessary to waste the money and time, both. I'll come in that also. Then, material investigation. We are going to construct a tunnel. We will bring the construction material. Then ultimately at the time of award, after awarding the work, contractor goes here and the from here, I will bring this material there. Is it possible? So one rock soul query, whatever it is, it should be very near and should be identified properly, and all the tests which are required are to be done. Uncertainties regarding geological hazard. People say geological hazard, people say geological surprises, but nobody says geological problem. These are not the hazards or surprises, basic problems which are required to be tackled by the site engineer, by the site geotechnical engineer, and by the site geologist. Then, very important thing. If you do not know how this groundwater sources will behave, then it may become a problem for you. Then provide specific data to formulate design, constructability, cost productivity, and schedule. For doing all sort of investigations, at least one roadmap is required. And that roadmap is identification of engineering tunneling proposal by governing bodies. Because once the proposal comes from the highest authority, then only work can be started on it. Then recovery traverse. Somebody has to go to site and see what type of site is there. Then evaluation of proposed based on site condition and preliminary geological conditions. Afterwards, inception report comes in the picture. Then alternate proposal study, it comes afterwards, and afterwards to finalize one of the alignment. 5 steps are there. Then we can go towards the final alignment. Then topographic survey comes, then understanding and detailed study of regional and project geological features. Then comes petrography, then geophysical studies, then core drilling, then geotechnical test, feasibility report, then ultimately DPR comes. And this is a pictorial view how these reconnected traverses are done. While doing the reconnected traverses, nothing is in our hand. We go to the field. We do not have even any topographic map because this is the first stage. Then what we will do? We have to go through these landscape imageries first. We have to procure and see the landscape imagery, and these landscape imageries must be of the recent dates. Otherwise, you never know what Himalayan condition, when this earthquake, because of the earthquake or any slope movement, which earthquake, this landslide has come and when. So, for that, landscape imagery study is very important, and in first hand, it gives the information about the drainage pattern, about the source of water, about the catchment area, about this mounts, valleys, river, lineaments, so many things it gives together. But it should be used properly. Second thing, satellite derived soil moisture map. If you do not know what is the moisture content on the surface, what type of investigation you are going to do? What we are doing? Because this moisture content shall give at least preliminary idea about the groundwater condition, which is likely to be intercepted on the tunnel grade. Then satellite derived ND VI map to identify forest area, farmland, barren land. This is again very important. Land use pattern. What we do? We see this land use pattern is the second thing. Forget about it. No. Land use pattern is the first thing. We must have an idea what is there in the surface. How much land is degraded? What is the condition of slope of material? Whether it is barren land, it is forested land, or it is the fill of the water, or some degraded zone is there, or some zone is like that which is sinking. So this type of land use pattern is required. This is called the geological land use pattern. Then second come development and contours. Afterwards, it comes the development of contours. 2 types of contours are here. One is the direct contour and another is the indirect contour. Direct contour, what we do on the site, on the ground, after doing survey and all these things, it is very common. But indirect contour, when we do not have any contour plan in our hand and we are going to the site, we are reconnoitering the site, we are going to understand the site on prima facie first information report, FIR. We have to lodge the FIR. How? This is the mode of this thing. So we have to develop indirect contours based on, again, this landscape imageries. And these landscape imageries are very important for developing this type of model. This model is called DAM model. Of late, it has come into picture now. Earlier, nothing was there, only the simple topography of Survey of India. You go to the field, see, mark something, some overburden, some rock. No, this is not the business now. If you have to do the perfect investigation, you have to identify each and every component of the land which is on the site. No need to identify only rock, overburden, nothing. The time has gone now. A bankable investigation report is required to save the money and to save the time. I'll come on that also afterwards. So, it helps identification of relative location of position of portals, tentative estimation of tunnel gradient, tentative estimation of available vertical and lateral cover, stream order, catchment area, flow condition. If you see this model, this is some sort of 3-dimensional model. What it is giving, one slide is there. If you see, one slide is there. This is the actual ground condition. One slide is there in Uttarakhand on way towards this Yamunotri. Very renowned slide called Ujjeri slide. We have to bypass that slide. We went there, but we were not having anything in our hand. What we have done this based on DEM study. You see, one slide is there. This limited area is there. River is flowing. Area of river has come. What are the lineaments present? That is also incorporated. Well, how much barren land is there? Depositional terraces, erosional terraces, tributaries. So many other things are there. So, this type of model is required to be understood before proceeding further. Then comes topographic survey. It is very common that everybody knows, but the scale varies from 1:50 to 1:5,000. 1:50 and 1:100. It is in case of portals. For this portal geology and this portal geology and design and alignment study further done afterwards, after collection of data of the portal and all these things. Then alignment study comes into the picture. The geotechnical stability of the face, portal and side slopes. Very important factor is the joint rock orientation. Criss-crossing of the joint. This is the common phenomenon of Himalaya. 5 sides, 4 sides, 3 sets of joints are present. It is required to be seen on the ground. Generally what happens? 1 or 2 sides they see and plot something like that. No, time has gone. We have to plot a bankable investigation report. We have to identify all the joints. Which joint is going in which plane? Suppose a slide is coming from this direction. We must have an idea which this is being controlled by which set of joint. What is the orientation? What is the rotation? And how it is behaving? What is the nature of this slope? If you do not know the criss-crossing orientation of the joints, how we will be able to understand the workability or the role of joints on that particular slide? Then it comes ground stress condition. For that, vertical and lateral cover must be studied properly. Proper lateral cover and vertical cover should be there. Then intersection of the existing road and road of the portals. To achieve the most economic and feasible alignment option, various project aspects can be explored, like portal location, side distances, acceptable horizontal and vertical covers, seepage, expected geological hazard, travel clearances, MEP, mechanical and electrical plumbing, then ventilation at site. Now, whatever has been discussed till now, it is on these recognitory studies. Now let us go to the field and start geological investigation. How? These are the factors. Study of existing geological data, whatever available in literature, whatever available in different government organizations, with scientists, with other organizations, it is required to be collected and studied first. Then geological mapping, then geophysical prospecting, whether electrical or seismic, then drilling, then ultimately it comes geotechnical studies. How the geological mapping is done? It is also very important. So recording of geological information from outcrop to provide a visual representation of geology of a region, it mainly includes the rock type, formation, boundary between different litho units, and structures. Then what are the structures? Fault, unconformity, and different lineaments. Then it helps in planning tunnel projects and also to eliminate the areas which are susceptible to failure due to geological hazards like earthquake, landslide, weathering effect, and it provides the information regarding the structural deposition of the rock, earthquake-prone areas, fault, and all these things. Once a geologist goes to the field, he collects the information like this. Detailed information is required to be collected religiously on the ground. And whatever the data is collected, whatever is seen in and this is called the outcrop mapping. This is the geological mapping of the area. Outcrop, each and every outcrop is to be identified on the ground. Give the number to them. You just see a second slide. The numbering has been done on the ground. If I go there or you go there, so please go and see all the numberings are there on the ground or not. Same numbering is there on the map or not. Then numbering, direction, if flow condition is there, some structure is there, that is also required to be recorded. Then ultimately handmade sketches are developed. Because handmade sketches are very important. Development of sketch in a topo plan or any other thing is very important. But making handmade after understanding the thing, it is very difficult. Once you know about all these things, then only you can do the justice with this geological mapping. And whatever the format you just see, this is the handmade format on the ground, very standardized format. Each and every detail of that particular outcrop is there in this. Whatever is there. Anybody can go at any time and verify this thing. Yes, this is the outcrop number, this is our format, he will see. That type of mapping is now required. Then cumulative field data collects like this, and it always comes together. A geological map gives so many informations like overburden. Overburden means it may be reoverburden material, it may be slow post material, it may be silty clay, it may be simple clay, it may be scree deposit, whatever it may be, it is deposited on the surface. That is called overburden. Then type of rock. One must have idea. That is called the experience. Whether it is biotite gneiss or granite gneiss or sandstone, siltstone, how? He must have something in his mind to know, because this is a virgin area for us. Then nature of the rock, mechanical, physical, and chemical erosion. Then weaknesses of the rock that also required to be identified. Then structures of this area it comes. You just see the overburden rock contact. It is very difficult to identify in the ground. The vegetation, some it is very difficult. So that it is identified properly, then fold and all these things, then ultimately all these features come in a single sheet. Like that, single outcrop is plotted, and after the plotting of this thing, interpreted map is made. Then the map comes in this form. It gives, if you go through this index, all the information, whatever there in the ground. Nothing, no stone has been unturned and untouched. That type of mapping is now required, and ultimately a geological section is prepared to understand what is the geology on the subsurface ground. We know on the surface now, based on the interpretation. So what a geological section gives? Detail of portals. All this, I say, astrological detail of a rock outcrop. This is the astrological detail. That is what required nowadays to understand, to plot, and to present in the report. Then it is supported with the photograph. Whatever this, you just see, one of the portal is there, photograph is there. One of the portal is there, kinematic study is there. So all these things are together. Once all these things in a single format, then anybody can understand all the things quickly, nicely, and formally. Then this type of study comes, and these are the different parameters. Then drilling comes. What? Drilling is a very essential item. And wherever the approach is not there, drilling can do wonders. It can give a strange results. All the formation is brought out together, correlated, and the entire area is scanned now. Then afterward management of core boxes like this, and a cross section is developed based on the drilling. It gives you, this is a very interesting cross section. It gives all the information at one place. You see, thus this shear zone is there, you see joint pattern is there, you see rock is there, you see overburden is there, you see recovery is there, you see RQD is there, you see whatever the data has been observed for this permeability, it is also plotted there. So everything is in one sheet. What else is required now? This is ultimately a permeability system. Then the geotechnical investigation comes. Different type of tests are done in rock and soil. Then ultimately petrography is done. Petrography is also very important to understand the strength of the rock and the nature of the rock and the mineral assemblages. Then geophysical survey comes. It is indirect method. It also gives very good results beforehand, and afterwards interpretation with the drilling data. This is a very important study which we have done in a river at Assam.
2 minutes.
Yeah. Okay. Then this here, this AEM, it gives whatever it gives, it can be correlated with the drill holes. Because of environmentally sensitive area, because of eco-sensitive zone, because of not allowing due to this defense purpose or some other purposes. So you have seen this dolphin, that fish is there. So Ministry of Environment Forest did not allow us to do the drilling and geological mapping. So we adopted this method, and first kind of method it has been adopted and got the best results. And ultimately seismotectonic studies are required. It depends on the this structure. Then rock investigation results comes together. Ultimately, based on this thing, we calculate this RMR, RQD, rock class, and all other parameters. Then slope stability studies also comes in the picture. Based on all this data, ultimately slope stability study can be done and make an idea where we have to put the tunnel. Then the other feasibility study model, then construction material comes, different tests are done for the construction material, then excavation of tunnel. So this is also duty of a investigation geologist. What type of excavation method should be used? So excavator, it is very common in shivalik regions. Then afterward, lesser Himalaya, drill and blast, TBM. So much in length has been discussed, but only one thing I want to say, that it is not like that TBM can be used everywhere. It is not like that. A religious and detailed investigation is required. Monolithic rock is there or not. So many cases of failure are there in Himalaya. Parvati hydropower project in Himachal Pradesh. For the last so many years it is stuck off. One more tunnel in some other area is stuck off. Reason? Presence or absence of the shear zones, presence or absence of groundwater. Nobody has studied. If the investigation is done like this, every study will be in a single paper, so nothing will be failed.
Dr. Dinesh.
Okay. Then environmental studies, then challenges, this access to the site, complex geology, site condition, safety. So time constant is there, sorry, I'm very sorry. This type of geological mapping is required to be done. You have to climb each and every place, collect the data. Then it is very difficult to carry out the drilling machine on the top of the tunnel. But it has also been done successfully, and drilling results are correlated with this thing. This is a study of a slide area. If you see, I'll take 1 more minute just. This type of landslide comes. This is one of the existing site. This is Wuzi. You just see the boulders are falling down road, all the vehicles are strengthened. So what you will do? Alternatively, you have to make a tunnel. No other alternative is, or you keep the dozer on both the sides and clean it all the day and night. Is it possible? Then the best way is to make the tunnel. Then impact on design, it is used numerical modeling which helps in estimation of support class. Then time and cost overrun, I will take 2 more minutes. Times and cost overrun, overbreak condition, it is required to be studied during investigation. If you do not know how overbreak will behave at the time of construction of tunnel, then it will in vain. Weak zones, it should be identified during investigation stage. Ingress of water, it is also required to be studied. Squeezing condition, if tunnel is squeezed afterwards, then nothing can be done except to waste a lot of money. Rock busting, it comes in the high cover condition. It has come one of the project in Himachal. Rock busting, it is very common now in a high cover area, and adequate rock cover lateral and this thing, uplift pressure. Recently, one drilling was going on near Alaknanda river. There is a river tributary called Dholi Ganga. So completely drilling machine got uplifted because of the presence of hot springs. So it is also required to be studied. Toxic gases, very common in northeastern region. Methane gas. One tunnel was there in Loktak, long back, 2 decades back. Complete methane gas came, most of the person got fainted. So this type of study is also required to be done well in advance. Then estimated quantity and approved muck disposal site, this is again a problematic thing. It is not done properly. It is required to be done properly so that contractor does not waste the time and ultimately he does not search out other sites. Then this is a very small case study. So first geological mapping is done, then why tunnel is made, it is required to be studied. How it is studied, you just see the muck, how much muck has come. That's why tunnel has been proposed. Then you just see height of the landslide. Every geologist has to visit there and study the area, then only a bankable geological data will come. Then material behavior is also required to be studied. Then how it will act, how this curve will act, it is also required to be studied based on the different softwares, and ultimately how it will behave after 50 years. It is also required to be known well in advance. Then accordingly tunnel location is to be shifted. Then this is a prediction after 50 years. Then few kinematic analysis has also been done intermittently in the portal, outlet and the slope also.
Dr.
This is the conclusion. So geotechnical investigation plays a crucial role in the design and construction of tunnel. It helps to identify and assess risk by providing information on the geology of tunnel site. Information obtained from geotechnical investigation is used to develop an appropriate tunneling method and design which can help minimize the risk associated with ground condition. It also assists in selection of suitable material for tunneling lining, which can improve durability and stability of tunnel. Overall, geotechnical investigation are critical in ensuring the safety and efficiency of the tunnel. Thank you for patience hearing.
Ladies and gentlemen, congratulations, Dr. Dinesh. I apologise for the minutes. 38 years experience, and the message is clear: do the work and keep it real. Ladies and gentlemen, thank you. If you could join in me again in thanking Dr. Dinesh in reducing 38 years into just 25 minutes. Thank you very much. Our next speaker is Lucy Rue, and as I foreshadowed earlier, what is particularly interesting with Lucy is, like Dr. Dinesh as well, decades of experience, and in Lucy's case, also her qualifications from her part of the world with being a chartered civil engineer and a fellow of the Institute of Civil Engineers in that part of the world. That's a serious thing. So with that, Lucy, the floor is yours.
Thank you, Arnold. It's a great honour to be here speaking to you today with a panel of such eminent speakers, and also because I'm representing Bernard Falconin, who is one of the world-leading experts in tunnelling and our former director. So I'm going to be talking to you about the geomechanical investigations for long tunnels in mountainous areas, and I'll try not to speak too quickly, but I do only have 20 minutes. We already have an introduction to why we need to carry out geotechnical investigations. I'm going to explore in a bit of depth some of those ideas we've just heard about. So survey, investigation and geological report preparation for tunnel works are very wide fields, and we can't do it justice in 20 minutes. This presentation is going to be focused on the investigation for long tunnels and especially on the key strategic issues. Tunnel construction and operation include numerous risks that must be mitigated insofar as possible by several measures, provisions and procedures during the design, the construction, but also the contracting and the operation. Operational risks will be discussed in a separate session tomorrow. Mitigation of the construction risks are the background of this presentation. The main risk that we're seeking to mitigate is a slippage in the cost and duration of the project, or even its unfeasibility. If we can't build it, we want to know before we start. The major risks we need to look at. So, tunnels in mountainous areas are most often long and deep. Mountains result from very powerful tectonic movements, and if we don't understand the geology, we can't understand how to interpret it. The geology in mountains is rarely soft and regular in big cities. What you can see in this picture is a typical tunnel in an urban area with regular layers of clays and sand. We don't get this in the mountains. We get something that looks like the second schematic. Very complex with numerous formations and the risk of significant convergence. This is a Alps, and I should think is quite similar to what you might find in the Himalaya. The major risks are related to the geology, the hydrogeological and geomechanical conditions, mechanical characteristics of the formations, high stresses, temperature conditions, and at the portals, which are vital, geomorphology, landslides, and avalanches. The impact of the risks may be huge on the investment costs, the construction deadlines, and even the feasibility if the risks have not been identified beforehand and if no mitigating and management measures have been taken. The investigations are essential for the identification and the evaluation of the risks and for planning, anticipation, and management. It's a mantra that I'll repeat later on. The investigation should start as early as possible in the design process and before the alignment is fixed. You can't fix an alignment before you've done the investigations. And they should include the tunnel and the access portals. The process is global. The accesses are often neglected and can be more critical than the tunnel itself. The careful location of the tunnel portals and, if necessary, a lengthening of the tunnel can lead to a more optimal, less risky and costly solution, even though this may not sound logical if you don't know what you're talking about. The main objectives of the investigation would be to collect all the information available so that we can establish the most representative and suitable geological profile, so that we can identify the different nature of ground, its organization, that's the structural organization and quality, locate and identify discontinuities and major accidents, identify potential hazards and display the uncertainties, identify hydrogeological and temperature conditions, evaluate the geomechanical characteristics of the different formations, and evaluate, especially for deep tunnels, this is really important, the risks and probability of rock burst, squeezing, spalling, water flow, and hydrostatic high pressure For instance, limestone casts can contain very large volumes of pressurized water. Regarding the concept of the investigation, the main objectives would be to provide the designer with the information that he needs or she needs, to design the structures, evaluate the convergences, so convergences are when the tunnel closes in on itself, define and dimension the support. We need to evaluate the uncertainties and the risks, and we need to define the most suitable execution methods. And finally, we need to evaluate the production rates to be assessed during the works. All of this is so that we can plan, anticipate, and manage the risks, and so also the project costs. The investigation strategy is specific to each project and the issues encountered. However, experience, methods, and tools of other projects can be successfully reused. As we've heard just now, each project is unique. The investigation is a progressive and iterative process, from the preliminary steps with a global approach to very detailed analysis focused on specific issues which you will identify as you go through the investigations. Each stage of the investigation should be defined according to the results and uncertainties of the previous stage. It's a long process, it costs time and money, but ensures the feasibility of the project, including the planned cost and schedule, and of course the safety of the people constructing the works and who will ultimately be using the tunnel at the end. For the long alpine tunnels that have been constructed or are under construction in recent times, there are 3 of them that are each over 50 kilometers in length. And for these, the investigations took over 10 years. For less complex projects, several years is the usual ratio, but it is a matter of years and not months. Poor investigations often lead to very difficult or even catastrophic situations during the works. Investigations may represent an important budget, but they should be seen as an investment and an insurance, not as an expense. This graph shows the correlation between the investigation costs and proven costs for risk for several real tunnel projects. The y-axis shows the investigation cost as a percentage of the tunnel target cost. The x-axis shows the proven cost of the risks, again as a percentage of the target cost. The graph has been developed, as I said, with real project data. The main information to retain, it's a complex graph, I know, is that a project with low investment in investigations may have some nasty surprises and could end up costing double or even worse. It may not be possible, and if you discover that when you've already built half of the tunnel, that's quite a disaster. And a question one can ask oneself is how much would it have cost if the right choices had been made from the design stage? Well, from here we can see that you may have only spent 8% of the total cost of the tunnel to have been able to reduce the cost significantly. I'm not going to present all the methods and techniques for investigation, although we already heard quite a lot of them in the previous presentation. There are many. What I would suggest to you is to refer to the international recommendations and guidelines. They're very well detailed, they're well documented, and they often result from working groups with a broad multidisciplinary and multi-trade and international experience. For example, I would refer you to the AFTES, that is the French Tunnelling Association recommendation from Working Group 32, which is available in English as well as obviously in French. What I'm going to talk about now presents the most essential methods of investigation as well as new approaches that have been developed in recent projects. The main difficulty for the investigation is often the impossibility to access from the surface, which is a problem you have here in India. The relief may be too steep, there may be too great an overburden, 1 to 3 kilometers as a minimum could happen. There could be glaciers, so you can't access the ground, etc. This handicap often requires a combination of several investigation methods. To start with, we would look at geological maps, but only for the preliminary stages, and many countries don't actually have regional geological maps.
We can carry out detailed geological surveys for lithology and structure. This is an essential tool that requires great rigour and very meticulous tracking. Interpretation must be carried out using structural geology, not the usual lithology approach that is not relevant. Structural geology means understanding the tectonic movements that have created the mountain. Without this knowledge, the interpretation of the investigations will not be possible. You may need to carry out laboratory analysis, petrography. For anybody that doesn't know, that's the analysis of the composition, the mineral composition of rocks. Structural geology is not known in many countries. It's very sensitive and requires highly skilled geologists familiar with this sort of analysis. There could be difficulties in very rugged terrain, abundant vegetation cover, or, as I said earlier, glaciers. We can also use the interpretation of aerial photographs or satellite data. These are complementary and often preliminary methods to geological ground surveys. Image analysis has been replaced more recently by methods based on digital terrain model and the use of geological interpretation software. This method is very powerful in high mountain areas. It's also fast and allows the establishment of a 3D full numerical geological model. The results of the investigation are then added to the initial model so that it can be refined. This is an example from the New Andes Crossing Tunnel. This is a 100% digital terrain model. What we can see, for instance, the red mass is a volcanic intrusion that was suspected from the aerial photography. So we knew we needed to carry out a boreholes here to see what the impact would be on the design. The structural geology was essential for defining the geological profile. The directions of the faults and sometimes the perpendicular secondary breaking is fundamental for designing the temporary support and even deciding in which direction the tunnel should be excavated. It may not be an upward drive, the downward drive may be preferential. The dark blue zone to the right of the schematic represents anhydrites. Could they be avoided? And if not, what strategies should be implemented to mitigate their impacts, which could cause squeezing, creep, and heave when it's in contact with water? Boreholes we all know about. They can be destructive or cored. They're very popular and efficient. However, there are limitations. Access above the tunnel is sometimes impossible. They give punctual results and become uncompetitive in the case of very deep tunnels. Directed drillings can overcome these inconveniences. It's a complex technology that's been adapted from the mining industry, and it was used for the first time in 2002 in the new Lyon-Turin tunnel, which is 57.5 kilometers long. And here you can see on the graph the black line, the thick black line, which shows that we drilled down by 500 meters and then horizontally by 1,600 meters. Here they allowed us to consider an alignment that would otherwise have been abandoned. And I'll be talking more about this specific project tomorrow. We can also carry out an exploration gallery. For instance, the 4 new major alpine rail tunnels in Europe, the Lochberg, the Gotthard, the Brenner, Lyon-Turin, ranging from 30 to 57 kilometers in length, have several sections of exploration gallery. The gallery sections are often associated with underground descending accesses that are put to use later during the construction and the operation. The picture you can see is the TELT project, the new Lyon-Turin rail-based tunnel, 57.5 kilometers long. The red circles show the descending accesses, and the green line shows the sections of exploration gallery that have and are being excavated. Something else we mustn't neglect are the temperatures that you can get in very deep tunnels. Temperature measurements and modelling are mandatory for deep tunnels. An example could be the measurements on the TELT project, where we did 140 meters of drilling, and we forecast the temperature at the project level of 48 degrees centigrade. To excavate a 9-kilometer long tunnel with a tunnel boring machine at temperatures exceeding 40 degrees centigrade requires specific ventilation provisions. You'd probably need to implement additional ventilation ducting, which requires more space and could actually impact the bored diameter, so the design of your tunnel boring machine. And you can see on the graph that our predicted temperatures very accurately matched what we actually measured during the construction. You can see at the top of the slide the geological longitudinal profile, which was provided to us by the client for part of the project. We carried out a 10-year preliminary investigation campaign. We carried out the investigations in 3 phases. The first phase was standard investigations, traditional drillings for 40 kilometres, 5 kilometres of directional drillings, seismic reflection and refraction from the surface for 123 kilometres, seismic down the hole 85 kilometres, and electric geophysics for 4 kilometres. It took 10 years because each investigation gave us new questions, and we also had to advance gradually to be able to obtain additional funding for the investigations.
5 minutes.
Thank you. It's a 57-kilometre tunnel with extremely complex geology, and we wanted to minimise the risk during construction. However, 10 years was exceptional on this project. The second stage of investigation was to carry out ancillary works. We excavated 3 descending access galleries of a total of 8.9 kilometres, and we carried out 8 kilometres of exploration galleries in the tunnel access. The third stage was to carry out preliminary works that could then be integrated into the final project, and they're also used to complete the collection of data. The example would be from Saint-Martin-la-Porte 4, which I'm talking about tomorrow, where we excavated 9 kilometres of TBM and 2 kilometres of traditional tunnel in extremely complex geology, possibly the most complex tunnel excavated to date in the world. They confirmed the feasibility of the project and will be integrated as part of the base tunnel. The key strategic issues: even the most complete investigations do not predict or protect against all of the risks and uncertainties that can be prohibitive for the whole construction works. Here are some examples. You can see on this photograph very large convergences that were found on a TELT tunnel when crossing a very large fossil slide at great depths. The position of the landside was known by the investigation. However, we did not know the characteristics and stresses which were impossible to evaluate. But because we knew we were going to find this sort of geological fault, the contract was written specifically so that the risks could be shared between the employer and the contractor. Consequently, there were very few opportunities for claiming. Huge convergences. This is another section of TELT tunnel. The blue line shows the initial section that we excavated, the blue circle. The red oval shows how the tunnel converged. That's not a separate section. It was built at the section of the blue circle and it closed to the section of the red oval. If anybody wants information on the convergences in the graph to the right, I can explain later. And then we have the Ortières tunnel on the A43 motorway. We crossed a fossil stream furrow. It was very localized, and the narrow furrow was dug underneath a glacier from the Verme age, ice age 20,000 years ago. Only one tube was affected, and we were able to carry out jet grouting from the unaffected tube to treat the ground so that we were able to excavate the second tube. And the great surprise is we were able to keep to schedule, and the tunnel costs only increased by 10%. The remaining high probability of risks and high uncertainties may lead to carrying out preliminary works that are part of the final project. This can help us confirm the feasibility, the assumptions and the methods. It can make the construction period more reliable. It can reduce the risks and uncertainties. And it can confine in a separate contract, if necessary, works with a high level of contingency to avoid their contractual impact on the global contract.
2 minutes.
This is another section of the TELT project, which I'll be describing tomorrow, but it's the crossing of a 9-kilometre coal formation with a number of very significant geological issues that we needed to explore further to determine if the project was feasible. And to conclude, not all projects are so exceptional and do not require such extensive investigations. The principles and methods presented remain applicable to more common projects. The strategy and programme of an investigation campaign needs to be defined and adapted to the potential risks of each project and the magnitude of their consequences. The level of risk one is willing to take with full knowledge and awareness. It's an investment to guarantee the successful outcome of the project. A campaign requires to be useful and effective, time and a sufficient budget, both of which, I repeat again, are an investment. The uncertainties and hazards must be considered when drawing up the contract, in particular to define a balanced and fair distribution of the risks between the owner and the contractor, knowing that the owner is responsible for the ground and its characteristics, and the contractor can only take the risks he is able to assess according to the information given by the owner before signing the contract. A method of remuneration that is adapted to consider risks that have not been identified or properly qualified and quantified. You can get more information on the ITA and ITES publications or from the AFTES publications and recommendations. Thank you for your attention. You can take a note of my email address. I'm also on LinkedIn if you'd like to have any further information. And I'd like to thank again Bernard Falconer, who did prepare this presentation originally. Thank you.
Thank you very much, Lucy, and thank you for keeping to the time. And if there is a theme emerging, it has to be keep it real and understand these rocks or big trouble. Now the third presenter is Dr. Subhash Chandra. Dr. Chandra, the floor is yours.
Good evening, Chair, Co-Chair, and participants. Let me first thank this organizer to invite me. Probably I may be one of the having least experience on the tunneling, but very shortly we have started using the Hellebone geophysics. We have covered the 126 kilometer long tunnel of Rishikesh to Karnaprayag with RVNL, and roughly around 150 plus of the Konkan rail in the Western Ghat. So I'll be sharing, and even we have in accident in the case of Tapovan, we had to rush and do some survey. So I'll be sharing some of the knowledge, but then before as the task has been assigned to give the geophysical investigation for road tunnel in India, especially identification and the planning. So I'll try to give cover the introductory part. Certainly, geophysics is one of the very effective method of non-invasive way of assessing the ground conditions, even mapping the ground condition very rapidly. And to characterize, it can be in the pre-mode or post of the tunnel construction to understand the different scenarios. Because once we are going to construct the tunnel, a lot of dynamic changes happens besides the structural feature, which is very important while tunneling, construction of the tunneling. But then in the post mode, how the groundwater dynamics is going to change when we are puncturing the aquifer system, and how groundwater flow reversing can take place. Even the aquifer can dry over the period of time. That can also lead to the land subsidies, or many things can happen. So that's why a continuous, a high resolution mapping of these patches are very, very essential. Main goal is to achieve an accurate and continuous information of the subsurface. Of course, at short span of time, and mainly we have a target to look for the caves, aquifer, structural feature. Our previous speaker has stressed upon that rather than lithology, it should be structural feature, because that matters a lot while construction of the tunnel. So I'll be covering like various geophysical method, what are advantages, limitations, and then going to the airborne geophysics, how it works, and then results, including the challenges while carrying out in hilly terrains, especially. Already has been covered, like seismic reflection and refraction, that deals with the elastic property of the material, that you can get it. What is the compactness or some structural disturbance? Certainly, your velocity is going to be reduced. So there are refraction and reflection. Refraction can give the shallow information and reflection, but these are all ground-based method where you need to go, and even to go the deeper level, like sometimes the tunnel can be constructed at 1 kilometer deep. So you need a good amount of energy where blasting may be required, which may not be again good for these kind of terrain, especially in Himalaya. There are control source audio magnetotelluric, like magnetotelluric natural source, but here we use control source like artificial source at varying frequency and try to measure that can go 1 to 2 kilometer. But then certainly we are going to have a reduced resolution, and again you have to climb and put it, and how you plant your different sensor that decide the coverage. The coverage may, the mapping may be another issue. Ray-shooting method is well known, so easily you can go 100 to 200 meter, 300 meter. In fact, in Australia, they have gone even to 6-7 kilometers using the poles of the telephone and 20 kilometers. But then you need a straight access, which are not at all possible, these kind of terrain. So that also is ruled out. That can be again applied at very local scale at a flat ground or a little undulating, but not a kind of mapping. Then we are left with the electromagnetic, especially the transient electromagnetic, which is operated at ground and airborne. So, and the airborne especially provides you the flexibility to cover the terrain, and you can cover 200 kilometers, 300 kilometers in a day. So that becomes very, very fast. You acquire the data in a microsecond scale, and you get a mapping at tens of meters, or even sometimes you acquire the data every 2 to 3 meters depending upon the helicopter speed. So I'm going to cover more how it works. Actually, there is suppose these are the terrain, 2 layers, and this is the loop, a current wire you are putting, and there is we send a current, and this current sets a magnetic field into the ground in the surrounding. When suddenly this the current which is sent in the loop is turned off, these changes are objected, so there is induced eddy current, and these eddy currents generate a second, that also decays with the time, and any changes in the system is opposed, so that generates a secondary electromagnetic field which is recorded in this receiver loop, and these are all numbers and that we convert. So more conductive, more the signal, and lower the resistivity, and if you have compact, hard, etc., you have a less induction, so high resistivity, so you can interpret that way. But then certainly we need to have a knowledge of geology, and then you can interpret the sedimentary rock or igneous rock, what kind of primary porosity, secondary porosity, clay, sand, etc. All those things can be interpreted. How it is, this talks about the sensitivity. Suppose you have a 4-layer case, 1, 2, 3, 4, 5, and these numbers, like this talks about resistivity, so 100 ohm meter, high resistivity, more compact, 30 ohm meter, low resistivity, a conductive environment, resistive, conductive. And the EM method is sensitive to the conductivity of the formation. So you can see that here it stays more time, here it stays more time, and you get a high, and by seeing this dV by dt curve, you can interpret what kind of terrain it is going. So that is, and then actually we have been carrying out for groundwater mapping. Recently we have covered this RVNL tunnel of 126 kilometers, starting from Rishikesh to Kanprayag, and from Thallassery, Kerala to Mysuru for the Konkan railway. Why, how these data density matters? So this is the schematic diagram for any earth scientist or any branch of science. We make observation and try to do the pattern recognition. And suppose the hydrologist there, he will try to see that lineaments or structural geology, lineaments, etc. So suppose these 2 different colors of dots are there, like red and blue. One possible scenario would be like this. This could be one model. and another person with have some more experience can say this could be. But if you increase the data density, you have a more control, so your model become more realistic. So that's how data density gives you controls and refines your model distribution. And the same loop is lifted in the helibone. The same loop is lifted above the ground, roughly 30 to 40 meter ideally. What we are using is a dual moment technology. Of course, we have both the technologies. And there could be number of flight line, and each flight line, each dart will have ratio-to distribution with the depth, but we have used that goes up to 500 meter or so. There are the technology that can go even deeper, but then it is subject to the conditions, how the ground conditions are there, status are there. This is published literature which shows the differential, the weather profile of the granitic rock, which has gone to the subjective differential and multi-phase upliftment, erosion, etc. That create a lot of weathering and fracturing, alteration in the rock, and there are quartz vein, tectonic features, and these kind of features. Why I'm presenting? Because once you and while these features facilitate to water percolation, and there are some mineral composition that gets weathered fast, so there is a tensile forces. That there will be swelling that creates further microcakes, and so though the fracture or these kind of faults, etc., the dimension may be less, but then the aperture in terms of conductivity distribution are quite high, and that's the reason we see these kind of low and deeper. So this gives indication that there are some conductive targets at the deeper level. And these are like, geology, magnetic, airborne magnetic, race UT at different depth, we can see. So this is from Western Ghat profile. And these are the like gneisses, there are charnockite, there are a number of geological terrains are there. And we have flown, and then for tunnel you require very precise information along the tunnel. So we have put a line all along the tunnel, then 200 meter either side, and 500 meter, then 2 kilometer, and then 5 kilometer to have what are the localized feature, what are the regional scale feature, and how to differentiate. So that become quite crucial. And I'll go directly to the result. This is like once you get these information, these are processed, and we get the 3D distribution. And these are the race UT, and you can see the geology. And this along the sea coast, so there is a lot of saline water intrusion. So you can see the blue patches, the race UT, low race UT, high race UT. So you can say that low race UT is more conductive, more the weak rock are sedimentary kind of are loose formations. They are more hard and compact. These are the fault. There are the different geology. Fault is going like this, and you can see here the change in the race UT. You can see here change in the race UT. So this is depth at 0 to 10 meter. The moment we go 40 to 50 meter, you can see here the changes still. You can see here the changes, and we have gone up to 150 to 200 meter. You can see. So these yellow patch among the these are the relative changes. They are not giving the exact ratio, but the relative ratio because there are a certain degree of averaging. So we can pinpoint these kind of fracture, the structural feature in the geology, which can be vulnerable for while construction of the tunnel. Along the tunnel, like this is from 0 to 30 meter, you can see these, and these are the different like migmatite, the Harvard group, and charnockites, and the contact. You can see here change in the ratio T, and these are the Euler's depth that gives the depth of the causative body, and that is also in a straight line. And you can see here, and these are at this contact, geological contact, so that become vulnerable. And you can see here also. So it is done in the combination of aeromagnetic, the electromagnetic. So both controls are there. Yeah, and then these are like geological contact that has been interpreted exactly the way our previous speaker has talked about, how deep it is there and where are the locations. These features are there like fractures, etc. The major geological structural features, so those things has been interpreted. Coming to Rishikesh, to Karnaprayag, this is Rishikesh, this is Karnaprayag, and actually this was the first tunnel we have flown, and initial 1 week pilots were saying that no, you give a straight line. It was so horrible that 1 week flying was total gone without any usable data because they could not fly the way the tunnel was planned. And after 1 week of flying, they got some experience and then they started flying. But otherwise, they have been asking, just give me a straight line, no zigzag line. So it was quite horrible, but then it has given a lot of lessons, and there has been a lot of other like high tension power line running for Uttarakhand and UP, etc. So number of concerns are there. We will discuss. But then geologically it's very nice. It is very well responding. Only challenge is that to fly as close as possible to the ground conditions. And this is one glimpse, like you can see in the previous slide, you can see these are the synclinal features. This can be quite risky, and these are the same. So if any changes are happening, that is alteration or there are tectonic features. So that way we can get it, and you can see these are the color. This side, this side, this side. So this gives about this synclinal feature, and we see the changes in the ratiosity, high ratiosity, low ratiosity at this contact, at this contact. So these are the geology provided by the RNL. We are trying to correlate 1-to-1, and we are getting a quite good correlation. Of course, a lot of data has been deleted because of noisy condition, and we could not fly the way we wanted to fly. I think 5 minutes is left, so I'll come to the Uttarakhand because while flying for the RVNL, there was some accident at NTPC tunnel near Tapovan, where almost I think around 150 personnel were entrapped into the tunnel, and then suddenly we were asked that can you do something for this? And of course it was very hard because the coordinate system used by the engineers and what we use, there have been a lot of problem, and what they have been communicating, what we have been asking, a lot of nightmare were there to understand, and then finally we could manage somehow to get those proper location and try to put it. And these are actually Alaknanda River, and these are the tunnel. Of course, there are a lot of another tunnel crisscrossing, maybe support or you understand better. So we planned like these are the flight line, and we have been sitting at Srinagar and asked the pilot to go and fly. It was roughly I think 100 kilometer or so, 200 kilometer via another temporary helipad. We asked them to go and fly and then come back. But then when they reach, actually this is flying at 60 kilometer per hour speed, so roughly 1 kilometer you cover in a minute. And they got totally confused. The moment you go and suddenly there is a high cliff and how to, so they started rounding and rounding. They thought, okay, we'll cover. They forgot our flight line plan, so they flown like this. And finally we got this ratiosity, like this is at 0 to 5 meter, and these are the, I mean, when you construct, these are the start of the tunnel, in fact. So a lot of changes, and there's the side by river is going. So we get the ratiosity distribution like this. And what the relative changes, like if you go to 20 meter, there are some changes over here, there are some changes over here, 50 meter. And this is started disappearing. So we are getting, actually it is responding very well, but and these are the 3D distributions. So you get it complete information, in fact, a kind comprehensive. But of course there are a lot of interpolations. So we need, once we put all the tunnel plan, etc., it can be mapped, and consider that once, if we have these kind of information before the tunnel construction, then after, then what are the changes, temporal changes, are changes due to ingress of the water, etc., or slush, etc., that can be very well mapped and located. The challenges what we face, ideally we are supposed to fly at 30 meter above the ground, and your signal drops 1 cube root, 1 over cube root. So the more you go higher, your signal drops down, so that sometimes it can go within the noise level, so hardly you get any useful data. So Well, and then in this terrain, roughly your hills from one to another, roughly, start repeating 1.5 to 2 kilometers. So very close by, and the 1 to 2 minute, and then pilots, it become a nightmare for them. So we have tried initially to fly like this, and of course we have got a new idea that rather than flying, there will be more additional number of flying, but then we have to follow the contour height to get it more accurate information. So in future, we are going to improve the flight plan. Another scientific challenge is that our ground should be parallel to the loop, and if you see here, there are inclines, so that is again going to impact your signal records, signal strength. So these are the some challenges, and we are recording not only the jet component, that like vertical field, we are recording the X component also. So combined together, we are hoping that we can further come up for improved informations. So to conclude, airborne electromagnetic is very effective, and it is already prudent for a number of geotechnical investigations. Coming to the tunnel, certainly we need to have some improved the flight plan, and of course over the period of time some more technology we are working out, being an R&D organization, that how it can be further improved. And these structural feature, cavities, major, these are a very easy target for this, provided we are able to fly at the closest possible, the way it is required. We have already, like you have seen, that high resolution subsurface characterization with the connectivity and continuity in 3D. The TEM and magnetic is natural complementary tool. Results of the terrain also we have seen for the Western Ghat. These are affected by the power lines, so advanced. Actually, we have managed for RVNL to shut down some of the power, high tension power, to get some data. So we did a lot of exercise while surveying. Another serious problem is the smoke in the valley that settled down, and we have to wait for the rain to clear out those things. So these kinds of challenges, that increases the cost. So thanks a lot, and I must thank to the Ministry of Jal Shakti, Central Groundwater Board, Nawami Gange, Surat Municipality, Konkan Railway, Rail Vikas, and of course the IRC and road authorities for providing this opportunity. So thanks a lot. I'll be happy to respond to the question if any.
Thank you very much, Dr. Chandra. If you'll join with me. Dr. Chandra actually self-regulated his time, showing that he really is a chief scientist and able to regulate even himself. We have an opportunity to take questions, and can I just ask one question for a 10-second answer from each of you three? The Prime Minister of India has announced his Gati Shakti national program and plan for the country. We've just heard about the importance of pre-project investigation. This plan is urgent. What, in 10 seconds, each of your views, is the most important thing to do if you have to do the project quickly? I'll start in the order of the speakers. 38 years experience, delivered lots of projects. From your perspective, what is the absolutely most important thing to do, Doctor? I'll say, sorry, Dr. Dinesh, if you have only 10 seconds to answer what is the most important thing to do in preparation for a project, if time is a problem, what would you recommend?
In
10 seconds.
About the investigations, this, this has already been discussed by me. This time and this cost, both are correlatable to each other. First thing is that. And if you do not do this investigation properly, well in time, and under the certain guidance, as well as completion of taking the data well in time, so it is not possible to do any project within time frame, or without cost overrun.
Okay. Thank you very much. And Lucy Rue?
I think you need to carry out a risk assessment. You need to identify all the possible risks, and you need to assess the impact that they could have on the project in terms of delay and cost, and then identify the critical ones to eliminate those risks to determine if the project is worth pursuing or not.
Thank you. Now, Dr. Chandra, you've responded to a disaster, so I think I know what you're going to say. 10 seconds, what do you recommend we do when time is short?
Yeah, certainly, of course, considering the time, but then what I feel that, like recently we had suffered the case near, Tapovan. There is a lot of havoc and a lot of panic, and there will be cracks, etc. So I feel only constructing that there are a strong engineering technology in any conditions the tunnel can be constructed, but then geotechnical investigation, pre and post assessing the conditions is very, very important for its long-term sustainability and risk. Yeah.
So your answer is definitely do the initial pre-project study so you can do the change analysis quickly. Okay, ladies and gentlemen, your questions from the audience. My goodness, young man in the front, and then.
Well, not so young anymore. But I would like to ask Dr. Dinesh about the risk in case of misinterpretation. You got a lot of information, geotechnical information, assembled. You did not mention the geotechnical baseline report as it is defined in the Emerald Book of the FIDIC, new FIDIC recommendations.
So, Dr. Dinesh, can I summarize your question?
Who takes the risk of misinterpretation?
In fact, the risk has also been discussed by me in detail, if you have heard, that there are two activities. One is the investigation and other is the construction. If we do not do the investigation properly and sincerely, so how we can avoid the risk during construction? Because we do not have the knowledge. We have to have the knowledge of surface. We have to have the knowledge based on the surface observation of the subsurface area. If we do not have the proper knowledge of the surface, how we will extrapolate this thing and how we will be able to understand what type of risk is going to be obtained at the time of excavation, at the time of construction of the tunnel, because man, machinery and material. Three things are there which are involved in the construction of the tunnels.
Okay, let me respond with one example, and I'm talking about the Gotthard Base Tunnel. You know, in the early beginning of the feasibility studies, the Piora fault has been kind of a killing argument for the Gotthard Base Tunnel, and it was the ETH, University of Zurich, Dr. Kovari, who said that the Piora fault zone is super dangerous. Finally, it has not been shown that it is such a big risk. But maybe Lucy Roux can respond to that.
Okay, thus I'll respond in 2 lines. You have talked about the pure fault zones. Himalaya is full of stench. Himalaya is not a simple and ordinary rock formation. It is not like other type of this peninsular India or the rest of the rest of the country. There are so many good rocks are there, good formations are there. But here it is entirely different. Fault is one thing. Fault is the one thing. Fault zone is other thing. Then movement in different directions, that is a third thing. And shear zones, fault. Then if you see this thrust. In Himalayan geology, so many things are there together. You have to study all the things in one line. Fault is not one thing that will disturb the entire thing and it will jeopardize the working on the tunnel. It is not like that. There are some zones which can create squeezing also.
But you know, the
So,
Himalayas and the
gentlemen,
geologic age of the Andes
Harold?
and of the Rocky Mountains, it's all the same.
So, Harold,
it is true.
Gentlemen, so it's questions and answers, and I'm really interested in what you're discussing, but there's another question behind, and we can discuss after. I think we can agree complex geology causes complex issues which have to be resolved through systematic analysis and apportionment of liability. Can we just leave it there for the moment, and I'll take another question, because we don't have so much time. Yep.
Good evening. Good evening. My question goes to Mr. Tripathi.
Microphone near your mouth, please. Big voice.
My question goes to Mr. Tripathi. Any rough idea of range of estimate of bankable investigation in Himalayas? Do you agree with the MS Lucy's observation 2 to 8% in the case of Himalayan zones of the tunnel cost as a bankable investigation versus time frame as pointed out by Professor Arnold?
In fact, this investigation is responsible for the time, whether time increases or decreases. 2 to 8%, you are telling this common range. It is not like that also in practical. If you work on the ground, investigation, after you are doing the investigation, it varies from place to place. It varies from tunnel to tunnel. It varies from formation to formation. 2 to 8% is the standardized thing which has been written in the paper.
In case of Himalayas, if you can...
In case of Himalayas, it is even sometimes 8 to 10% or so. If you see, there are some zones which are squeezing. Lot of water. There is a case of Bagaliar. I will tell you, Bagaliar is in Himachal, the J&K. There was a tunnel which was being constructed for hydropower. You know, for 4.5 months, complete water jet was there. Complete water jet. And that jet, it used to start from here, it goes up to the end of this hall for 4.5 months. Can you imagine? Was it possible to do the work? It was not at all, because all the machinery was thrown out. So this is one thing. So that's what I am telling again and again. A bankable investigation is required, because that is blind. We do not know anything. That is what our experience will come into the picture. So whatever we have done for this time and again, that should count. And based on that, we can have a fairly good idea about the subsurface thing. Then this cost, whatever varies from 2 to 8% or 8 to 10%, can be tentatively worked out. Otherwise, just it is like that. We are telling something, reading something somewhere in some papers or like that. It is not. It varies from place to place. And Himalayan, I am telling, it is fragile. And it has different rock formations. One is Shivalik, other is Lower Himalayas, then Middle Himalayas, then Higher Himalayas, then Trans Himalayas. Which formation you are talking about? That is important.
So, Dr. Nilesh, this is very interesting, your answer. We had Dr. Wagner saying we did investigation, we identified the problem, and it wasn't. And then we have an explanation here where you go blind, and it's a huge problem. It's telling us this is a difficult task. Question over here.
My question goes to Lucy as well as first speaker Dinesh also. It is well said that every detail like geological, geomorphological, geotechnical, geophysical tests should be done. But if you agree that drill borehole is the confirmatory, and for tunneling, drilling should be done up to the inward level of the tunnel. But due to this overburden height and deep tunnel, it is not possible to reach up to the inward level of the tunnel. Therefore, in that case, there are two issues. First, based on the past experience and available technology, up to what maximum depth drilling can be done as on date. Tomorrow what will happen, I can't say. Number two, if it is not possible to go up to the inward level of the tunnel, then what is the alternative available test which can confirm the type and nature of the rock available at the invert level?
Tough question for you, Lucy. Tough one. Himalayas are pretty big.
Yeah, okay, so in my presentation I gave the example of the directional drillings that we did in 2002, where we drilled down to 500 meters depth vertically and then we went along horizontally. That maybe you can go deeper, I don't know, that's the only project I know of where it's been used. Then if you can't use boreholes, then what you can do is to construct an ancillary structure. So here we had our access tunnels, the down tunnels, which were then also used as access points for the construction of the project, so they're not lost. And from those access tunnels, that already gives you quite a lot of information, but it also brings you closer to the tunnel invert. So from the access adit, you can drill from there, and you may have already gained, I don't know, 500 meters you could already have gained in depth with the access adit, and then from there you can then drill several hundred meters down. So that gives you an increased access for information for carrying out boreholes.
So Lucy, on our right and on everybody else's left, Dr. Dinesh is getting ready to respond as well. And I suspect he's going to say something about just how tall these mountains are, but it's just a guess. Dr. Dinesh, what do you say from 38 years in the Himalayas?
This is really very interesting question. This is being asked in so many forums. Here in Himalayan condition, as you have very correctly asked, that how many holes, up to what depth, and how we will interpret. These are the three questions from your side. If you go through code, so the code says in every 100 meters you do one hole. Is it possible? No. Because we have not done any geological study and code is telling like that. Code is also required to be changed, number one. Number two, there are certain machines in India which drill even plus 1 kilometer that we have done. 300, 400 meters very commonly we have done and collected and made the log. That is not a problem. Including water test in rock with the help of single packer. Subsequently with this thing. Second thing, if it is not possible, suppose that area is very complicated and it is too difficult to carry out the machine over there, then interpretation comes in the picture. We can have some drill holes up to approachability. Based on this thing and whatever the observation has been made on the ground, there are, I always told you, so many sets of joints are there, foliation is there, bedding is there, characteristic of this outcrop is there. We have got the entire, that is what I call this astrological detail of a outcrop. It is only for that purpose. That is extrapolated based on the available drill holes and a little bit geophysical studies. Of course, geophysical study also cannot go more than 40-50 meters. So it is also not possible, but these are the things. Nowadays, one more method has come into practice, that is called cross-hole tomography. 2 holes are done. In between 2 holes, entire scanning is done. So there are systems, but very expensive. It is to be allowed first. Then it is possible. Other 1 kilometer drilling, very expensive. I do not know how many departments will allow for this. That's why it is a common practice to go small holes and go up to the tunnel invert wherever it is possible. Otherwise, interpretation is there, geophysical method is there, and whatever the data has been observed, different deep nalas, road cuttings, that is used and plotted a bankable geological section, which give by and large good geological judgment. 1 kilometer in India is available, that was I know. I do not know about
Well, that's what we did on this project, yes. And of course, you can always build a pilot tunnel. So you can drill a small diameter pilot tunnel through the line of your project, which is, you have less risk of collapse because it's a small diameter, and that can give you a lot of information, and if you're clever, you can incorporate it into your final project.
Ladies and gentlemen, it's like an auction. We went 500 metres, 1,000 metres. I was about to call the auction, but there's a late vote coming, or a late call here. Yes.
CSIR NGRA has been carrying out long-term project on Koyna Reservoir. Reservoirs induced seismicity in the Koyna region. the near Western Ghat. And we have already carried out drilling of around more than 1.5 kilometer. We have done all the measurements, and not necessarily. I just wanted to add that, see, we have to go for the integration. There are the geophysical technique like that can do the continuous measurement. Then you can do a drilling, not necessarily the core drilling. It can be a DTS or any kind of drilling, but then followed by the geophysical logging, where you can really very nicely find out the each strata, and then with the magnetic, etc., all integrated together, you can very nicely take to the deeper level with the high confidence level. So it cannot be done only by even for the cross borehole tomography. You need to go and drill all those things. There are many non-invasive way. Then where we suspect, we drill it. Some could be positive anomaly, some could be negative anomaly, followed by geophysical logging, and then a joint interpretation that what is the confidence level, how much you can, borehole gives only localized information. What is there 1 meter away, 2 meter away, what is your confidence level? So where we need to tie up with the geophysical data, which gives you little bigger at the larger scale, and then so that's how integration will certainly help our level of confidence, including the depth of investigation. Thank you.
Thank you very much, Dr. Chandra. We could discuss this for a long time, because this is such a serious matter, but I have to draw our questions and the answers to a close, and now call on my learned friend and co-chair, R.K. Mehra, to summarise, and this is a difficult job, to summarise such a discussion in a few minutes. Thank you, my friend.
Thank you. I will quickly summarize all three presentations. The first one was tunnel investigation model by Mr. Dinesh. He elaborated the national and international guidelines for investigation. In India, we are having IRC guideline SP 91 2019 guideline for road tunnel, and another IRC guideline SP 123 2017 guideline for geophysical investigations. Actually, geological investigation plays an important role in construction process to understand and provide information on surface and subsurface ground geo conditions. He explained the use of satellite imagery for first-hand information of investigations. He also explained about airborne electromagnetic survey, AEM, where investigation is not possible on the ground. And second one was geomechanical investigation for long tunnels in mountains by Lucy Ryu. She highlighted especially on key issues like construction risk mitigations, and we can say from her presentation that higher the investigation cost, lesser will be the cost of risk during construction, and the investigation should not be treated as an expense, but it should be treated as an investigation, an investment. In a case study, she explained the investigation approach which was applied in 4 major new alpine rail tunnels having a length of 30 to 57 kilometers. And last one was third one, geophysical investigations for road tunnels, identification and planning, Dr. Subhash Chandra. For this also we are having IRC guideline 123 2017. He explained about geophysical prospecting method for investigation of strata. First one was ground-based point local scale, and second one was airborne geophysical method. It is good for us that CSIR took a good initiative of heliborne geophysics for groundwater in India since 2012. They have used this heliborne EM survey method for rail tunnel projects of Rishikesh and Karnaprayag rail line, and also RVNL tunnel projects in Himalayas hills. Although this method is effective in mapping of fault cavities and major fractures and overburdens, but At the same time, investigation is affected by power lines, metallic installations, and also the height is the limitations for getting accurate data. So it was on the summary of all three presentations.
Okay, thank you. Thank you very much for your most informative summary of the three presentations. Just a few brief words. What we have just heard is at the heart of our delivery of major underground infrastructure for our peoples, and particularly here in India. And in the face of a national plan and strategic objectives for the extension of your major infrastructure here, this group of experts say it takes effort to understand the geology, and for that effort there will be reward. And as noted by Mr. Wagner, sometimes that effort identifies problems that turn out not to be problems at all. But in other cases, where problems are underestimated, the result is catastrophic, and as we've heard from several speakers, the project can't even be completed. That's why we're professionals. Our societies trust us to get that balance correct, and I hope in some way this discussion has informed all of you, and it's certainly us, on how we do our job better for our people, our countries, and for all of those who trust us with limited resources. Thank you, ladies and gentlemen, and I formally bring this session to a close.
I'd like to invite Shri S.K. Nirmal, Secretary General IRC, to kindly come up on the stage and felicitate the distinguished guests at the high table. The Chair, Professor Aaron Dix, President ITA, the Co-Chair, Shri R.K. Mehra, Vice President IRC and Secretary PWD MP, Dr. Dinesh Chandra, Ms. Lucy Rue, and Dr. Subhash Chandra. Thank you so much, sir. With this, we find ourselves at a conclusive end of the day. Having learned major issues regarding the agenda of the seminar and having found ourselves with many objectives and solutions for the same, we limit the day for the further proceedings, giving ourselves the time to refresh, understand, and comprehend the gravity of everything discussed and shared. I thank our honorable presenters to participate and vividly amplify the issue, and I extend my gratitude to the Chair and the Co-Chair for maintaining the flow of the procession with their utmost skill, excellence, and experience for the same. We congratulate everyone for their conclusive day and request everyone to retire for the day and refresh themselves with the cultural festives planned ahead, and the cultural program will be followed by the dinner. With this, I, Anya Jha, take your leave. Thank you so much.
Thank you. I have one announcement. In fact, our host, Government of Uttarakhand and Minister PWD, he has requested that he wants to have interaction with all our foreign guests, particularly from PARC ITA today. So at 7, already we have reached 7. This session has prolonged to the time of cultural program, so I requested them at least half an hour you give. So 7:30 he will be coming here for a small interaction with all our guests. So, and otherwise cultural program will start maybe in another 15-20 minutes. They're all ready, team is there. So you can have some, maybe those who can come back maybe in half an hour. So that kind of break is there. So 7:30 we will again have interaction with the Honorable PWD Minister, and cultural program will continue parallelly. Thank you.